for me at least, because they have all the mental construction already there.
Yeah, we came in, I mean, the whole CXL team was basically derived from the Optane team because it was, Type 3 was let's do
Yeah.
Type 3 first, let's get that up and running. We'll see how Type 2 goes. I've been wanting to do some Type 2 stuff, but
That's weird.
every time I do, it doesn't work out.
When you work on obtain this kind of CXL fabric in, was that mine? That kind of operation in
I
the.
don't really know because it was so far before CXL really came to fruition. Um, and CXL, I think more came out of our product group or our I don't really know their because Mahesh isn't really so
For me,
Mahesh is driving the spec a lot.
for me, CXL was a surprise because I knew about this kind of coherence thing with the GPU. Right? I thought the other standard, the CCX, was ahead. And then I went back to look at these Yamaha models and all that, and I thought, it's not there anymore. It's all
Well, and I think we absorbed. I don't know about CCIX, but I think of that name now.
Making progress on
But there was another standard
HPA,
that
SPA.
kind of absorbed the CXL.
Yeah, yeah.
You remember the conversation they had last year?
Open. No, no, that's not.
Yeah, so
Yeah, I can't
I'll
recall.
just say that we
But
did some beta tests yesterday. I got it on a platform. So let's see
CXL
whether or not it's in a perfect state to upstream. I think they're probably close to ours.
one.
You know what?
Whatever your definition
They got it
of
running.
win
It was
is.
both the memory. It didn't fall
I
over.
think it makes a lot of sense to have this.
Well, they have translation.
Yes, I
Yeah,
think
they
there's
make
a
it
lot
work.
of good use
So,
cases in the data center.
And they seem
Whether
to
it's
be
in the format
really
that will
keen
eventually go upstream. That's
to
all.
offer it. So that is the back. That's all this requires.
Yeah, exactly. Well, no. You have
So Stephen never turned up with a laptop. I was kind of assuming we'd have a laptop. And we can use mine. But
This is the new transparent model.
yeah. So the speakers now get to not see their slides for extra comedy.
Yep.
Apparently Stephen was running around distributing laptops, but hasn't got here yet.
Song was here a second ago. Let me,
Oh yeah, I'll use mine for now.
okay.
Which means you've got to take all the notes now. Oh, I have to get the other laptop out. Is there any power? And we'll also run out of battery halfway through. So, so we'll kick off in just a moment. Let me just maximize things here. Battery, yes. We've still got last few people coming in, so we'll let them grab some seats. There's room right in the front, just here. And you can move my bag out of the way if you need more seats. Okay, welcome to the CXL Micro Conference 2024. And how many years have we been doing this for? 3, 4? Some years. So anyway, first thing, important things. We need to thank our sponsors. I'm sure you've seen this slide a number of times, but yep, thank you to those sponsors. Second up, this is obviously very important, is the anti-harassment policy. I'm sure you all read it while registering, etc. So the basic principle of this is be civilized to each other. So yeah, if we get a little heated in some of the conversations, and I'm sure it's not going to happen around DCD. And no one ever gets heated about RAS. DCD maybe. But yeah, please keep it polite. So with that done, that was the intro session, so that was 5 whole minutes. I'll hand over to Ira, who's kicking off, and hopefully find the right slides for him. That looks to be you.
Close enough.
Yep, we can probably make it a little bit bigger so you can see.
Close enough for government work.
I think there's a full screen mode. There's the big exit button that we're not allowed to click. So tempting.
That's good.
Cool.
All right, how do I?
Left and right.
Okay.
If people could a few people could log into the BBB platform and help with the shared notes, that would be very handy. We'll use those to produce some sort of blog or record afterwards and then share them in the monthly call. If you don't know about the monthly call, talk to Dan.
Okay.
And then, yeah, over you.
Yeah, I'll reiterate that there's a monthly call, our Discord, and of course mailing lists, which we should all be familiar with. So, hi, I'm Ira Winey from Intel. Navneet should be on the call. He's also from Intel, and Jonathan has had a lot of input on DCD over the years, although I don't think he's going to speak today.
Not about this.
Not about this. Navneet, are you there?
Hey folks, good morning. Can you hear me?
Yes, we can hear you. Great. So I'm going to go over some of the current patch set that I've been pushing upstream for the last 2 years. Oh. You have something to...
We have it.
Okay, we're just making sure we have the cube to toss around. and discuss some of the things. We had a quick little BOF yesterday to discuss some of the tag handling and whatnot, which is significantly part of what my talk was going to be about. So I'm going to kind of quickly move through what we discussed yesterday, what the patch set status is right now. I really apologize. This should have been version 2, but right in the middle of sending version 2, my SMTP server conked out on me. Then I had some issues with V4, and eventually I just sent V3 because it just... And so anyway, the patch set is V3. So far the comments have been kind of mild, but we do have some changes that we want to make. Along with the kernel support, I've been developing the NDCTL support to support DCD, to be able to create regions, to see extents in those regions. And very importantly, I've mentioned a couple of times CXL tests. So we've been developing a lot of CXL tests and it's been very helpful. I can't stress enough how helpful it's been to basically be able to regress things as I make changes. As we've changed the architecture, we've been updating the tests to make sure that the semantics that we've discussed and changed over the years have been reflected in those tests. The QEMU support, thank you to Fan, who got that working, and Jonathan for getting it upstream. I do test a little bit with QEMU, but mainly for interrupt support, because that's the thing that CXL test just can't test. At the last discussion forum, the monthly meeting that Jonathan just mentioned, tag support was really important to a number of our users that are looking to use this. And so we had a discussion there, and that's why I focused my talk a little bit on that tag support and how we should go forward. And since V3, I went ahead and added QoS support after I submitted that patch set. So those the QoS parameters are also reflected in the regions, just like a regular CXL region is now. With that, though, the sysfs entries had to change slightly, so if people are using V3, just be aware that a sysfs change is going to be coming. Post V3. So yeah, so what's in V3 has kind of the old sysfs entries and then the new sysfs entries. So there's a little bit of change in the directory structure and the way extents are seen in the sysfs directory structure. So just want to make people aware of that. For me, I keep kind of advocating that DCD should not be system RAM. And then, of course, this morning on Discord, there was a little bit of a discussion. And so I'll kind of skip over this slide. But I really think that we need, as a community, to figure out for sure, how do we get memory on and offline for VMs, for all kinds of different user space applications where we want to be able to take that memory away. DCD is sort of hot plug, but I'm going to say it's hot plug light. And did you have a question or comment? We can throw that.
Right. I did a bit of experiment with some actual device and found that results I got make me question whether it's useful to treat it unconditional as system RAM. So primarily due to the latency of which unfortunately is good. Meaning it's in my test case it was even better than talking to the other NUMA node. Which makes it a bit unfortunate because it messes up all our algorithms which we have. I'd be fine if we had a higher latency, then we could clearly separate things out and say, right, okay, it has a higher latency, don't use it, fine. But if it has a lower latency, you end up moving device memory over to CXL and then having to, go via CXL to talk to the device. Good idea. So keep in mind, so whatever we design, it's heavily dependent on the latency of that beast, which we don't know yet, because that what I'm running with is pretty much experimental. But I suspect we, or others, will run into the same problem. So be aware of that.
I totally agree with you, but I think it's up to the admin and the policy of the user. If they want to online it as system memory because it is more performant, that's great. But if you do that, you will not be able to take it away. And for DCD in particular, where our use cases are memory's going to come and go, it's going to be very hard to take it away. And a number of our customers have been saying, oh, well, we want to online it as system memory, but you might not be able to take it away. So it kind of breaks the DCD use case.
Well, they just want to online it as a system memory because they have no other means talking to it. It's not necessary they want to use it as memory, they want to use it. But the only way they can use it is called malloc.
Well,
There's other ways.
yeah,
But that requires them to change their application and rather push the onus on us, let them do the work than me, right?
And so that is something we should, pass it forward.
Maybe like a show of hands of how many people have alternate to malloc-based memory allocation applications? Okay.
Not really the question. The question becomes, are people able to replace the memory allocator that's providing the malloc, which is a totally different thing. So you will still use malloc typically, but it'll be based on top of one of the, should we say, smarter allocators that's aware of these things.
One of the concerns is device DAX has been around for a long time. I'm not aware, we had PMDK, which was an allocator, like a J malloc allocator in front of that, so you could get your malloc semantics back. I'm just not aware of another project that's doing device DAX-backed memory allocation.
Right, and I'll be talking about FAMFS later, but it's a way of putting data sets in memory mapping them, accessing them directly, and
Yeah. Anyway, okay, I should have skipped that slide, but I think it's a hot topic, and I think it's something that going forward I would like to work on if I can just get this patch set and kind of the basic support at the driver level. Because if you look at the patch set right now, there's about 12 or so patches that are just getting the driver running, accessing the memory, surfacing extents, and there's a little bit there's like 3 or 4 patches in the DAX layer to kind of get that off the ground. And then test code. So anyway, extent handling, this is the current state. Every extent, whether it has a tag or not, and actually this is in flux because I just started changing it this morning, you can create a DAX device across those extents. The extents are just added capacity to the region, and they will continue to take as much memory as they need. And we really ignore tags. On our discussion yesterday, we really didn't like that. So we did have a couple of possible scenarios that I proposed in this slide, and I updated my slides this morning to cross out a couple of options because we discussed them yesterday. And so what we really want to do is right now in V4 now will be to just reject tags. The current support, base level support, will be no tags. It'll be basically regions will be created as non-tagged regions, and the extents will be surfaced. Any extent with a tag will be rejected as not supported yet. And so that'll create a semantic that our current regions, our current DAX devices are basically untagged. In future, when we create the ability to add a tag to our DAX device and specify we want this tag, we can then go on to this scenario where extent A, I've got a couple of scenarios here that don't work. So we want DAX device A is bigger than extent A, that fails. DAX device with tag Z, there is no tag Z, so that would fail. DAX device tag B is only allocated out of extent B. And so, once we get the support for DAX devices to be tagged, or if we have some other non-DAX thing, we'll need to come up with the ability to assign tags so that when you create this memory access to a tag, it will look for that tag and it will assign the memory out of those extents with that tag. Dan is giving me consternation looks. So yes.
Like the tag is on the extent.
The tag is on the extent.
Why do the association of extent to DAX device, the user should be able to say, yes, this DAX device is a single tag, this device is multi-tag. Like if the DAX region is in charge of allocating extents to DAX devices, and we have a user interface for that. If the user wants to mix multiple tags in a DAX device, why would we stop them? Like, why are we rejecting people's usable capacity?
Well, yeah, because of him.
So if a tag is a namespace to memory,
It's just a number.
I know, but that's how we're going to use it. I mean, that's what we put it there for. And so the reason you can have more than one extent with the same tag is because you might not have been able to allocate that memory contiguous. And so, and Andy Rudolph and I put this in here, the extents that are tagged have a mandatory sequence number so that you have to map them in order, because you do have to map them in order if it's a shareable thing, right?
Well, yeah.
I thought the mandate was only if it's shareable, like where it actually matters. The ordering doesn't matter if it's not shared, right?
Right, and the tag field is reserved, or sorry, the sequence number field is reserved if it's not shareable. I argued it should be sequenced anyway, but, but tags are a namespace to specific memory, so.
So that's the semantic we're going to go on. Okay, so I was a little bit in your camp. That's the way V3 is that a untagged DAX device is basically give me any memory. But that does have some semantic issues with, and maybe we will need to do something where we can create a DAX device that is generic. Like, how do I say this? There might be a difference between a zero tag device and an untagged device, although implementation wise that's going to be difficult to discern. But so in my mind, I was kind of in the camp of, an untagged DAX device just gets memory from anywhere. We've got another comment back there. And
I think for the shared case, we have to be able to restrict the allocations in either case, because otherwise we're running into a starvation issue. If it's shared, we do have two independent actors trying to allocate memory, and we really do want to avoid one being starved, come what may. So in the shared, at the very least in the shared case, we need to be able to restrict one and say, no, you can't, the other has to, whatever. Has
Right.
also had to have a chance to do it. So
Right. So no matter what, an enhancement on top of this patch set is going to be to have to allocate a tag to a DAX device so that that DAX device can be matched up only with those extents.
Only if it's shared. I mean, it makes sense if it's shared because you have to, but if you don't have to, then why restrict things?
Because the user asked for it. If the user says, I want this DAX device to only be allocated from these tags, I'll do that, right? But you're advocating if we don't have a tag, if we don't assign a tag to a DAX device, it just gets memory from anywhere.
An example of memory for a purpose would be memory that was allocated to be the backing memory for a VM. And so that's for a purpose. I tagged it so that my orchestrated environment knows what memory the VM should be backed by. And then it's got to show up as one DAX device.
We probably need a wildcard tag that could say, that we could say allocate from anywhere. But I think I think it just came into my head. So like tag 0 is maybe like untagged, and V3, and then maybe we do a wildcard tag in the future where maybe people are surfacing tags, but they have some use case where they don't really need to lock it down to any particular use case. But
Is the tag, well, we should move on, but is the tag enumerable from the extent?
what do you mean, seen
Yeah.
in user space? Yes, absolutely. Yeah, absolutely.
I mean, the other way to look at this is
I want this to all be user space policy. It's just the kernel has to honor, we have to make the right levers. But user space is going to handle all of the policy here, absolutely.
The other thing is what we need to be very careful of is that we don't restrict something we enable initially. So if it turns out that we do need to ensure that different tags are not used in the same DAX device for use cases, we can't do that retrospectively. So we're better off being too restrictive initially, sitting back, thinking about it a little bit, and once we've got tag capacity in there, then thinking, oh, okay, yeah, it does make sense to
Right.
generalize it rather than
And so
whisking
kind
it
of
around.
define current DAX devices as tag 0.
Yeah.
And then if in the future we want to wildcard them, I think we could define like all Fs as, wildcard tag, allocate from anywhere. And that's another reserve tag. Maybe we, reserve, tag 0 is reserved now, kind of in the spec, but yeah. Okay, so that took a little bit longer than I expected. Let's see here. Navneet, do you want to, I know there's some folks that want to talk about Fabric Manager, Orchestrator, so I was going to let Navneet discuss that a little bit.
Thanks, Hiro. So this slide is more specific to DCD as a product point of view, where we have the orchestrator, we have fabric managers, some sort of daemon service, like we can call it as the orchestrator or the host agent on the host. So to communicate to each other in adding the or releasing the memory, right? So if you see the figure on the right hand side, right, this is the basic flow of the DCD. We have a CXL fabric manager talking to the CXL memory. There's a predefined, I would say, well-defined interface to add and release the memory, right? And then we all aware of how memory has been, has been populated in the host as extent, right? But the main problem here is we have been doing this whole allocation using some of the scripts from the fabric manager, right? But when we see things from a bigger scheme of things, right, we need some sort of orchestrator or the host agent on the host who can talk to which can talk to orchestrator, and also we need some sort of plugin in the orchestrator which can talk to fabric manager, right? So let's say we have a host and we are running some workload, we are running out of memory, or they.
Navneet, did we lose you? What? How?
Hey, can you hear me?
Yeah. I didn't touch anything. Stand back here.
Okay, I don't know till where you have heard me, but let me start again. Okay, so
Go ahead.
shall I resume?
Yeah, no, continue.
Okay. So, as I've mentioned that there's a well-defined interfaces between the CXL Fabric Manager and the CXL memory to initiate the add and release memory. And also, we have the driver implemented to surface this memory as an extent. But the onus lies to the user to create the DCD region, to add the extent as a DevText device. When it is not required, destroy it, right? So in the bigger scheme of things, right, we need some sort of orchestrator or the host agent or the on the host, which can basically detect the memory pressure, or if there's no memory pressure, then it can talk to the orchestrator to add and release the memory, right? So let's say if we have a workload which is running on the host, and there's a memory pressure on the host, and there's a need of additional memory, which is elastic memory from the pool, then this host agent can talk to the orchestrator and say that, yeah, I need X amount of memory, right? So some sort of service or daemon is required to do particularly do the things, right? Detect the memory pressure. Who can decide whether we can create one extent per DAX or multiple extent per DAX, right? If it is a shared, then generate the tag, communicate to the orchestrator that, please request the memory with this tag, right? It can also create the mapping, I would say, create the DCD regions and set the right set of interleaving configurations and so on, right? And when it comes to the orchestrator, right, because CXL memory fabric manager can be implemented as a redfish, or maybe some other way. So there's some sort of interface required in the orchestrator to talk to Fabric Manager, and it can use that interface to raise the request for the for to add or release the memory, right? So so basically, if we see a bigger scheme of things where we have multiple hosts connected to the memory pool, these are the missing pieces of software, right, that we need to stitch to get the whole this functionality as a product point of view.
We should be careful trying not to overthink here, because the experience shows reconfiguring a host is an event which, well, at least with our customers, doesn't happen that often. One could even say it does not happen at all. There's the classic example of the HP Superdome back in them days, which was fully reconfigurable on the fly. You could do everything you could think of with that thing on the fly. The next release, they turned off completely. No one was using it. Point is that for these kind of applications or these kind of things, it doesn't come cheap. So you won't find them in your user, whatever handheld devices, laptop, you name it. It will be primarily in the enterprise. And in the enterprise, you buy the systems designed for that specific task. You lay out prior, this is the task I'm running, I need this and this and this, whatever capacity, memory, you name it, by the system designed for that task. Full stop. You're not going to if you were to redesign it, it's not that often.
Yeah, I tend to agree with you, but I do feel
so that's one thing. The other one is if you start doing a dynamic feedback loop, please give me more memory and so on and so forth. You're not the only one. You will be competing with others to having the very same feedback loop. So again, there might be a chance you will not get your memory.
Right.
Which means, right, where's the difference for not getting the memory initially? Not that much, because we can't be sure. So shouldn't we rather concentrate on getting the things off the ground first, having some offline interface via Redfish, get it stabilized, and then worry whether we can implement a feedback loop?
Agreed for the feedback loop. Absolutely. Navneet, did you get that?
Right.
So as somebody who
one more question.
well, I want to just respond to as someone who worked at HP on Superdome, I have perhaps a little bit of insight into this, which is that customers did not trust the ability of Superdome to be reconfigured, and we asked them why, and they said, when your service engineers start believing in it, we'll start believing in it.
Okay.
No comment from that. But what I do want to say is that I think the reconfigurability that we do see today is very much in virtualized environments.
Right.
And so if customers are going to start treating this kind of physical environment like it's a virtualized environment in terms of, we'll squeeze this machine down to its minimum configuration and then we'll expand it when demand increases, then maybe we'll start to see this. But I think that's much more a thing for virtual environments. It's not so much a thing for physical environments. Maybe that will change. I don't personally see it. I think you're right. I think the vast majority are going to set it, configure it, leave it alone.
I think it's a matter of cost, though. I think we're seeing more customers in the data center who want to be able to dynamically adjust their memory in their machines across their data center.
So one of the classic use cases.
Okay, and I think you're right about the feedback loop and the automation there, where we need to crawl before we run. Totally agree with that. So actually, I was going to ask: are there anybody working on a user space host to manage this stuff? I know there's Fabric Manager people, but is anybody looking at the actual interfaces that I'm implementing? You, maybe a little. Okay, so almost nobody raised their hand, so somebody probably at some company, hopefully. All right, well.
Someone at some company is working on it for investment.
Okay. Go ahead, Navneet.
I think the main question comes here is on the orchestrator side, if anybody has started looking into the interfaces to the Fabric Manager.
I think there have been people who are working on the orchestrator fabric manager, right? Okay. Okay. And are you all on the mailing list? I mean, this is, I mean, even though it's user space, you know, the mailing list doesn't have to be only for the kernel. We have, you know, our utilities and other things, QEMU discussions. So, you know, if you want to fire that up and get in touch with Navneet and start to talk about these things, we'd love to hear that feedback. Okay? I think my watch keeps.
Over to you, Ida.
Actually, I think we're out of time. Oh.
We left a bit of time, maybe 5 more minutes.
Okay, we got 5 more minutes. Did you want to wrap up, Navneet?
That's all from my side. Thanks, folks.
Okay, cool. Yeah, I think we should continue this discussion, you know, on our communication channels, because it is a system, and I'm just trying to get one piece of the system done. So future support, I already did the QoS stuff. Navneet has been working on interleaving a little bit, but we've kind of deprioritized that again to just get the basic support in. Mapping a tag extents, we've talked about that. Splitting and merging extents, I don't think that's ever going to get done. I kind of added it here because we've discussed it in the past as a future task. I don't hear anybody saying they really want to be able to see the kernel be able to split an extent or merge extents. Correct. Right. So it. Agreed. So the comment was that we kind of already split extents and through the ability to have a single tag with sequence numbers, we can have multiple extents that are already really part of the same unit. And more importantly, we have our DAX layer that we can then combine or use part of extents all we want. So even though the spec allows you to allocate extents down to a very, as John said, you know, like very, very small unit that's almost unusable, we're not really going to support that. I mean, the kernel will honor it if an extent is, if a small extent is surfaced, but we're not going to try to combine it into bigger extents or split big extents into little extents. And then we have been throwing around the idea of doing something a little bit different than DAX devices. Kind of gets back into whether we should online a system memory or not. And so I need to explore those options a little bit more and understand them better once I get the basic support done. Okay, that's okay.
If at all possible, we should stick to the existing DAX device in the infrastructure.
Okay.
Because while it wasn't perfect, I'd be the first to admit, and the hardware was crap, there are customers.
Just take it, Dan. Just accept it.
Why do you laugh if I say there are customers? Anyway, so, and who happens to have been using the existing interface, for good or worse. Which means, sorry?
Yeah. Customers here. Right. We have customers here.
Do you have customers? Right. No, none of those are here. I'm pretty sure of that. So, and if we were sticking to the existing interface, they could just use the existing framework which they have, and it would work with CXL. That will make the adoption of CXL far easier for everyone involved, because they will only have to have, well, very little tweaks to the application to get it off the ground with CXL. We can stick to the existing interface, or can just whatever, malleable the interface to do whatever it's needed there, so the adoption will be far easier. If we now start to move things around and do things differently, people will have to change the application, doing that, thereby delaying the adoption, or even at worst saying, oh, you know what, DAX was crap, we are not going to invest in that one because you mess up again.
Right, and that's why I'm targeting DAX initially. But to get back to your earlier comments, We do kind of need a better way to be able to online system memory and offline system memory. And so that is a much harder problem to solve. But I think that going forward, we can probably do better. And I don't want, okay, I've got a stop sign. Okay, we're done. But last comment.
Why do you say that onlining system RAM is a harder problem? We already have memory hot plug.
Because hot plug isn't a guarantee to be able to release. It might work, but what we're looking with DCD use cases is it must work. We must be able to take the memory back.
People that can't get the memory back, that's it.
Yeah.
Dan said that just tell people they can't get their memory back, that's it.
Well, that's what I'm telling them if they online it as system memory is you're not going to get it back. So please don't do that, which was the other slide that was controversial. So anyway. Okay, well, thank you.
So one thing we did when organizing this micro conference is we took a number of sessions and proposals that we had that were very, very similar and basically smashed them together. So this next one is an example of that. Let me just, there's my mouse. And it's the right one. Over to you.
That's the next one.
Yeah, it's just the right arrow.
Okay, I'm Robert Richter. This presentation is done by Terry and me. He's also in the audience. We are working at AMD on CXL. There's a second part here, which is done by Srini from Micron. It's about RAS page offlining. There are lots of slides on RAS, and I want to go quickly through it, and we'll also skip some content here to, because we are short on time. So CXL RAS, the specification has a couple of features included. There's first error handling for various protocols, link and protocol errors, device errors. Then there is CXL error injection, poison and viral handling is offered, and there are maintenance event records and commands also available, which are available through the CXL mailbox. And there's also CXL error isolation. The main topic here is on CXL error handling, but some of the features are related to each other. Okay. So CXL error handling, we have link and protocol errors here, which are using mainly PCI AER. We need to consider two modes here. I will talk on this a little later. When there's the device errors using the event logging facility, the mailbox driver of a device or of a component. And a third part here is firmware error reporting. There has been some CXL extensions to ACPI as well, which also needed to be implemented in the kernel. So link and protocol errors. There's a variety of things that need to be considered and implemented. We have a number of components involved with the two modes that are available. We have a restricted mode and VH mode. So the restricted mode offers the RCH downstream port and upstream ports, and then there's the restricted CXL device, which is showing up as a boot complex integrated endpoint. And in VH mode, all the CXL components are visible through the PCI hierarchy, which are the root ports, downstream switch and upstream ports, and the endpoint also as a PCI device. The protocol types supported are CXL IO and CXL cache mem, which is covering the cache and mem protocol. And there are a lot of register blocks that need to be inspected when an error happens. The first one is the error space or registers which are in the PCIe configuration space. Then there is also the DVSec block for the CXL devices and ports, also in the PCIe config space. And additionally, there's the CXL RAS capability, which is the CXL cache mem block in the MMIO space, and this is available for all the components except the host bridge. And all this is using PCI AER, and in the end the kernel generates trace points, and there will be another talk later on EDAC integration, so it could possibly later or in future also be forwarded to the EDAC subsystem. A few words on AER. So this is the mechanism used for error handling for CXL. All CXL components need to support AER. The I/O errors are logged through the AER extended capability, and the cache mem is using correctable and uncorrectable internal AER errors. And once this error triggers, then the CXL RAS capability need to be inspected. There is one challenge in the implementation we discussed yesterday in the PCIe session already, which is the port driver implementation for CXL error handling. We do need basically a custom port driver to further handle the CXL specifics. But the good thing is PCI AER basically exists in the kernel already. There are a few
Sorry,
extensions.
Robert. Just to ask a quick question. So for the custom port driver there, how much do we need? Wait, I mean, what's actually needed for that?
Yeah, if an interrupt triggers, then we need to look up the CXL RAS capability, and for that we need to do the mapping between the device and the CXL RAS capability. So, and this is only available in the CXL stack.
Okay. Yeah, that needs some thought.
Okay, for restricted mode, the thing is, or AER need to be slightly extended here, because the devices do not show up in PCI hierarchy. We have, there's the special RCRB, root complex register block, where the AER registers are in, and also the RAS capabilities are not mapped through the PCIe member 0, but using the member 0 in the register block. And the notification is done through the event collector. So for restricted CXL devices, we need the RCEC implementation here too. So what's done in the kernel? The AER handling, CXL AER handling and of correctable errors has been extended in 6.2 along with the RAS capability and trace point support. In 6.3 there was error unmasking to enable the intermaps for the RAS capabilities, and restricted mode for downstream ports were implemented or added to 6.5 and 6.7. And there's patch set posted by Terry on port device support for ports in VH mode. Device errors. The device may report poison viral, non-memory errors, which is the last section that I talked about, Lincoln protocol errors, and memory errors. The memory errors itself is using the CXL specifics of event logging and signaling. That means for errors, the general event logs is used, and the notifications using the MSIX device interrupt. So event logging not only uses error handling, but also there is an interface here for the mailbox. The errors or the events are used for reporting errors and also for requests and responses between CXL components, which is used in DCD also. So the membox commands, there are access membox commands to read the event log, and the status here that all kinds of events are supported in the kernel and accessed. Whereas DCD support ongoing, but no physical switch support yet. What went into the kernel in 5.16, there was very early the mailbox support added. When 6.3, we had the event logging, including interrupt support. There is an extension for poison list, list and injection. In 6.4, 6L background command execution for the event log was implemented in 6.5, and in 6.10 the IO control of the mailbox commands has been extended to also support error handling or the error commands. Firmware support. This is ACPI using the CPR records has been added and GHAS sources. For the records, we have support for all the agents that are available in both modes. The error record includes basically the AR configuration space that is part of the AR error or GS CPR error record. There is also the DVSec space available and the CXL RAS capability, which is coming from firmware then. And for the components, we have the record was extended to use or to also include the event record as specified in the CXL specification. In addition, we need operating system capability handling for firmware, basically to enable the OS first mode. So there are also some changes, there has been also some changes needed in the kernel, and then also same here, same for OS first kernel trace point support to have report the errors to the kernel. So here are the achievements. First, the OSC support finally in 6.7, when CPR event decoding in the ACPI driver in 6.2. Error injection has been added in 6.9, and CPR CXL driver support in 6.8 and 6.10. Poison and...
Robert, sorry, before we move on, a really basic question on the error testing thing is, also the error reporting side of things is, how easy is it to test? Because should we say error injection platforms are usually a pain in the backside?
Yeah, there are some sort of injections possible, but not always implemented. Dari, do you have something here to add?
So, a job for Morrow here.
And I think also in QEMU there's some support of error injection.
Yeah, what I did with some of the CPR stuff is I literally just hacked something into debug.fs and then didn't submit the patch for that. So
over there.
I think it's worth calling out, mainly because he's sat there. Very briefly, sorry. We do have some work that Morrow's taken over where we're trying to add to QEMU the ability to inject pretty much any error through the ACPI pods. We haven't yet. I actually dropped the CXL support for that because it was changing too quickly, but we'll bring that back. But for now, it's getting the basic infrastructure in place, but it's going fairly well. So that should solve that problem. Ooh, he was fast. My throwing's terrible.
So two things. So for error reporting and how well it works, in practice, I found that any cache errors are pretty self-evident when the machine checks and throws some really bizarre errors out of the CPUs. Question about the firmware though. So on like the vendor side, how many vendors are you aware of that have signed up for this type of ACPI support? Because in my experience with certain vendors that will be unnamed, their CXL support in ACPI is leaving a lot to be desired, where there's like flat out problems with mapping devices, and Dan knows a little bit about this, but where it's just flat out broken.
Yeah, well, I at least know one vendor, so. But
fair enough. I mean, we have one big vendor that just is just broken, and then other vendors that are like, hold my whatever and watch this, and then they can fix it. So
at least anything can fix in firmware somehow.
So, I guess it not so much depends on the vendor, but also to the eventual distributor, like hardware vendor, HP or you name it, because these are those who tend to be very insistent on firmware first modes on the grounds that they have their management agent, BMC, you name it, and want to see everything. Those hardware vendors currently implementing that stuff are not that chuffed about it because, well, they don't have BMCs as such. And so they're not that worried and do whatever they've been told. I guess the real push will be coming once the system go live on real hardware, and then we'll see a push for that.
Thank you. Back to the error injection question. Of course, a lot of that is platform dependent, using, like, for instance, the EINJ module. But we also have a recent upstream patch that adds injection support using the sysfs files. Now, I don't know how complete it is for different components, but it's a good start such that it'll be independent of the platform. And should work for QEMU as well, is what I would expect. I can. No, actually, Ben on our team upstream that was for the error isolation in order to take down the upstream port. I'm sorry, the downstream port.
And then I'm also aware that there's a compliance DOE in the spec, but I'm not aware of anybody having enabled the enabling for that. But you can inject errors via that, I know, but I'm not aware of any tools for that.
Yeah,
You can inject a very, very small subset of stuff. That thing is not super useful. We do, in theory, have QEMU support for it. In practice, it's not wired up to do anything. It just fakes it.
Which tool is that?
This is the compliance DOE. But I think the idea is that no one will ship a part with the compliance DOE turned on. So unless you can get a prototype, well, I guess maybe we can get prototypes. But
Okay, so I'm not sure if you know me, but I'm the author of RAS Daemon and one of the RAS reviewers. So, and we've been doing this work, as Jonathan mentioned, on QEMU. The idea is that we are adding a script that can inject any kind of CPR record. So it can even be used to generate fuzzy testing. And with that, we can inject not only CXL, but also other kinds of errors, and even try to crack the kernel by injecting some defector packages there. So maybe it would be interesting if you could take a look on our work, and it could be helpful to check the development.
Thanks.
Flying cubes.
But
I need that.
But back to your question about vendors and their various firmware first support. I mean, my entire idea with CXL is that the kernel would eventually obviate the need. Like, yes, we can interoperate the firmware first, but the kernel can supplement when firmware first is not there. I think I've seen people saying, "Oh no, we need firmware first." I mean, so if it's there, great. But if it's not, Linux should fill the gap.
Yeah, there's OC support to enable OS first.
The kernel rules all.
Okay. Yeah, we need to hurry up because 17 minutes already. So poison and viral, basically there's just only one thing that needs to be added here, which is a media poison and management mailbox command. Everything else is handled through the generic memory management system. And, oh, I'm sorry, I was on the wrong slide. So for poison and viral, and for Yeah, CXL isolation, we have this posted patch set from Ben, but that needs a user. And that's all on our handling. So, Srini, are you there? I hope he is. Can you try to speak? We cannot hear you.
Okay, now am I audible?
Yeah. Thank you. I will skip.
Yeah, thank you. Sorry, was there a question?
Yeah, I will handle the. Let me know when I need to switch slides.
Sure. Firstly, thank you, Robert and Jonathan, for helping me in the merge of the PPT. Can we go to the first slide, the next slide? Yeah, so the agenda is like how is the device fault domains or the error sources and error coverage, error reporting specific to DRAM events, which is specific to this page offline. And we have this PFA, breakthrough failure analysis algorithm, implemented in RASDemon, and this is already kind of offloaded in the CXL Type 3 devices as a part of advanced CVME, and which can leverage to do page offline. That is overview of what we are going to discuss. Can we go to next slide, please? Yeah, so typically these are the fault domains on a CXL link. Either we'll have CXL link faults and the memory faults. The area of the primary focus would be for this discussion is memory faults. Memory faults including data single bit, row bit, different like row, bank, and device specific. Can we go to next slide, please? Yes, so here I want to spend a bit of time. So the errors from the memory, broadly categorized or broadly of these or these primarily most happening is single bit error, which can be recovered using ECC, demand scrub, and petrol scrub. And there are cases like even if it is corrected by ECC, it can be persistent. Then we can use page offlining and row failures, bank failures, device single bit failure. And the last one is like, you have a device failure, a multi-device failure, which we need a hard page offlining. From top to bottom, the occurrence of errors, the probability is less. At the top row, it is more probability compared to the bottom row. Can we go to next slide, please? So this is an existing, CXL error reporting that we have. A type 3 device would log the errors into a logging, and then it triggers the interrupt to the OS, and OS will create a trace events for that, and the user space applications can leverage these trace events. And so far, what we have for DRAM events is reporting for the DRAM event. So there is lacking of acting on the error. That's where this what we are proposing can help. Can we move to next slide, please? So yeah. So this is what I was talking about, the predictive failure analysis algorithm that we have in the RASDemon, and similar we have in the CXL spec, advanced CVME we call section 829. We have this advanced CVME. What it does is that the device, type 2 device, can have the thresholds being configured, and the time and the refresh cycles, and based on that after these many events within the device, it can trigger the event to the OS. what we are trying to do here is like we are segregating the events and reporting to the operating system at once. So that is advanced EME / PFA. Can we go to next slide, please? So here, what we what we can leverage is like we have a DVRM event when we get a CE, the correctable errors. For that CE, we have a physical address associated, and from the device address to host address, the mapping being done, and we have the mapping in the Linux kernel itself, and we already having that being exposed to the as a trace event. So now we have the HPA at the user space level for the given record. With that HPA, what we can do a page offline in RAS daemon. And we also need one more input is whether this threshold has been triggered or not. If there is no threshold or if there is no support in the advanced CME, this similar thing can be done using EDAC. But here the advantage of having thresholds is the device has more knowledge of the errors and it can be more accurate, rather than doing it in the software and having some thresholds. Can we move to next slide, please? So yeah, so once we get see whatever the first 4 points which is already exist, and this is one what we want to have it in the RAS daemon, and also at the end I want to propose some interface in the Linux also to make it easy. So once the CE threshold set, and if it has a corrected error, what we do is in the RAS daemon we'll try to indicate that it requires a page offline. Based on the configuration in RAS daemon, it can be a soft offline or a hard page offline. Can we go to next slide, please? So this is algo, what we can add. These are the we are getting the HPA from the trace and having a record of it, and we are storing it for persistent record, and also we are reporting instantly. Apart from that, what we are looking at is whether this is an corrected error and if the threshold is met. And instantly, what we are trying to do is in the last line, we are instantly indicating that this is a good candidate, or this address can be page offline. Any questions so far?
We've got a minute or two for a couple of questions, I think. So, I think that's your final slide, is it?
Yeah.
Yeah, thought so.
Yes. Yep.
So we had this concern about whether RAS daemon should grow support for native CXL error records, or whether the CXL driver should be translating memory events into the existing memory error records that RAS daemon already understands. Is there a benefit either way? One of them actually pushes the problem to user space.
From RAS daemon point of view, it doesn't really matter if this is a hardware first or a firmware first event. It can handle both cases. In the case, we actually use traces to get the event there as a RAS daemon. So whatever it is input, it can be handled the same way internally there. So
I think one thing here is that some of the information can be a lot richer than goes through the normal algorithm. So for some of this predictive stuff, if you aren't doing it on the hardware, you want to push as much information as possible up to whatever algorithm's running.
So one question, how complex would be for the kernel to notify the device that a certain range of addresses has been offline?
So we have an interface. Yeah, there is an echo. So we have sysfs interface to indicate the soft offline and page offline. RAS daemon is currently using those interfaces. For RAS daemon, you just require what HPA that need to be offline.
The point is the best is to warn user space, because then you can have your policies on user space and not on the kernel space. So if you do an internal loop at the kernel for it, for example, to offload some pages, it means that you are actually placing your business decisions at the kernel. It's usually not something that we would want to do.
I think what Dano was asking was slightly different, which was more that when we've done the offline,
Yeah.
Tell the hardware.
Doesn't know anything
What?
about offline.
Why does the device care?
The device can optimize some media management operations.
Okay.
Or,
So stuff that's kind of lighter weight than, say, PPR or sparing, but some...
avoid sparing if a page has been offline or a set of addresses has been offline.
Okay.
That's an
Yeah.
optimization process.
I mean,
I was thinking sparing,
yeah, I mean, it's easy to do.
so you could actually fix the page.
Well, we have the slight snag. I don't think there's a hardware-defined interface to do it yet.
No.
So those of us who are in the consortium may see one shortly.
Yeah.
Just do it in a driver.
Yeah.
Well, we still need an interface to tell the hardware. If it's useful to the hardware to optimize its information that's easy to squirt down. Yeah.
Yeah, but do it code first.
Well, yeah. So I should have added that at the beginning, that we won't discuss anything that's been discussed in the standards organization. However, this has not been discussed in the standards organization, so we can merrily talk about it.
And now that we have talked about it, we can continue to talk about it, even if the consortium talks about it.
Absolutely. Well, yeah, as long as we don't convey any information. But yes, we haven't had to call that out yet today, but I will stop people if they do verge into that stuff.
Right.
But so far, we haven't. So thank you very much.
Yeah. Thank you.
Yeah. Just otherwise I'm holding it in the wrong place. Okay. No. Everyone loves RAS, so we got some more RAS. So this was another one where we smashed it together. In this occasion, Shiju, who's online, myself, and Mandana, who's going to kick things off. It's the right button to...
Hello everyone, myself is Vandana Salve. I'm from Micron, working on CXL software architecture. And today, along with Shiju and Jonathan, I'll start with an introduction with the things that is to be covered in this session. Typically, the goal is to cover the RAS control features as such. So when we say the RAS control feature, what particularly it refers to is configuration, control, and the capabilities that is to be exposed to the management agent as such. And typically here, so here in this case, we'll discuss what are these RAS features and why they are to be in kernel and the different use cases. And to summarize the RAS control features that are to be covered as the petrol scrub, error check scrubbing, memory sparing, and PPR functionality as such, and the control threshold as such. So particularly when we starting with the ECS, is ECS using the ECC error correcting code allows the DRAM to internally read and do the correction, single bit correction, and write back to the memory, and providing the error counters as such. And basically, the flow goes through. It provides the configurations, allows the configurations with various parameters as ACS threshold, the counters, and reset counters, and the mode of operations as such. And also it provides the ACS logs, so the host can collect the results of this ACS parameters. And petrol scrubbing, basically ECS handles the correctable errors, whereas petrol scrub mechanism also handles correctable as well as uncorrectable errors, and it provides through the various configurations through the host, such as whether this petrol scrub is enabled or not, or whether how the petrol scrub cycle can be changed or not, what should be the petrol scrub cycle cycle value and and what would be the smallest number of the petrol scrub cycle as such. So those are configurations that can be controlled by the petrol scrub as such. And when the number of events when the number of errors exceeds a particular threshold value through the petrol scrub, it generates the event record. Typically, it has been passed through the DRAM event record or the media event record as such. And particularly the actions, as like the discussion will be continued later on with Jonathan, like what appropriate actions can be taken from the admin side, like using the RAS daemon. The appropriate action would be to trigger the page offline on those event records as such. And going back onto the memory sparing and PPR. PPR is basically the post-package repair. It's for the repair operation whenever the error happens as such. And it was a feature introduced in 3.0 specification as such. And basically it works for repairing on a row sparing happens as such. Whereas the more generic definition is evolved in 3.1 for the memory sparing, where it provides a more modes of operation, like not limited to row sparing, but the cache line sparing, bank level, rank level as such. And so yeah, these are the ones, and then the error reporting can be done through the various threshold counters as such. So these are, and one more feature that I was planning to talk, but due to limitation, was the memory reduction. That was the enhancements to 2.0 specification. Basically, it is like whenever the error occurs and if the system identifies that the memory can be taken offline altogether. Instead of that, through this memory degradation, it can report that the memory has been degraded, and accordingly the system firmware can update the size and report back so that the memory can still be used as such. Okay, so next I would hand over to Jonathan to continue on this discussion. Thank you.
Thank you very much. Okay, so now we're going to move on to what we proposed as initially a separate subsystem, but since then it's become enhancements to the existing EDAC subsystem to control all this stuff. And yeah, one of the opening questions is, why do we do this in kernel at all? We could push it all to user space. We could just have mailbox commands for this. However, there are some of these features that are not safe. One particular one is PPR. So for PPR, there are devices that will implement it so that you can do it safely on memory that's in use, and there are devices where you can't. If you attempt to do so, you get to pick up the pieces because the memory just disappeared underneath you briefly. There are some devices where you have to create all traffic to the device while you're doing it. Hopefully no one builds those ones, but we do need to support them. The other aspect of this is if we push things down into the kernel, it does allow us an option to generalize. We're talking today about mainly the CXL features that support these things, but there are others. We actually, very first time we proposed this, it was only with ACPI RAS2, which provides scrub interfaces. And the reason for that was that the CXL spec hadn't been published yet with the features, because this was pre 3.0. So when we originally proposed this topic, the patch set has been through quite a lot of versions. I think we're on version 12. We were having some challenges in getting reasonable feedback on it, whereas actually that, in the meantime, has been reasonably resolved. We've had a lot of good feedback from some of the RAS maintainers and EDAC maintainers. So things are actually ticking along reasonably well. So now I think the focus should be a little bit more on what are we missing, what enhancements are needed, any questions people have about the topic. So yeah, why EDAC? Well, it's kind of where the related stuff is. This is more a grouping topic as much as anything. It's bring everything together, enhance existing interfaces. Yeah, EDAC is unusual. It's been around a while. Let's say it's mature. As a result, it uses the Linux device model in a somewhat novel fashion. You only have, I think, 2 devices. You have one called MEM that covers all memory, and one called PCI that covers all PCI. Under which you have a whole load of child directories with stuff in. What we wanted to do while doing this was move to a much more conventional sort of, well, it's a bus as a class. So because EDAC's a bus, we're going to do it that way, but it could just as easily be a sysfs class. And that means that we end up with separate devices. The strategy at the moment is to do a device per kind of instance of the thing that we are controlling on. Now, for CXL, sometimes the feature makes sense to control at the level of an individual physical device. Sometimes it makes sense to control alongside the region. So if we mounted it and we got DAX on top of it, etc., it may make sense to associate it with that. It may not. So some of these features you'll see in both places. So if we've got scrub control, for instance, the reason you do it on the device side is that actually you quite often want to know if you've got a problem before you turn the device on and start using it. So a classic thing to do is to scrub on the devices you're not using, because then what you will see is if they've got a bit of a failure rate, you'll get some idea of what it is, and you may elect to not use that device. However, you also want to scrub when live, so you want to associate it with a region, which might be across a whole load of interleaved devices. So the idea here is that basically you get whatever the most frequent scrub anyone's requested is. So yeah, you write to either the region one or the device one, and then we match whatever's requested, and you will report it back through the other interface. It's a little clunky because you've got two interfaces to the same thing, but it at least means that both those use cases are covered.
So if you scrub a device that's online under a region, that still works? It's just going to happen underneath? Okay.
Yeah.
All right.
If you've requested a higher scrub rate for the region, we'll respect that.
And I presume that you are going to have DPA reporting for one and HPA for the other kind of thing?
The reporting is actually, for this stuff, is just going to be via the normal error reporting part.
Okay, but like
for control.
Is it going to be address-based scrubbing, or is this going to be scrub device, like, or like?
For CXL at the moment, it's just scrub device.
Okay.
There isn't, the spec I think doesn't allow for more detail. Actually, the ACPI REST2 thing does. So there we may have on-demand scrub of particular regions. You want some differentiated reliability. You've got some region with really important memory in it. So we're going to use higher scrub rate on that and lower elsewhere.
And when you say region, are you talking about the device partitions or
no
CXL region?
Yes.
Okay.
So this is purely the region bit. You could move this all to user space. You could figure out where they are and control down to the underlying devices or not.
Here we are talking about a bus for CXL stuff, but what about the normal memory? Are you also planning to have a separate bus for that, or what are you thinking about?
Yeah, no, this is all on the EDAP bus. You can see there that we have a third entry, which is ACPI REST2. And that's representing the normal memory, assuming it's using that particular ACPI interface. We only have one vendor that we're aware is actually using that today. A number of others have evaluated it. Should we say that spec has problems? One of the absolute classics is it doesn't define the units. So you can control scrub, but you've no idea what the multiplier is. So that will hopefully get fixed, and we will update the code to support that. But today, yeah, these little details that sneak through. But it is in use, and we have had, there were complexities around that to do with, it's supposed to be per NUMA node. The control, you're supposed to have you basically pick which NUMA node it is. But there are people who've implemented the mailbox, so there is only one across the whole system. So you can end up trampling on each instance, trampling on the other ones. So you have to be a little bit careful. So we've got a few quirks in there from what the spec actually says.
Yeah, at least for me, splitting this per NUMA node or per memory controller actually would make sense.
Yes.
Because they may have differences and...
oh, absolutely, yeah.
Yeah.
I mean, the intent here is to push the figuring out which memory you're actually controlling to sort of the next layer up. So we do that from REST daemon. So this is just exposing all of the information you need to figure that out. In many cases, a CXL region is going to correspond to a NUMA node, but you can have multiple regions for reasons of how you set the thing up. And you still want to be able to control them separately. So, yeah. I mean, it's possible we'll end up with yet another layer on top of this, and we'll have a NUMA node one with yet another scrub. Yeah, we'll have to see how that works out. Okay. So we do have a RAS daemon, so Shija wrote this, proof of concept to do scrub control. We thought, well, okay, what's the algorithm here? Well, we need a reason to increase how often we're scrubbing. Let's just use a threshold on number of corrected errors that are reported. So if you get a load of corrected errors, we crank the scrub rate up. Now, the idea here being that you'll fix the things earlier, you will, of course, end up with more corrected errors reported. So it's a very, very simple algorithm. We only crank it up to the "this device is bad" level, and then we leave it there. So there's no control theory going on here. There's no dynamic control at all. It's just it's looking bad. Scrub it more. That obviously is garbage. There's no way anyone's going to ship that. But the point of this was just to show that the interface provides everything that's necessary to implement something sane. If anyone does have suggestions on what such an algorithm would actually look like, yeah, get in touch. We'd love to put something more realistic on there. But until these devices are out there, we're kind of assuming clunky hack is the way to start and come around later.
This is my ignorance about how these things actually get deployed in the wild, but like, I mean, RASDmin is the open source thing, but do each like CSP environment have their own RAS policy thing? So like this would be a sample policy for those people to adopt?
Yeah. Okay. So, I mean, well, there's several things here. Where this was one of the two obvious use cases. The other one is the hot plug case, which is that you need something to squirt in an initial set of settings. And that one's much simpler because that'll just be a hard-coded UDEV policy. Well, not hard-coded. It'll be per particular vendor or particular cloud or whatever. They'll have a policy for how often they scrub their memory. And you just program it into the devices, all is good. This one, yep, you're going to need some policy type controls on top of it. At the moment, it's just one value. Maybe two, actually. I think there's a scrub rate and a threshold, which is obviously silly, but gets us going, shows that the thing works.
So you just said something confused me. Do the devices periodically scrub on their own?
Yeah.
Or is, okay,
This is all hardware scrubbing. So the devices are merrily doing this. Any sane device is going to scrub. By default, it will be on at the beginning. All we're typically doing here is tweaking the parameters of that. You can, in theory, turn it off. The only reason I know anyone ever does that is benchmarking.
Okay.
Where what they're actually trying to do is they're trying to get rid of a source of noise.
Okay, well that's just my ignorance of hardware, so.
Yeah. So, yeah, that's that side of things. Yeah. Yep, as I said, there are some issues. I think we already touched on those. Oh, yeah. The RAS thing also allows multiple scrub ranges. So you can say, well, I want to scrub this range at this rate and this range at a different rate. Unfortunately, there's no way of discovering how many there are or what the restrictions are. So it's just give it a go. And that doesn't make for a nice software model. So one of those things I am interested in, which is obviously not so CXL related, is if people are interested in fixing RAS2, it's definitely a place for code-first ACPI proposals. And it would be nice to tidy that up, because while it is sad, it's not all memory is going to comply with the CXL spec for a while. I mean, maybe we'll get there, and everyone will use our nicely defined control. But it's not happening today. I mean, there are efforts to try and generalize some of that stuff. So there's some stuff going on in OCP, I think, which may bear fruit, and people might eventually implement it on their host memory controllers. But probably not today. We do it for time. Okay, so open questions. Now, I put these down purely on the basis we might get here and no one had asked anything. But jump in with anything that you're interested in knowing more about. I mean, the opening one's kind of obvious. Does what we've defined so far actually meet people's requirements? Are there things out there you can't control? Is the granularity wrong, information wrong, any of that stuff? If you haven't reviewed the patch set, you may find this a challenging question to ask.
So the CXL standard, besides the host control mode for some RAS functions such as PPR and memory sparing, has also the device initiated mode.
Yes.
Where the device autonomously has its own policy to perform, for example, soft PPR.
Yep.
And inform the host through an event about the occurrence of these actions. So is there any initiative also to enable this mode in the kernel, or there are some drawbacks?
Yeah, so enabling that mode, well, I don't know, it's an interesting question. Are people going to ship devices with that on by default? Or is the expectation that it's opt-in?
No. It's the software must discover the capability,
okay,
and then enable the capability on the device.
So far, not something we've actually enabled. but it would be dead easy to add a flag for it. We already have for patrol scrub, there's one of the specs includes a sort of background scrub always, which is kind of an enable bit that would be a bit similar to that. It's just a mode you switch into, at which point, yeah, you get reporting, etc. We would need to wire the events up so that there was some interface. Maybe we just squirt them out as trace points and make it a RAS daemon problem to deal with it. Much like we do with all the CXL events today, we just add those ones. I think, has anyone added those?
I'm sorry.
The PPR memory events
Sparing.
Would that say that PPR occurred? I think.
No, I don't think so.
I think they're in the normal DRAM event, which we do have, but I think the fields were added later, so it may just be a spec update. Okay, well there's a job. So someone take a note of that one, and we'll add that.
Just one more question, which is somehow related. So still in the standard, some of these operations can become background commands. Okay, and there is also a command to request to abort a background command. Not sure if this is planned for the kernel to support.
Okay, so the reason we've talked about enabling the background command abort has primarily been for those commands where we want to expose them to user space. So it's things like component state dump. And the reason for that is that there's no defined maximum time, which is obviously problematic if the kernel needs to do something with the device. For these, the only reason the kernel would probably abort them is going to be down to some timeout, which absolutely we could implement. And if people think we should have a timeout on things like PPR, I mean, I dread to think quite what aborting an in-flight PPR actually means. I suspect it would leave you in a fairly odd state.
I think the device...
Sorry, yeah.
Sorry.
The device, I think, has a timeout defined in the capability, so can be used also for requesting to abort.
So if we don't trust the device vendor, so put the correct timeout in there.
Okay.
Yeah, okay. There'll be a bad one sometimes. So yeah, it makes sense to potentially use those timeouts as a hint. And maybe abort if it takes twice as long. I guess in theory we might have something that needs to be acted on very quickly by the kernel and then abort something like this that was in the way. But I can't today think why we'd do it. But we do, yeah, the background command abort stuff is definitely coming for the uses like the firmware control interfaces. So if if it goes on forever, we need to go, no, bail out. So, yeah.
Okay, thank you.
Here's one for Dan's favorite, NVDIM ARS. Do you care if we add support for it? Or does anyone else care? I mean, I can open it up to other lovers of PMEM devices of various types.
Well, they don't love it, apparently.
So we'll just delete ARS. It's much nicer. So ARS is just the kind of on-demand scrub equivalent for persistent memory and an ACPI spec thing.
Yeah, I say we leave all that alone until...
Yep.
Somebody asked for it.
Excellent. Not doing work is my favorite sort of work.
Yeah.
Absolutely. Yeah, so one question that came up in review that I threw down here is this question of, from the various drivers, passing the interfaces as a big attribute group and basically making it so that the drivers can add anything that makes sense for a given driver versus the callback type strategies. I got a couple of arguments for why one way or the other. One is that EDAC is all callback. So for keeping with local style, yeah, it kind of makes sense to stay with callbacks. And the other one is, should we say everything that's ever gone the attributes route and has grown to any scale at all has given up and gone the other way?
Well, I mean, I like the object-oriented nature of like, hey, here are the core attributes, and here I'm going to include that set, and I'm going to add my own set. And so like we do that in CXL. So I'll take a look. I mean, I like that property of here are the attributes, and here's my set of extra stuff, and not having callbacks all over the place. But
yeah, it's fair enough. I mean, one of the reasons this also is if you're doing things like PPR, if you do it via attributes, you've got to have a dance where the driver has to do the sanity checks. Whereas if you've got it pushed into the core, all you've got, the core itself knows what the situation the memory has to be in order to be able to safely do PPR. So it's things like that page has to be offline. We don't really want to do the offline check in every one of the drivers. I mean, we can. It's a perfectly good model. So at that point, that one needs to be callback based because we need to initialize the thing from somewhere else.
Right. If it's a general attribute that has like a sub function that the driver needs to do, that should be a callback. But if it's like a wholly owned, like we don't want to teach the EDAC layer about this policy, but we just want to have some extra files show up, then that should be an attribute. That
okay. So when we add tags, that should definitely be an attribute.
Yeah.
Because we're going to have tags here as well. Yeah. Okay. For now, I mean, my cynical attitude on this is adding attribute support generally means that people abuse it. So I'm kind of inclined to hold off on doing it until we have a clear use case.
I really think it really depends on what functionality you're trying to enable.
Yeah. That's fair enough. It's easy enough to combine a bit of both. Yeah, do we need policy control in the kernel? So one of the things on these is you can shoot yourself in the foot. So one thing that people have talked about before is things like not allowing disabling of scrub. You can change the rates, the idea being that the thing won't go to an insane rate. My personal view is no, but it has been asked. So anyone in favor of the kernel, basically the ask was along the lines of no sane manufacturer should allow anyone to disable this stuff because you're just going to get horrible errors and lots of bug reports and your field application engineers are going to go mad. Nope. Good.
Yeah, no, I mean, if the user has root, they can do whatever they want to their machine.
To be fair, my answer on this is slightly different, which is that a sane manufacturer is going to have hard limited these things.
Sure.
So,
like
so
if
they're
the
just
hardware
not going to
wants
allow the
limit
device.
it because there's a reason that the hardware should protect itself.
Yeah.
But, you know, the user can go in and pull memory and do whatever they want. They've got the hardware.
Yeah, okay. Cool. Any other questions? I think we have 0 minus 1 minute. So if anyone can talk backwards. Anyway, I'm happy to take continuing questions on these topics. And now it's coffee break. I will add that there are 2 gifts which will be handed to whichever speaker gets the most interesting discussion going. So I have my ideas on who that is today.
Well, if I had known that, I could have stirred more.
I didn't say controversial.
Thank you.
You've changed them again?
I added some links.
Yeah.
Thank you, sir.
Yeah, I'll do it. Do we have a break slot? I think we should.
Has gone away from so DAX is based on memory backend file. DAX user memory. All via memory.
Definitely no chocolates for John. Hiya.
I hope I still latest presenter.
Latest presenter? Yeah.
It's a little thing that you sell benchmarking.
Yeah. Yes. Yeah, you're down there. And did you upload a new presentation, or is the one?
No, it's the same.
Yeah, good. Because he's just changed it, so I need to do a rapid.
Okay.
It's around 1 p.m. something.
Yeah, I'll bring it up in a second. You can check. I just need to go through the dance of getting version 3. He's changed it twice since last night.
More along the lines because that was nobody here.
Having some interface
One more thing. I just uploaded version 3. Oh, there we go. Hang on. It's just a slow update. Hang on, I just need to do one more thing. Where's it gone? It's a very clunky interface. Kind of works beautifully, but then a little bit wrong. You didn't put a version number on it. Anyway, your slides, benchmarking. There we are. So version 2. Is that, do you anything you'd check?
No, I think it's everything's there. Yeah, it's, yeah.
If anyone can read the references, they're doing well. That's annoying, the shrunk screen thing, but yeah.
Okay, everything is there.
Anyway, that's cool. Let's just switch back to the break.
Okay.
Just put the
Yeah, no, I mean, we that's what. But I think it's being like rather more less there. I'm not sure if I would be using the
true way to solve the
I mean, there's something that has to do with I guess this one very old one. I wouldn't not use it as a it could be a file.
In that case, you don't need family files. Maybe I'll thanks to creating this flexible memory container things.
All this stuff rhymes with all the problems we have with
Yeah, John
Exactly. So he even has a devil device, and he's just kind of you see the database, and this is and you
well, the new loads are associated today with the fixed memory. So they're not only per device. That is something we potentially need to change. The idea is that the QoS is the same.
Oh, zone? I know. He wants a zone. I get it. It's not a club. Just for example. So anyway, if I find a way to even if we have the system memory, if I find a way to collect the memory ready for I think that's possible. But that is a general and I think that it's a solved, and I don't. I think it's been people have tried to do it, and every time they fail, it's just not really willing to because one of the things you do, and I think people try to say, I want this memory back. And lots of people, there are people right now, I know who's saying it works, and I'm like, great.
It's going to be the CPU.
Right. Yeah, so the jump system memory.
If you're talking about it's slightly wrong today. No, well, you need HMAT to then you need to fuse it all together. So the bus is discoverable, so you use it each of the parts switches and discovery instructions. The device has another one.
Okay, so HMAT just going to... Yeah. Oh, shit. That's no.
It can't go any further.
No, it's not going to okay, so it's about...
Well, that's support. Well, so, yeah, it's one number. Well, I think the other is just away with the license. We just don't have all the runs.
Yeah, or rather, we don't have what could you say?
Because like it's not like running your lobby that's how I know which DPAs are. That's why. There's a bonus this is a special
It's the more general thing, because using the CXL device for minor things is then used by the general population. Yeah, I mean, the CXL can do that stuff, what we do. So, because then, and that's also,
the restriction we had there was the
I'm in 2 minds, right? It's just the lazy way of basically,
there is the house where you're doing it purely. Yeah, like the cloud guys who are running DDR4.
Which is actually a reasonable
it's got reasonable performance, it's not quite as good as the other one, and it's not dynamic at all, it's just flat in there. And doing it's just a new one. Bog standard boring like one. Some configuration.
The company is consuming the memory on behalf.
And maybe, and you can do that with the Linux right now. It says, oh yeah,
but
we would do this, but now we have no one example.
In no individual application has
we're going to fix it, but when I would hope that we could, yeah, but on the wall.
I tend to agree with you. So they are. The problem is user space doesn't have the ability to really control that to the detail. And that's kind of the issue.
And that is why I'm so the tax thing is something that you can sort of mark things out.
If it fails,
and then
forget the CXL just published the
I think there's a problem with writing something starts just like normal memory. And then also try to forward also even if it's not and then we have enough of these we have enough of these
Linux fails for parts of well, that's what I was saying. Okay, so the solution would then be it's not generic. Oh, okay, so you were agreeing.
There is the one layer, so there is the other use case which is the running out of memory at the end, and this yeah, check it with and in that case it's normal memory, it's just at the layer on the lower level.
But then
what about the use case? It's in the memory map. It's there.
and still come back and try and keep it and handle that.
Oh, no, sorry.
See,
That's
that's
absolutely.
what we were talking about yesterday. How do we get it into the host, where to the host, and then say, get this VM memory, right?
No, different use case. So there's the dynamic in the VM use case, which is what that's about. There's the static stranded memory VM use case, which is just the guy, they pay for a certain amount of memory, they haven't paid for good performance. So it's not, you're not doing anything dynamic at all. It's bring a VM up, and you're bringing it up with 50% of the memory cost, 50% of the memory on 6L. And that one, all you're doing is you're going to throw new nodes in there. It's not dynamic, we don't need any of that stuff.
Well, then if the VM runs out of memory, they
Well, no. They don't run out of memory. They've got a distribution up there that just looks like normal numenodes. Because the whole point is the recovery path is you tear the VM down, at which point you can recover it. Oh, sorry, no, recovering the memory. So when we want to bring the memory back.
Right.
Yeah, to get the memory back, you tear the VM down. You don't tear it.
Sure.
That's a big use case.
Sure.
And in that case, the distribution is purely normal numenodes. We don't have to care about anything else. Hopefully the performance is not as bad for bandwidth as the stuff he's got some gold. I wonder who's it.
No, we never mentioned I haven't seen you in a while. I didn't recognize you until I saw you like presenting. He was like, oh, he's here.
I'll go back in a second.
Yeah, I know.
We've got 10 minutes. We can talk on the way.
Not only did we tell us that it was but that's why I didn't post it. I want to get
like in general, like if you have a failure and you have
I think I have an Apple that watches crash.
You think that's not an issue? So.
Yeah, for me, like,
Actually, so
I break these all the time.
It's not like I
yeah, go ahead. But for CRD boards, like,
I like because of our
it's
farm. They think that
I love it.
security issues.
My wife and I are
I mean,
both
but if you can
talk
about it in general terms, like take out the actual
if I should crash or get hurt,
I think
crash.
Maybe.
It's got a couple of like DNR, so if I crash, I'm done.
I collected the messaging.
Yeah, it's kind of like about yeah, exactly.
I'll just show you.
So yeah, it's got my wife's phone.
Paying years.
Yeah.
Right after
That's true. If I ever forget their phone number.
it should be. But there was an issue already, but the issue has been very serious, and the available solution. This kind of maybe I should report it to public or private about this.
yeah, I mean, like, personally, I prefer privacy. Just in case other people are having the same issue, we can fix it. But also, like, feel free if you're like, oh, I don't, like, not sure about what the details are, you can talk, you can send me off with as well.
Thank you. Using the CLV.
Yep, 100%.
Things to consider.
Okay, we don't really care about.
This is not my issue.
To me, and so I'm working on some
We had a lot of
So because I think this session is more focused on building the hardware features and maybe more focusing on the specs and so I'm working based on the Luma abstraction. So in terms of the users and then so to expand the bandwidth and privacy and then so in terms of the bandwidth and from the regular price and so we also
public, like, LSSMM. I think very, like, that's definitely more in scope for that because then we have the very many people.
It's my first time joining the LPC, so maybe I can instead of that, they were doing voice assistant.
Oh, okay, okay.
Yeah, with the
Was it recorded?
Yeah, it's recorded.
Okay.
So
Type 2 is.
It's more in the.
So how are things going over? How are things? I took 2 months off, so I'm like completely unplugged. So now I hear CXL as system RAM is just dead. This is a dead idea. It shouldn't do it now.
Okay.
I think always makes it nobody knows how to use that, right?
Yeah.
Like you talk about the system, like where's the memory? So
Yeah.
you just activate. What the heck?
It's so funny to watch it go. Like it's so funny to watch the conversations to an extent just go in circles of the different interested parties, and it just goes like, we should do this. No, we shouldn't do that. We should do it this other way. It's interesting. It's fun.
But I mean, so the people that are in here are people enabling the side. The people are not users who are like, I just heard man.
I mean, that's
I don't care about any one.
So think of this, right? Like right now,
So no.
the reason why I was talking about the default user movable today is I got the memory to come up and the driver plugged it all the way to a DAX device. I didn't even have to do like CXL CLI. Plugged it all the way through. And then I had the option of auto online. That go configure on or off. If I turn it off and then I go poke it with CXL CLI, or DAX control, it defaults into zone movable. If I turn auto online on, it defaults into zone normal. And I'm like, I really want it to default into zone movable, but I don't want the extra step of having to poke it. Yeah, and so I'm like, I think we can plumb that through pretty quick.
I think it was.
I was already looking at the code. I think I know what I'm doing.
Because it can also be a case where, like, say, even if we know about this, like, not enough zone,
And it goes
but
through
then
the 6L.
you do a fallback, you go like, well, hey, no one wanted it.
Yeah, exactly.
And,
Or, like, to be honest, it's just a matter of the CXL driver. Yeah, you're setting SPM anyway. You're setting special purpose memory anyway. It's just a matter of whether or not you set it to auto online or not. So just don't auto online it. Or if you really just need it as normal, just don't set SPM and let the BIOS configure it, and then chunk it over. And so that's where we explicitly don't want that. We want to keep the kernel out of it, at least to review. And so we have a chance to determine whether or not it's safe. Well, it makes sense.
But like, and the kernel was random things in there, like, why didn't
And that can happen. So like finally somebody on the back end, I wasn't telling you, they're like, did you know we could go to those blocks and just offline them and re-online and zone movable? And I'm like, yes, that is technically possible and not reliable. So I was not telling you all about that on purpose. It's the exact same problem we were talking about. But even in zone movable, you can't guarantee it's going to offline. So.
Right.
Do we know how the kernel runs is added to the
Oh, region. So that prevents the makes it non-movable.
I mean, I think it's just the kernel just has a normal allocation and allocator and those CXL tools.
My bet is that is not.
So the idea of
Because it's not part of the.
itself becomes movable, zone movable is more of an allocation policy, so it will prevent some kernel allocators from accessing it, but the kernel
No, but it's not that what you do,
access
but
or allocate explicit memory. So it's not a hard line, but like once you get to the user land can basically just ask for it. And it'll do it. There's nothing that says you can't.
Yeah, so what I was getting at is that like we do the take the region offline, but if we don't, it falls online.
Even if you online, because in my previous work, you don't guarantee that every allocation will actually it's more of it's like a top line. Do our best. Yeah. But if somebody asks you some page,
like anybody here.
Even userland. Userland, there is a way for userland to request an HTTP nothing happens. So like, you should just assume if userland can do that, anyone else can.
Yeah, usually signal.
Let's.
I don't know how to put my
Yeah. It's the Magic Plus. Yeah, be careful. There's the kill all button in the top right. Don't click it. The wonderful set of advice. And to you, isn't it?
Right. So you asked me to move
We'll
with
give people a moment.
arrows?
Yep, just dunk. Give it a moment. Just enough time to pour coffee down myself.
Oh.
Realised walking back is like, whoops.
Are you doing that?
So the mega RAS stream has driven half the crowd away. Maybe we should have stuck RAS at the end.
Yeah.
It's a niche topic.
Let's see.
Okay. So, looks like most folk are back. We've got a few folk online, but hopefully everyone read the timings. Anyway, let's kick off again and on to some Type 2 support with Andrew.
Yeah, thank you. Hello, everyone. I guess you know what's the talk about. 20 minutes, 14 slides. So going through the first two really quickly. I will have a summary of the current patch set for Type 2 support and the review upstream, and then I will share my concerns, my thoughts about supporting CXL cache in the kernel, and maybe some potential next steps or first steps for supporting CXL cache. So let me just start presenting the use case for applying this Type 2 support patch set in the kernel. This is for a network device that has CXL support. And the idea is to use it for lowering the latency. So we have programmable input-output buffers that rely on PCI bar aperture. And the idea is to use a CXL MEM, CXL region for that. So hopefully getting better latencies. CXL cache will be used for receiving. It's complicated, so I cannot talk too much about it. So what a Type 2 device requires in the kernel, well, first of all, no one touching it, the CXL main at least, no the BIOS, no the kernel, so no DAX device, because it's a specific memory for the device, and it needs to be written specifically, no generic memory. So hopefully, if you apply the right flag to the memory, the BIOS do so, no one is going to touch it, so perfect. So CXL, the kernel core, has support for PCI class, memory class, type 3. So we need to support PCI or the kind of PCI classes like network, Ethernet network PCI. And for that, well, we need to export the current CXL core API for doing initialization to those accelerated drivers. We need to fix some code that relates only on type 3. And we need to have a way for creating the CXL region from inside the kernel. And well, last one, once that is done, to not create a DAX device from that region. I suffered that, so that was another work that I had to do after the first implementation, because after installing the driver, suddenly the VM crashed, and I figured out, oh, someone is using it. So that was after the initial work. So the summary for the current patch set. So, well, I need to say this is all based on previous work from Dan Williams, that his goal was to start the way for supporting type 2, not specifically type 2 device. So, but most of the code is from that initial work. So in the request for comment, the first patch set, I write my concerns about this kind of the BIOS not doing the right thing, the kernel using that memory for that device, and then maybe breaking things. I was told, well, if you attach the right flag, no one is going to touch it, so don't worry. Perfect. Not completely convinced. I will talk about that later a bit. So I use initially not a real device, but an emulated one, because I have problems for using the real one. We don't have it yet, the physical one. We are using emulation internally for validating the hardware design that I couldn't use at that time. It was said, okay, that's fine, but you are not going to implement all the things through that emulated device. That meant that I had to use the real device in the following patches. Other concern with the request for comment was that should we trust accelerator drivers for touching things in these CXL structs? I think the initial concern was that security thing, but I think it turns out it's more about manageability. Maybe I'm grown about that, but that's my impression after the last reviews. And one last thing is that patch has not CXL cache support. That is the second part of my talk. So in V2, instead of just exporting the current CXL functions for initialization, an API was created for accelerated drivers to use it. So not touching the structs by themselves, but through that API. I use the SFC driver, network Ethernet driver for that, commenting on the use case as well. Well, other things, moving just specific parts of the headers that were moved fully in the first in the request for comment patch it, and I was told not to do so. There were some problems with the capabilities, the mandatory capabilities to work with, that led to another change for V3 that I will comment in a second. And also some concerns about some patches being too complex that I fixed in the V3. So the more important change here was to add a capability field to the memdev and also do the CXL port. And the idea is instead of, the CXL code discovering the CXL registers, initializing that field with what it's found, and then the driver checking or matching the expected capabilities to be found with those ones. So removing some checks in that CXL core for discovery. I did that about removing complexity from big patches. That, by the way, it was in the original dump patches, but I just mixed that in the first one. So I think that has helped to understand better that specific patch. And I add a fix that I suffered, and I was glad yesterday because Fang told me that he had the same issue with a race condition between the CXL memdev being creating a CXL port, and then a race condition because the CXL port is not there yet, because it goes through this device model when the main code is trying to use it. That was not really liked by Jonathan.
I think so, and I saw another person with a similar patch that hasn't gone out yet, but there's a race condition. We just need to have a retry.
Yeah, that is what I did.
Yeah, the long and short is like there's an ENXIO error somewhere in the stack that just needs to be an eprobe defer, and that seems to be appropriate. We just need to dig a little bit more into exactly why, for the sake of documentation, I think.
Yeah, I need to work on that. So this is inside that patch that tries to solve another race condition between the CXL memdev creation and the CX support not being still there. That I don't know if that is a corner case or is something that we can expect often.
My best understanding of the problem is that the ordering isn't guaranteed regardless, so it's a problem we're going to have to just deal with by having occasional retries if we detect a failure.
So I think Daniel had suggested using a lock instead of a retry for this race.
Well, no, I mean, this is dependent on like the top of the hierarchy being probed and the devices being probed asynchronously, and they have to rendezvous. And so if the memdev wins, you got to I think we have to retry. But yeah, I add the question to make sure we actually, if that is actually the problem. But it seems like it.
We saw the same thing.
I believe it's data in that port.
We have literally the same patch.
Well, yeah, I think we gave you the patch, right? It's in the.
No, actually, I made it separately, and then I saw yours.
Okay. Yeah, it's just the timing. It can't find the root.
Okay. So it's not a corner case then. Good. Well, the idea is to, in my case, to dig a bit deeper.
I mean, if you can't find the root, it means probing hasn't finished, right? Why do you expose the device if it's not finished?
Because PCI did. It's a PCI drive, not CXL.
Right, yes, but again, why do you expose the PCI device if it's not fully probed?
This is normal resource racing in the kernel. You defer and go around again. It's how it's handled all over the place.
Another word for sloppy programming.
Ooh.
Now, I mean,
Who invited him? Next year, he's not coming.
Okay, so so for before, I think that's the main problem that I need to investigate a bit further for understanding and maybe proposing something that is like it. And the other problem, not major, but is handling better CSFS files that I just put there a check for, okay, if this is a type 2, just forget about it. And I was told that maybe that could be better handled now instead of keeping it going. So the rest of that, I hope, is fine. I don't know if someone has any comment for inline review now, but I hope this is going well, and maybe in B4 or B5 can be integrated. So if that is the case, I think a following work is, at least with my concern of the least concern, is how to handle CXL reset that is not done. We don't have code in the CXL core for handling that possibility. And the problem here is, what are we going to do? I understand that for type 3, CXL reset is a really bad thing. Maybe the system is going to crash, but I think it's more likely for type 2, where that kind of device reset, including the CXL, can happen. And then if the HDMA registers are being committed, I guess we need to tell the switches that is not there, or to keep that information for restoring the same information to the old registers after the reset, because that the way it works is that that device is going to be proof after the reset, and it's going to go through all the CXL initialization, and I guess we don't want to have different HDM range in that case.
Do you think, I mean, is it the case that you're going to want to definitely always restore the same configuration, or that you want to reset and do something different next time?
Well, I think what we want to do is to keep the configuration, but that's my idea, but I don't know if that's the case. But in any way, we need to support that. Yeah.
So one thing I found kind of obscure in the spec is I think the CXL functions that need to be reset are not explicitly listed. I mean, there's some obvious things like the HTM decoders and all, but all throughout the spec, like, it mentions here and there, but it's not clear to me 100% what the impact of reset is across the whole driver.
Well, the whole driver, you mean the accelerator driver, or the...
Yeah.
Yeah, where it doesn't say, you reset it. So
that's kind of what...
That's the intended implication, is it's the equivalent of a normal reset on a PCI device, except that we walled some things off because that was destructive. And this just puts back the rest. So yeah. I don't think there's anything you're not supposed to reset.
In any case, it's a following work, so I don't want, because I want to talk about CXL cache. The other thing is to have a way for if the device memory is taken by the kernel, to have a way of, I see, done.
But, I mean, the BIOS doesn't get to pick this, like the device, I mean, you're saying the device correctly said in the CDAT, this is reserved in the BIOS, and nah, I'm going to put it in the memory map?
I'm saying that maybe we shouldn't trust the BIOS to do always, in all cases, the right thing. At least in the following years. I'm suffering now a problem with the BIOS related to other thing, and it's hard to get rid of that problem. So what I'm saying is, okay, maybe you can update the BIOS. If not, let's have a way of saying, hey, that's my memory.
This is a slippery slope. Yeah, fix the BIOS. Really, every time this happens and anything else in ACPI, if stuff's wrong, we paper over it. It's a nightmare. This is new hardware. It's not like it's been around for 10 years and we've got to deal with it.
Yeah, but I mean, how long is it going to take to fix the BIOS?
Well, until then, it won't work. They won't sell any product. They'll fix it quickly.
We can at least do like a warn taint firmware workaround to like put them on blast, shame them, fix your BIOS, and then let people get work done.
A warning, sure, but if they do something like commit decoders that you can't then uncommit.
No, decoders are fine. This is the memory type.
matching ACPI tables. So, and you can do them in kernel. That's, if you're going to put a quirk in, that's where to do it. Don't do it in the driver stack. Do it as an overrided table, which is horrendous and gives you all sorts of warnings, and you have to enable extra config options. So no one ever ships it, which is great.
I mean, I think the problem is a little bit more fundamental, that you have to also tell vendors that if you're trying to build a Type 2 device, you have to have this memory type so that the BIOS won't screw with you, right? So you can't fix stupid if someone builds a bad piece of hardware. But then, I mean, yeah, I agree. If the BIOS doesn't treat it correctly, then fix the BIOS. I mean, and
fair enough.
and I mean, half facetiously, Jan, like, get out there and say, like, your vendor, this vendor X has this broken. That should be loud and proud, because that fundamentally breaks this type of device.
Right.
Yeah.
Agree
Plus-
with Dan that you should print some big warning.
Yeah, so-
Find a new
But it's a
vendor.
BIOS bug.
And in the end, I mean, if a BIOS vendor puts in something like that, he wants to sell the thing. And if it doesn't work correctly, he has its own interest to get it fixed so that it works, because, well, it is new. So he has to build the BIOS. So it's not that he can say, oh, you know, it's long out of service. No, it's not just a bloody new thing.
So what I'm saying is maybe that is not the right thing to do, but what I'm saying is maybe for the next 2 years.
No, I think
Okay.
the thing where
BIOS is because the kernel rejects stuff every week.
Okay.
I think where the
Shout at BIOS team, they fix it.
I think it's
where the work is probably best spent is to warn when this happens, and hands off and focus cycles elsewhere.
Well, in our case, the warning is not needed because the machine is going to be partly. Good, fine. So, yeah.
I mean, if the DAX device is created and you have it like mapped as write back, and you try to load your host driver, it just gets pissed off. It doesn't crash.
If this memory that the kernel is going to use and the guys do. So, okay, that's done. Let's talk about CXL CAS. So I'm going to go straight, because I don't have time, to this one. That is about memory, allocating memory for that in the kernel. That needs to go.
2 minutes.
Okay, needs to go through the, for security reasons, through IOMU, but there's a case of IOMU not there. So anyway, it needs to go through the DMA IOMU API. But the problem there is we have a snooping CAS in the CXL root complex that needs to be taken into account for not reserving more memory or not allowing more CXL CAS what that snooping CAS requires. So I think we need some kind of wrapper there. For that case and for other cases, I'm not sure the current IOMU implementation in the kernel supporting different devices is also doing this safely because different reasons. But I think that in our case, we are going to use IOMU for the normal DMA thing, and we are going to use IOMU ATS for the CXL CAS. So same IOMU mapping probably is going to be complicated to ensure everything is going to be fine. So because I don't have time, I think that's the main point of what we need to do to start discussing.
Yeah, I was going to say, like, I am not a fan of how the current kernel policy around ATS is designed, and I think CXL is pushing that off a cliff. And we need to have some more discussions about what does ATS look like in a world where we need to enable CXL cache devices, because the current ATS policy is based on like whether it's cabled into the system or not, and that's not appropriate for CXL.
I think it was. I think initially that it was once the ATS thing is done, the system trusts that device. But I think in some cases, if it goes through this PCI, there's a routing there, and if the ATS flag is there and the right routing is not there for that ATS, it's not going to work. But I don't think that is the case for CXL anyway.
Might be a stupid question, but does this have implications for the Linux memory model? Like cache misses and TLB flushes and so?
No, because that is the CPU.
No, yes, but does it need to? So
that's the TLB is for the CPU.
Has anyone checked? Like?
No, this is the problem. The hardware you don't have to software manage.
May I
So
ask?
now
Yeah. Yeah, okay. Thank you. Here I want to say, I think currently the ATS is work for the PCI root complex, and that means the ATS most IOMMU service translation agent is just like treat it as a traditional PCIe TLP package. So if ATS enabled, I think the endpoint can easily use the ATC and let ATC to send the translation request to the host. I think maybe the current IOMMU on the host could serve like this way. So I think I thought when we enabled ATS, most the catch the type 2 the CXL dot catch could work properly with the ATS service. And the second, if we disable the ATS, that would make a problem. That's the current IOMMU hardware in the host maybe cannot IO bridge cannot bridge the CXL catch channel. So that would involve another hardware circuit. So I want to ask the guys in this room, what do you think about this description, or how do you think about the ATS work with the CXL dot catch or disable
so
it?
maybe we could talk that offline. So I have, if you go through the slides, I have the last one where I put there a potential roadmap or actions to follow. So please comment in that channel that we have for that. So I'm done. Thank you.
Thanks very much, and sorry for cutting that discussion off. We had 5 minutes padding, and we've used it. So it was good. So you wanted version 2? John loses for changing his slides the most times. But hopefully...
You're lucky you got slides from me at all.
That's true, he hadn't sent them till yesterday. And this is still version 3.
How do I control them?
Yeah, right arrow.
Oh, okay. Okay. Hi, everybody. So this is a little different. I think it's a different perspective on how to use CXL. And I'm mostly focused on shared memory, and I'm the FAMFS guy. So I'm going to talk about what that is and why it is and stuff. First, a little bit about system RAM versus DAX mode, then my dynamic capacity overview, because I think we're going to have competing ones of those, you know. Some FAMFS details and some info about cache coherency. I'm going to try to skip over FAMFS details unless there's a lot of questions about it. There's quite a bit of detail in the slides, so I encourage people to look at those. So kind of a busy slide, but system RAM versus DAX mode. If it's system RAM, you online it, Linux owns it. It's eligible for being given to anybody in response to an allocation. That's got a lot of flexibility. You can migrate pages, you can run auto-NUMA. But memory and connectivity failures affect system RAS because you don't know what the kernel put in it. DAX mode, on the other hand, basically you have to have apps that know how to use it. But that includes FAMFS, which makes it look like a file system. And when you do it that way, system RAS isn't affected in the same way because Linux doesn't put anything in the memory. And in fact, not even FAMFS puts anything in the memory from the kernel, except in response to read and write calls or mmap on behalf of the user process. So the blast radius of a failure of the memory is the process that was accessing it normally. So quick overview of DCD, because So one of the things, I'm one of the authors of DCD in the spec. So I have some perspective on why things were put there. It's seen as something complicated, and I think there's a certain amount of misconception about it, but a DCD is just a memory device with allocation and access control built in. So when you connect it, there's no memory provided. You have to allocate some. We need a fabric manager for that. Luckily, Gisela's here. Tagged allocations. So allocations can be tagged or not. If they're shareable, they must be tagged. It's mandatory. And tagged allocations, I claim, are file-like. How is that? Well, there's a tag that you should be able to use to find that memory. And if an orchestrator allocates memory for an application or to back a VM or something, then the orchestrator should provide the tag, to the VM or to the code that starts up the VM. And then that's how you agree on what memory is what. If the memory is shared, that's how we agree what memory we're going to go find, and I'm going to put stuff in it, and you're going to look at it, right? So there's some talk about MEMFDs and whatnot. I'm a little concerned about that. I know DAX devices work here, and I think MEMFDs probably can too, but when we introduce FAMFS, we've got an analogy of these character DAX devices to block devices. With block devices, you've got the block ID library and LS block and stuff. And that's a set of tools that looks at all the block devices in a system and looks whether there are recognizable superblocks on them. And whatever devices it finds with superblocks, it tells you what they are. And that includes like logical volumes. Those have superblocks too. And so the character DAX device container is a convenient thing to have. Another thing about tags, the size of a tag is UUID sized. And I claim, Fabric Manager people, please make them UUIDs. They must be globally unique. There's some ways you can use this when you don't need that. But it's broken if broadly we don't make them globally unique. And a tag is actually local to one memory device. So you've got to generate these with the right discipline for UUIDs so that the tag space on one device doesn't collide with the tag space on another device. Again, think of them as file names, except that they're UUIDs, which are less user-friendly, but unique. Okay, so tags are essential to find the memory that was allocated for some purpose. If the memory is shareable, I claim don't online it as system RAM. That's nonsense. System RAM is going to get zeroed if you were going to share it. Whatever you were going to share was just lost. You basically just can't use shareable memory as tagged capacity unless it's allocated as shareable, but you're not really going to share it. In that case, because you can't do that. And then the bullet about FAMFS being able to interleave is slightly out of context here, so I'm going to move on. So I want to talk about the core inside of FAMFS. There's been a lot of work over the years. HP's project called The Machine that a lot of people have been aware of if you're old enough. It's maybe 10 years ago. They had resistive RAM, which was persistent and shareable. But the thinking really was, hey, it's a new paradigm. We need new abstractions. And that never works out very well. Unless you don't want the new stuff adopted, in which case it works out pretty well because it's just too hard to use. And so that's, I claim, a bad idea. Now, with DAX devices, when a memory device is shared, then there'll be a DAX device on one system that references the same memory as a DAX device on another system. If it's tagged capacity, I claim that should be a virtual DAX device that maps to that tagged capacity, that also, there's one on another system. And you do need a way to resolve tags to those. But once you've got that, that's a thing you can share. An application on one host can mmap it, and on another host you can mmap it, and it's the same memory. But I claim that's still a little bit too hard because apps don't already support DAX devices. A few of them do, but and you can't stat a DAX device to find out what size it is. There's a different procedure for that. So, so the core insight was, this is a little too hard, but all the plumbing we needed to make this look just like a file system is already there, except for what turns out to be a little less than 1,000 lines of code currently in the kernel for FamFS. This is patch sets, it's not upstream yet. And so I implemented it. And there are quite a few universities and companies that are kicking the tires of shared memory using this, and it's fairly far along. This, I think I'm not going to dig into because it's too much detail, but I encourage people to look at the slides and to reach out if you want to talk about the details. But FamFS is basically an append-only log-structured file system. It solves the problem of being able to mount from the same memory, which is analogous to mounting from the same storage device, except it's not a storage device, it's memory. And it handles that by, there's a master node that gets to append the log, the metadata log. Client nodes just get to play the log, which means they don't get to create files, but they can see all the files. And any given file, if you choose to make it writable by everybody, you can, because everybody's mmap is really just going to the memory. You can also, this is a thing I added into the CXL spec, a given host can have a read-only mapping of a CXL device or of a tagged capacity allocation. And in that case, you can actually require the device to drop writes from a host that's not allowed to write. It's a little bit about the metadata format, and there's some updates to this, including an interleaved format. One of the things you would want to do with memory on, or with data on fabric attached memory, is you would want to interleave across devices for performance. And so we actually support that now. It's not pushed to the mainline repo, but it's going to be there. And this is an interesting enablement because CXL the hardware can be programmed to interleave across devices, and therefore it can be programmed to interleave across tagged capacity instances. But the extent list has to be identical on all the devices or you can't do it. So if it's one extent, it's got to be the same DPA on all the devices or hardware can interleave it for you. But if you're already doing a file system, interleaving is actually straightforward. It's just an interleaved extent list. So my suspicion is that the ask of fabric managers allocating, give me 32 gigabytes each from these 8 devices and make sure it's exactly the same DPA extent list. That's going to be hard. Quick status update. I introduced FamFS at Plumbers last year. It wasn't out yet. It's on GitHub. The V1 RFC came out in February. V2 came out in April. I led a talk on it at LSFMM, and the net of that, which wasn't my goal, but it's actually good news in the big picture, is that there's a desire to merge this capability into Fuse. And so I'm working on that. We have Miklos, the maintainer's coming in tomorrow for a meetup. And so why is that possible? Well, FamFS, it's about 1,000 lines of kernel code and about 6,500 lines of user space code today. And the user space code writes superblocks, initializes the log. All log entries are created by user space code. All log plays are handled by user space code. With the current implementation, when the log gets played, for each file. The file gets created. Briefly, it's kind of an empty RAMFS file. And then an ioctl on the file gets called that says, here's your extent list, at which point it's got what it needs to handle mapping faults and handle read-write. The Fuse implementation changes around a little bit how that works. Fuse has the concept of caching up metadata and timing it out and whatnot. But the key thing that has to be added to Fuse, and Miklos is on board with this, is that a file whose metadata isn't timed out must have its metadata fully cached in the kernel. Because we're enabling memory. It's got to be at memory speeds. And that's what's required for that. Because what does the file system do 1,000,000 times a second? It answers the question from down below, tell me where the data is for this offset in this file. And the answer is in the form of, it's at this offset on this DAX device. And so that's got to be fast. That's why we cache the metadata in the kernel, and that's why we'll have to keep doing that. Interesting use cases. How am I doing for time? I'm close, but I'm good. So there's a ton of uses of data frames. Apache Arrow is among my favorites because it's a memory-friendly format. It was created by the data analytics community in conjunction with the GPU people to say, don't make me restart my job from the CSV data that I imported or the log that I scraped to get this into memory. Let's build a canonical format where a column of 8-byte floats is packed in memory vectorized, and so on. And so these formats are already super friendly to memory mapping. In fact, they're made to be stored in files and memory mapped. It's just that until this, files are demand paged things. In this case, if you dump it into FAMFS for analysis, it's just memory. There's not a storage backing. In-memory database is also interesting because those are also tend to be memory mapped formats. And let's see. So yeah, FAMFS doesn't create any new cache coherency problems. It just makes the old ones worse. This was a benchmark we showed at FMS. And the purple line is RocksDB database in DRAM. And the x-axis is normalized to system memory size. So when we run RocksDB query workloads against a database that's fully cached up in memory, it's fast, right? And when it gets bigger than memory, it gets bad slow, and the P99 latency, the lower plot, goes through the roof. And the lower plot is log scale. This particular diagram, acknowledges maybe more pointedly than will be applicable that, okay, the CXL memory is a little slower than the regular memory, but you can have a lot of it. And if you have a lot of it and put something big in it, you can have consistent performance scaling all the way to the size of that memory. This particular data was typical DRAM bandwidth, and it was 2 CXL cards striped. With more, we expect to be able to move the green line up towards the purple line on the left side. And I think the thinking that I want to encourage is that CXL memory can change, it can change what size of problems fit in memory. And there's a set of techniques we use to make things fit in memory, like sharding, which leads you to shuffling. And not all problems shard well. Some problems have to be shuffled because you've got to move the data to where the compute's available towards the end of the job and whatnot. Shuffling can be an n-squared order for n nodes. Some problems are hard to shard. But if thought experiment, take 4 servers, 8 terabytes of memory total. You can put 2 terabytes in each server and take a 6 terabyte database and shard it across the 4 servers. If sharding works well for you and shuffling is not a problem, that's pretty good. Another way to use the same resources is a 1/4 terabyte of memory in each server, 7 terabytes of shared memory, FAMFS. You can do it with DAX too if you like pain. And now the whole thing's in memory. All the servers can access all of it. Yeah, the memory's a little bit slower, but there is no shuffling. And so these change what fits in memory types of things are interesting. Couple words about cache coherency, and 1 minute ought to be enough for cache coherency, right? So CXL has a cache coherent mode, but if that sounds to you like it solves all your cache coherency problems, then you probably don't know enough about cache coherency. There are some implications like memory barriers need to wait for all CL flushes that have been called to complete before they unblock, and things like that. But John's opinion is that shared memory is interesting for the use cases, and there are a lot of them where data gets dumped into a shared store, consumed, the outputs go to separate files or data sets, and there's a ton of data like that. And like RocksDB is a good example because it writes files out and then they're read-only for the rest of their life. So it maps beautifully onto this. And here's just and this is the last slide. There's a big ecosystem of stuff that uses data frames, also LSM kind of key value store stuff that is biased towards data that gets written once or not very often and then consumed. And so there you go.
Okay, I've got one question for you.
Yes.
Is there anything you'd particularly like help with or people to look at? Basically, what would you like the people in this room to do to get this there faster?
So that's a great question. I'm at a sort of scalability bottleneck point right now because the Fuse port is gnarly. And I didn't know enough about Fuse going in, so I'm just coming up to speed. I expect to be posting Fuse patches later this year. The big thing that I could use, number one, if you have a use case that you want to play with this for, please do. Number two, I didn't talk about the limitations, but the limitations are kind of epic at the moment. Files are strictly pre-allocated. So you can't change the size of a file once you've allocated it. And you can't just open a file and start writing to it. You can DD in and out of files, but you have to conv equals no trunk. And today I don't support delete. Now, delete's actually pretty easy to support, but once we do delete, there's a problem. I mean, the core problem with FAMFS is that clients may not be up to date playing the log. So if I let you delete a file and then create another file that uses the same memory, some client that's stale still sees an old file that points to the same memory. And so I want feedback about, my opinion is that it does not make sense to try to turn this into a general purpose file system. That although there are some cases where you might want to use XFS and FSDAX mode on your CXL tagged capacity or CXL memory, if you want to have a file-oriented allocator that you don't need to share. If you need to share it, you can't do XFS because it does write back metadata, and that's not shareable. Hannes.
Sorry, before we go to Hannes, we've got Gurun's got hand up online. Do you want to ask a question, Gurun?
Yeah, one question. Thank you. How do you deal with the memory tearing? I mean, if the FS backended CTIL may have the tearing, some faster, some close, some remote. So would you move the metadata from one set to another set?
Got it. Today, FamFS doesn't do anything about tiering. It does do striping across multiple memories. And actually, the thing that it does today, because we don't have DCDs yet, and we don't have really Fabric, but what we've got is some early switches that are, super experimental and whatnot. But what they do is give you one DAX device that is a concatenation of some back-end DAX devices, not striped, concatenated. And that's the worst possible case because a given naive allocation is going to only land on one device. Therefore, FamFS has a striped allocation mechanism that can be just bucketized based on the knowledge of how big the back-end devices are, and it can stripe. Now, later, we could do more complex tiering. But the problem is, relocation's a problem. It's the same problem that delete is, which is that, we've elegantly solved the problem that clients might have a stale view of metadata by making that just not matter. The moment you do delete or the moment you relocate something, then it does matter. Deleting, relocating, those aren't hard, but we have to have an understanding with, the application has to understand what its responsibility is or else it breaks. But, and so a dialogue about how it should go forward in terms of flexibility for delete and whatnot would be very helpful. And then, because of the fuse port, I don't have, there's actually one or two issues up on the GitHub that say help wanted, but they're kind of DevOps-y things. But help is definitely wanted. And long term, there is a community starting. There are PRs that have been merged from outside, and more would be great. And feel free to reach out to me.
Oh, right, yeah.
Feel free to reach out to me.
Okay.
Oh, yeah, whatever.
We can do it afterwards.
While I do the slides.
Oh, that's fine.
Hey, wait a sec, he's asking. Have you got a question, Hannes? Go
Yeah,
ahead.
we can do it.
Oh, okay, do it offline. So, David Law, it's you. Yeah, we're technically 5 minutes over, but it's not too bad. All the padding's gone.
Hello, my name is David Orbueso. I work on CXL at Samsung. This talk is mostly about bringing a way for users to communicate or send commands to the different types of, the different ways that CXL allows it within the direct attached domain. And it's really a unification or based off of what FM API tests paved the way for a way of communicating through standard commands with different components. And added to that, the kind of administrative wrappers or interfaces that libNVMe provides. And if people are familiar with libNVMe MI, that's exactly what this is about. Yeah, and it's scoped by the manageability model of CXL devices as well as the CCI. And this library could also be called libCCI, really. So this is not intended to compete, replace, or do anything with libCXL. It's really mostly about not having the protections that the OS gives us for communicating with devices. So basically users have to know what they're doing, and if not, they get to keep the pieces. And it supports both out-of-band and in-band CCIs, but it's really mostly about out-of-band. And potential users are BMCs, fabric managers, firmware, whatever. And the reachability is what FM API tests kind of modeled with the Type 3 SLDs, MLDs, and CXL switch. Again, it does not support GFAM devices. And there's no concurrency. It tries to be NIMNIS aware, at least for the non-vendor specific things. And the idea for this is to have a standard and open building block for building fabric managers and dealing with BMC. And right now, this is very obscure and fragmented, I think. There's no clear open source software or there's very little information about what's going on. And this was previously discussed with the DCD kind of loop. So I'm not one to put code in slides, but I think instead of going through all the different library calls, it's better just to show by example. This is really just an MCTP component discovery using dbus. Here you basically discover all the components within the system. And there's really two library-specific components, which is the library context that keeps track of all the open endpoints, and the actual endpoint, which is whatever MCTP will discover, or whatever Linux has for the SysFS devices and how you do the IOCTLs. So here you're basically discovering everything that there is to discover and iterating through each of the endpoints and basically showing some trivial information. That's really what this is about. And there are really three ways of discovering things or opening them. One is passing the tuple, the network ID, and the endpoint IDs for MCTP. Linux does the MCTP stack. It includes the network ID, sort of like an address space workaround to not be limited by, I think it's 255 devices, something like that, the maximum. So you can basically open everything. You can open one at a time, or you can just do the old-fashioned libcxl way with Linux. When probing or opening devices, I call them endpoint. Again, endpoints is a very generic term. The library can track different instances of the same underlying device, but it is limited by what the spec dictates, that there needs to be a one-to-one MCTP and mailbox. You can also do it for secondary mailboxes if like, I know Linux doesn't support secondary mailboxes, but in theory there's nothing that would prevent having it. And the calls are really all about expressing what command to send to what endpoint and how. You can do it directly or the tunneled way, as we're going to see. So the functions themselves, they're called as best as possible the same as the payload data structures, keeping it simple. It can be like a mouthful to type and all, but it's really pretty intuitive. The 80 character width really is really hard to follow. So yeah, and it's really like, depending on the payload, you get the kind of function that you want to use. So commands that don't have any payloads, they'll just have the endpoint and the tunnel information. And the ones that have input payloads only will have its input parameter, output parameter, or if they have both, they'll have both. And the data structures themselves, the payloads, are basically exporting exactly what the spec says. So users are expected to know what they want to get from this. So normally for the tunneling information, if you just pass null, you're referring to the direct communication. But the more interesting use cases are obviously with the tunnels, and the spec has 3 that are not GFAM basically. So for to send, the first example is tunneling commands to an MLD through a CXL switch. The spec diagram is pretty straightforward. And basically all you have to do is arm the parameter with the level you're using. Normally it's one, but you can also have two levels of tunneling. And if you're sending it to a switch, in this case, you give the port number. And that's pretty much it. Very similar when sending to an LD within an MLD. You specify the LD and you just pass it. So again, very, very straightforward. And the double tunneling is basically you set the level and you set both the information for the outer tunnel and the inner tunnel. And yeah, that's all that's required. The return values, usually -1 with error no set or the respective CXL return code. And of course, like in this example, you can't always check for if error or if RC, whatever, because if it's a background command, you have to keep that into account. Silly things like that are necessary to give users the most flexibility as possible. And this is really what I wanted to open up the floor for. Is this sort of thing useful to the community? There's been no release. I know that some people are already using it successfully and are pretty happy with it, but things can change. A lot of testing is very hard for this sort of thing. QEMU has opened a lot of doors for this thing, and I think that the increasing interest in out-of-band use cases are making QEMU was always very tied to the kernel development side of things, and now it's really not necessarily only that. Now it's people are wanting to have the testability of QEMU for this sort of thing. So it really expands the necessity of the emulation. Yeah, the current state of the art uses the A-speed I2C. That's pretty much all we have for testing right now. But it has been successfully used with the SMB bus.
This looks great. So I think we're happy to join forces with you. We have something very similar internally, but we haven't, we were planning to open source it at some point if no one else did. And, but we can, I'll talk to you after, see how we can work together.
Yeah.
Throw a trivial request on there, which is if anyone has an MCTP device that they can publish a spec for, that we have any realistic hope of integrating with upstream QEMU, it would be extremely helpful. The thing being used here is an appalling hack. I mean, it's bodged into x86 PC, as they all have A-speed I2C controllers on them. I mean, it works, but we also have to hack the kernel drivers to make it work.
Yeah.
So it's a bit ugly. So if anyone has any real hardware, it'd be very, very handy.
And if anybody is going to test this with real hardware, I'd really like to have input on it, because again, right now most if not all of the testing I've done has only been with QEMU. The one thing that's open is the tunneling through the for MHDs, and basically adding the rest of the commands. I haven't looked at the GFAM devices, but the idea ultimately, I got this question, is it not supported? Will it never be supported? Or is it just not supported now? I think that this library should have the same reachability as CCI in general. Like if you can send a command to a device defined by the spec, this library should be able to to do it. But for now, the tunneling we have has proven useful for the use cases we know that have this.
Well, having done libraries like this in the past, I do kind of wonder about defining the header file with particular payload responses and how that will fit. I guess if everything's in a spec, it probably is pretty safe.
Yeah.
But then that led me to ask the question, why not Rust or a different language? Is there any thoughts on doing that?
I'm a C guy, but
I mean,
Rust wrappers, I totally see it. Unlike the kernel, I totally see Rust wrappers because fabric managers are planned on being written in Rust. At least I know a couple of cases. So
actually, that's right. I heard somebody.
Yeah.
Two things. The one is that, as you mentioned, libmdme, we found it quite helpful for just implementing all features and everything, just to have a test spec for the spec itself, just to see right where do we stand. That's one. So that's quite helpful. The other one is you maybe want to talk to Javier, because they have built a scraper for the spec file. So you can scrape the header files of the spec file, which turned out to be incredibly useful, because then you're reasonably sure you didn't make any typing mistakes when creating the header files. And you can even then validate whatever's in the spec, whether they didn't mess up and defined a bit twice or stuff like that, which never happens, obviously.
No, never.
So you said earlier in one of the slides, the intent is to, I guess, not compete, if you use that word, with libcxl or CXL CLI, however you want to interact with it. In that sense, there is some level of duplication of functionality.
Yeah.
Is the intent, and I guess this might be more on your side, is the intent to keep libcxl more for the kernel-specific management, like the inbound side, and have this more focused out of bound? But obviously, you can do the inbound management via this as well?
That's exactly the approach I took. I did not want to contaminate the NDCTL library, just because the libcxl is so Linux defined.
And yeah, I want to keep that straight, because like my mental model right now is NDCTL being the parent package for it seems highly tied to the kernel version you're running on, and if you can decouple that from, I guess, the CXL.
That's
general CXL.
Yeah, and we also have this firmware control interface we're talking about. We're thinking about calling it auxiliary control, but that's about having a path to send like unfettered vendor-specific commands, but also we also need to support the libcxl interfaces. So I think we need to be able to build a Linux that can do anything to anywhere at once. But I'm wondering, like, how do we, when we have the local interface and we're the BMC interface, how do we maintain the case that the kernel interface can be protected, but when you're in BMC mode, you can do anything you want. That's the part I'm trying to figure out.
I think that the users will just, like, if you send a command out of band and it screws up something, and the kernel doesn't know what to do there, that's, to me, is the user's fault.
I guess if you're on a BMC platform, you get to keep all the pieces.
Yes. Mm-hmm.
Again, taking a cue from libnvme, where we had exactly the same problem, that the NVMe CLI was actually there in the first place, and then Keith did the libnvme for his toy project. But in the end, we decided to move the existing NVMe CLI over to libnvme, such that we have a common code base for formatting the commands, for having the commands, blah, 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 such that we don't have to do the work twice. Because in the end, even though NDCTL might be Linux specific, at the end of the day, it still has to deal with the very same commands. So you will have to use the very same headers and everything. So it really makes sense to combine them both, that converting NDCTL as just whatever something, calling then your library there. So it is a lot of work, but in the end, it turned out to be really worth it.
Are you advocating actually combining the libraries or just the package?
Just the package. That's
okay.
basically existing front ends to use common
Yeah, but the kernel only cares about a small subset of the commands. Like I think for management interfaces, there's a whole command set, but for the kernel only cares about a few things that might exist inside the kernel.
There's about 5 commands that you would use in both. They're things like get and set timestamp. The rest of it is totally separate, and the message formats and everything are different. So how much you'd actually save? Remarkably little in this case. Yeah, but it maybe makes sense. Yeah. Oh yeah, sorry. Good point. He was just saying that the same thing happens for lib NVMe, where they only actually have, 3 roughly commands that are in this case where they get overlapped. And sorry for not throwing the mic. Any questions?
The one benefit, really nice thing that I would have liked to do for CXL was when I noticed the libnvme integration with the NVDIM tool. The integration allowed immediate out-of-band usage for all the commands it already supported. That was pretty nice. But yeah, other than that, we talked about the integration of both libraries and NDCTL, but it just never really clicked for me because this was so much more with the Wild West than exactly.
This will be a fun loaded question. So in the context of enabling, I guess, some vendor-specific things, are we going to keep that kernel warning splat the first time you run one?
But the position has evolved. Okay. And so at Maintainer Summit, we talked about the device pass-through topic, and we're going, and like CXL is one of the example drivers to get that new subsystem upstream. Okay. And so there are green rules about it, like this is to enable things that are not the primary function of the device. This is to give you access to vendor-specific things that the kernel should not care about yet, kind of things. It may care about it later, but yeah. So that we're going to have a path to have relaxed and more allow vendors to pass their commands.
This doesn't fit in that category at all, because this stuff. No. But if we did use the firmware control for this, which is something I chatted to Jason about, it's certainly a potential, but it's not the normal use case. This really is, we win. There are no rules. You'll blow yourself away if you turn it on.
Right, but there will be no splat.
Right, yeah, I mean, like, if you turn on the BMC mode, then all of a sudden this firmware control thing can do anything at all. Right. Yeah.
And we had talked about a config BMC or something along those lines.
Right, to say like, this kernel is going into a security model where we absolutely trust this thing to either destroy everything or be well behaved. Yeah.
Yeah.
Any distro folk like to comment on how we restrict this to keep it on BMCs? Not looking at any distro folk in particular. Apparently not. Very wise.
And yeah, here I have an extra slide for anybody who's interested in the MCTP Linux stack. I think the one kind of quirky thing we have is the VDM stuff, which is kind of passed down through the switch, which does the MCTP VDM method. So I think that there's lacking a host-defined the host-defined spec for VDM. I don't know when that will be addressed, if ever.
So there are host controllers that will issue PCI VDMs for MCTP, if that's what you're asking. They exist. The problem is no one's ever published a spec. Now, that was the open question earlier. I think it's fair to say we have one, but it's not in a state for reasons of its use cases that we would. I basically have no way of testing the hardware. So yeah, if anyone can fill that one, I don't think there's any intent to define a general spec for it.
Okay.
So it's always going to be some magic platform device or similar.
I just have a question about how do you approach discovery. You said you do auto discovery of finding all the endpoints, MST endpoints. Okay, so can you explain how?
DBus.
So do you rely on the DBus infrastructure
Yes.
on kind of a BMC type?
Yes.
Okay.
Yeah, DBus does all the magic there.
Yep.
It was all added by the OpenBMC folk.
Yep.
So hopefully they're happy with it.
Right.
Just fill in that. It's not libcxl, is what we said, because I failed to throw the microphone fast enough. Okay. Any last questions?
Yep, that's all I have.
Okay, well,
Thank
you very much. Okay. There you are. Yep. Where's it gone? There we are, benchmarking. Oops, sorry. This is me checking we had the right slides earlier. There you go. Oh dear.
Okay. Hello everyone, my name is Slava Dubeyko. So CXL benchmarking. So Adam raised this topic recently, and I realized that this topic is pretty complex. It's multi-dimensional problem.
Maybe just angle the microphone.
Okay. How now? Better?
Just shout a bit louder. It'll be fine.
Okay, so Adam raised this topic recently, and I realized that this topic is it's a complex problem because, for example, it's multidimensional. Because, for example, we try to ask multiple questions about CXL. For example, what is a killer application for CXL? Or, for example, how I can make my application CXL agnostic? Or, for example, what can I do if I would like not to change my application, but, for example, achieve something like better performance using CXL, or maybe not degrade my performance using CXL. And also, for example, how build my CXL infrastructure, or, for example, how to test my application for CXL if I haven't CXL memory or I haven't enough CXL memory. So it's a lot of questions. And, for example, in the future, potentially, for example, we can try to maybe do continuous benchmarking in the background, try to detect maybe some bottlenecks or performance degradation of existing infrastructure. And, for example, if you would like to decrease TCO cost, for example, by using more CXL memories and local DRAM, so how to do this? It's a lot of questions. And, for example, if you're considering some target use cases, potentially it could be huge relational databases, social networks, in-memory databases, artificial intelligence, machine learning workloads. It could be a lot of different workloads. It could be now, it could be in the future. And, for example, currently we're trying to, for example, do sharding, place something like a lot of memory in every node. But in the future, we could have something like a lot of CXL memory, maybe some computational power. It could be disaggregated architecture. And it could be slightly different environment. And the problem how to do benchmarking, it's slightly complicated problem. So if we considering any application from something like abstract point of view, so any application is something like set of threads. And if you're talking about memory, so any thread can locate memory at some time point, can delocate memory or free memory at some time point. If memory was allocated, then application trying to access this memory, read, write, do something with data in this memory. So from the memory point of view, any application have something like a memory access pattern. And for example, it's possible to see that it could be multiple threads. It could be some number of memory locations. And it's possible to summarize that, for example, we could have some number of parameters that we can use for, like, first of all, to identify memory access pattern and then try to optimize this memory access pattern by maybe something like modification of these parameters. Because, for example, as I mentioned, it could be some number of threads. First of all, memory should be allocated. Allocation could happen by using some granularity. Usually, then, for example, we have deallocation at some time point, and between allocation and deallocation, we can access memory, and memory can be accessed with different granularity. So finally, it's something like some multi-dimensional space that we can first of all detect, we can record with memory access pattern, and then we try to play with different parameters to achieve something like maybe better performance, maybe could be important not to degrade performance at all, and also potentially it's possible to play with something like memory allocation policy, because it's possible to allocate from different types of memory, and memory something like migration policy. So if we can, for example, detect memory access pattern, so then we need to try to optimize this. And it's possible to see something like maybe two fundamental optimization problems. First of all, of course, if you would like to use CXL memory, we would like maybe improve performance, or as a minimum not to degrade performance. And it means that if we can detect memory allocation pattern, potentially we can see some maybe repeatable sub-patterns in this memory access pattern, and then we can something like find or maybe patterns with more priority, for example, really slow patterns, and we can try to optimize namely these memory patterns. And the goal of optimization, namely to decrease the amount of time that we spend on execution of our algorithm. It's one of the potential optimization problem. Another one maybe, because for example, if we have CXL memory, it could be different type of CXL memory. It could be local CXL memory, it could be CXL memory under switch, maybe under two switches or something. And finally, every type of CXL memory could have something like own latency. And it means that we could have something like several types of memory with different latencies. And the problem here, for example, how many each type of memory we would like to use, or how we can build our CXL infrastructure with the goal, for example, maybe memory to achieve better performance by means of sharing memory, maybe achieve better performance by means of some optimization. So it looks like that optimization problem could be that we have some memory access pattern, we have some number of latencies, and for example, how to build infrastructure, CXL infrastructure, what types of memory we would like to use. For example, how many we would like to have local CXL memory, for example, how many we would like to have for maybe some remote CXL memory, and what allocation policy we can use, something like this second type of optimization problem. And optimization workflow could look like that. First of all, we need to understand memory access pattern. Then we can try to find maybe some repeatable patterns, slow patterns, and then we try to optimize these patterns by means of some variation of these mentioned parameters, or maybe take into account some potential policies or something. And then we can try to something like emulate this pattern by means of something like variation of these parameters, and then try to something like change something in these patterns and try to see could we improve performance or could we not degrade performance, can we achieve something like our goal to achieve something like best outcome. And then finally, if we can find something, the next question will be how feasible could be this optimization. Can we change our application, or maybe we can not change application, but we can change maybe allocation policy, how to achieve this best outcome. And finally, if we can change application, maybe change allocation or migration policies, and we can try to play with this optimization, and we can try to maybe achieve better performance or maybe not degrade performance. So the goal may be not necessary to improve performance, but for example, decrease TCO cost, because if you could use maybe more CXL memory that can be cheaper, then finally it can decrease the cost of the whole infrastructure. And for example, the difficult question, for example, how to emulate CXL memory, because if you haven't CXL memory, or for example, you would like to play with some type of memory, so how to do this? So there are multiple approaches, but not every approach looks good, because some hardware prototype could be not easy to build, or it could be not flexible. RAM disk, for example, remote RAM disk could be not so good, because it could introduce significant latency, and it could be not so predictable. And if we talking about GNU emulation, so finally maybe it's good for functional testing, but for latency management it could be not so good, and for benchmarking it could be not so useful, I think. So maybe my guess that maybe some mathematical model can help, and this model can be aided by maybe thinking about list data structure, because, for example, if you would like to manage latency, for example, by adding some number of items in the list, it's possible to increase latency and manage latency in some more predictable manner, from my point of view, if we consider something like different types of persistent memory, so it not so maybe more not so flexible. It's possible, for example, doing swapping, but in this case, the question how to normalize the result of this testing, so or benchmarking. So potentially, maybe a mathematical model plus list data structure could help. And finally, if we, for example, know our memory access pattern and we would like to do some optimization, what is the potential way to do this optimization? So first of all, it's possible to consider changing in allocation policy by means of selection of different types of memory. And also second direction could be to use some migration policy between different types of memory. So it's possible to consider multiple directions. For example, if we're considering size, so maybe smaller sizes in local DRAM, bigger sizes in CXL memory. For example, priority, but who will define this priority? Maybe application can do, maybe some other subsystem. For example, higher priority in local DRAM, lower priority in CXL memory. Also, for example, if we have a lot of CXL memory, we can prefetch some data into CXL memory, try to use this memory. Prelocation policy, for example, if we could allocate memory by big chunks, so finally it maybe could help in some way. And also, for example, lifetime based allocation policy, if, for example, some memory or some data can live longer, then it could be placed in CXL. If it's shorter, in local DRAM. And finally, for example, again, it's possible to play with lifetime. And if we can define that this data will be long-lived, then it should be placed in CXL. If it's something like shorter time, it could be placed into DRAM. And maybe it's possible to use something like file system-based policy of management. So finally, it's possible to consider something like such CXL benchmarking framework. So first of all, it makes sense to detect memory access pattern, or have some subsystems that can do this. Then it's possible to have memory access pattern emulation tool, because if you know some number of parameters that we can vary, then we can do this emulation. Then we can use CXL memory emulator and try to benchmark our memory pattern on this. And maybe finally, because it could be multiple iterations, so maybe we can use some machine learning subsystems that can do this for us. And finally, we can try to solve multiple problems. Maybe we can try to optimize memory access pattern. Maybe we'll try to build our CXL infrastructure. So this is something like potential framework. And also for the future, maybe Fabric Manager can be considered like benchmarking subsystem in the background. Because first of all, if you are talking about CXL, mostly it will be disaggregated architecture. It could be something like multiple hosts accessing with memory. So finally, Fabric Manager looks like the main point of doing this benchmarking and doing such management. Because also it's important not only try to optimize application, but finally detect how CXL infrastructure works. Do we have some bottlenecks or some degradation? Should we do something about this? And so on. And I think that open questions, for example, okay, we can do some emulation, and the main question, for example, how to do normalization of these results, and how good is good numbers, how bad is bad numbers, and finally, how to something like achieve something like real life optimization results. So I think that CXL benchmarking is a complex problem, and I think this is my open questions for discussion.
Yeah, so I know a team in Meta that's been grappling with the similar problems for a few years, and they released something called DC Perf recently, which is a benchmark suite. What's more interesting, though, is how they generated the benchmarks. They used a number of tools and techniques to do that, and I think they expressed interest in, open sourcing. First, describing how they've done it and open sourcing part of that tooling stack. And I agree that would be a really cool thing to add to a Fabric Manager or Fabric Controller kind of entity that could talk to host agents and enable all this machinery, extract interesting metrics and traces and so on from applications. But they have some very interesting techniques that they used for that to make it reliable. So they use it to predict performance on future iterations of hardware.
Yeah, sounds good.
In the end, it's again an optimization problem. And funnily enough, this is precisely what AI is about, isn't it? But the more interesting question is, do we know what we want to optimize for? Do we know the knobs we need to tweak? And if we know, do we have hooks for tweaking it? I discussed it briefly with Jonathan. Currently, all the measurement we do within the kernel are centered around latency. Bandwidth would be a good value to measure or to tweak, but we have no way currently how we could even measure or change bandwidth. It just happens to be. How would you do that?
For bandwidth control, we do have the advantage that some of the stuff done by res control allows you to tweak the bandwidth on normal DRAM controllers so that you can do, we've done a bunch of work on this when looking at some of the migration stuff, and you can tweak them up and down, and you can plot beautiful graphs because you can cap it.
But the problem is, you can't really tweak it. You can set it, and then the only chance you have, either you do the operation or you don't. You can't tell the operator, you can't tell the write, oh, please go slower.
Oh, no, it does. That absolutely does that. It will just throttle on the queues on the memory controller, and it will push all the way back to the CPUs.
Oh, okay.
So, yeah. It's not always available on all hardware, but quite a few platforms do support it. And it gives a line. That's the one thing we can do is bandwidth. Latency, you're kind of typically capped at whatever the system does.
For that, people use techniques like the 2 NUMA nodes, right? And then they twiddle the BIOS settings to... Yeah.
I have a question more general about the memory, back-end memory for the CXL here. All the here I saw, it seems as that the CXL memory is slower than the DRAM there. But yeah, is there like a different way, like actually high bandwidth memory as the back end of CXL and?
Well, Hans commented on this earlier, and in fact he staked his hand up, but I'll let him talk about it then. And I thought he wasn't paying attention.
Oh, I do. Well, at the end of the day, it's all down to hardware. And surprise, surprise, you only get a benefit for CXL if you're using as much hardware as is available. You will not go into the trouble of inventing your own kind of hardware or DRAM for CXL. No, you will be using normal available DRAM. That's kind of the point. Why would I need to do something else? Which then also means that, well, we already have a DRAM connector, and that's normal DRAM slots. So you'd be hard-pressed being faster than your normal DRAM slots. Because you're essentially, I mean, the idea is that this will be the optimal way of talking to it. So I don't really expect them to be significantly faster than your normal DRAM. That would sort of imply to me that the manufacturer really messed up.
I happen to work on the NVIDIA stuff, of course. The GH200 there, they actually kind of upset we. Like they are using the high bandwidth memory. It could be like 3.5 terabyte, and NVLink C2C goes to the system memory. Yeah. Okay. Yeah. So that way, actually, the device memory is way faster than the system memory there, and.
For these devices, yes.
Yeah. But why CXL don't do like it's still?
No, it does. You will if you use that for CXL, you will find this faster. Yes, sure.
So, okay.
But from that side of things, if you're doing conventional CXL PHYs, etc., you won't. You will find it's perhaps faster than inter-socket stuff, but you're not going to get there. Yeah, it's fundamentally a PCI PHY. However, there are certain standards that run CXL protocol over entirely different physical stuff, and at that point, yeah, sure, you might be in a situation where you might put HBM down. But at this time, most of the stuff is focused on stuff on the PCI PHYs. I think. If anyone has any other devices, now's the time to shout. You may get extremely high bandwidth because we do have the option to interleave an awful lot of CXL devices, but the latency is always going to be capped. Yeah. Well, it's usually the host end that's the problem. It's just how many things can you wire up because it's pin limited.
I think this is a problem. How to be faster to using slower memory.
Any more questions? Okay, so on that note, I think we'll thank the last speaker as well. One quick announcement, which is just as we wrap up, I got the two magic gifts for the things that promoted most conversation. So one goes to Alejandro.
Well, thank you for awesome.
And before he runs off, one goes to Ira.
Thank you.
So thank you all, and maybe we'll run this again next year. Depends if someone's interested in running it. I've had enough. I'm done. It's a one-time thing. He did.
Are you available in the afternoon to demonstrate the artifact?
Not immediately, because we've got a session immediately after.
Maybe like around 6 or not 6:30, 3 or something like that.
I've got a birds of a feather at 3 with Lucas on device attestation. So maybe after that. Yeah. After that would be cool. Yeah. Oh yeah. It's a constant. I never know what I'm expecting. But yeah. Absolutely. Cool. Yeah.
But at the end, once you try the device, is that device able to do what the device does? I mean, accessing other kind of the memory that device couldn't be doing. So actually, at the end, some kind of extra technology, not for the translation, that's for saying, okay, we're using that memory, that physical memory, and we're going to access that. I'm not going to do anything with the memory, but I'm going to check that address, you can use it. So I don't use what's going to be the actual system task. I think. I guess it shouldn't because it's not going to do the most other thing So there are two things. The host memory means that's by the device. And then the device is caching, sorry, so the device, a device caching memory. Okay? Another way is the host caches memory. That you can so it's two packages to cache. Can you send me back is for the device caching host memory. So that is no cache but actually control. And the other way is the device that is controlling the coherence is in charge inside the device. No, I think the device. In the device, inside the device, there is that and you implement the potential emergency control over its memory. So the host can use it, but the device is not the host. The bus.
I'm trying to stay away from that. Pulled in from where it all
Snoopy, just for knowing which device is using which memory in the host. So that kind is not the memory content, but memory accesses by devices. So if I otherwise I'm accessing this part of the host memory, the host needs to know. And then there is Snoopy caching for that, but not for the content, but for the knowing that you are using. So it's not a class about content, it's not a class about
first step, it's when you make for files, 4K instead of 2 megabytes. I said, you must have changed the log size. The log extension is also
well, there's no bus here, it's the 6 cell path. But that's
everybody's got to be able to read the log.
CCI is not a bus, but CCI is path.
when,
Yeah, so packets go to from point to point. Different protocols.
If it's a single DAX device,
Yeah, so the CXL task is quite confusing because you have these kind of two things there. The host caching device memory,
subordinate to on the other devices.
the host keeps control of the coherency for the host memory, but the device
But it's always in the same
is
place.
in charge of the coherency
Going to
for...
So if you can see this block on the one true
No,
device,
there are
you can
different.
see the log, and so you can.
So there are different things.
That's that's the whole thing. Is everything you need is in the memory. Yeah, sure.
Yeah, that's the point. That's the point of all this, that you can see what the other is doing. But you need to implement the coherency of the system. As you say, okay, at this point, I'm seeing the last data that memory address current. And the protocol allows you to do that. But yet, the device doesn't do the right thing.
And then
Doesn't do the right thing.
so you can reboot the master.
So the coherency protocol is
Replace the log.
that uses to implement properly the host and in the cloud.
You're a thinker in this space. And, you know,
well, we have one.
So what I would call memory allocation is really.
I cannot talk about it, but no, I mean, because it's a really specific, it's a Ethernet device with 6 stations.
Because it's, we think of it as sparse.
So, no, in Infinity, it's Ethernet.
It is memory allocation. And that's actually also true.
And we are using CXL, we are liberating
and so
CXL for sending and receiving. So, it's not time to restart to it's quite confusing. If you don't go into details, but we have, at the end, we want to have 6 cards and 6 men. 6 men for sending, 6 cards for receiving. But also for because some packets are the goal from some specific packets is about low latency. The low latency you can achieve, and then you have VMA for bandwidth.
Yes, because there's no conflict for TRV and CAS. There's no conflict for the LPC.
And for that, the way that was saying that so the device has IONUs in place, you will have an IONU domain, but you cannot mix the 6 advanced VMAs addresses because you need to differentiate them, and this is what is not there, and we need to implement. I think we need to implement.
So these guys don't require permissions from them.
Something else needs to be done.
Yes.
But for security, of course.
When you think about
Security, but even without security, you need to be sure you don't give more physical addresses than the host can know. So you need to, okay, yeah, you can use it, but how big is your flash? 16 gigabytes. I'm afraid I have 1 gigabyte for you. So that's what I can do. If you don't have that control, through the ATC service, you could have more than that. But then the coherence is not going to be there.
Oldest one.
So that is the reason we need this kind of wrapper in the middle. I don't know how to do it. We need an extra step in the IONU VMA allocation for that.
I still suspect.
That's what needs to be properly discussed and implemented.
Yeah, I think if there's like a standard, the Galaxy standard property, they are property want to do that.
So you're working
COVID.
Why are you interested in working?
Understanding with the reader, where the reader knows the situation. Another interesting area is there are clearly cases where you don't have to care.
It's not supported yet.
How did you there's no which device?
Well, so we have a device, a real device, yeah, that has support for 6LN and 6LN. But we are not supporting that yet in these spots. But we have a real device. It's an Ethernet device that supports both protocols. And yeah, and we can leverage. We want to leverage itself for sending and receiving. It's a smart, well, it's not a smart, but it's a high performance. So yeah, 6L is for lowering the latency to the minimum possible with the current hardware. And yeah, so we want to have the 6L cards. Apart from our own problems with the design, physical design, the kernel needs to run but hopefully it will be the following months. I wanted to discuss, I don't have time, but if you look at the last slide of my presentation, there's a proposal for accelerators for supporting the class. How am I going to test that? I have a physical device. So then the design is there, but we don't have it. The chip is not back. So we need to rely on emulation, hardware emulation. But yes, we can emulate certain things with implementing my email is in the slides if that guy needs more information or want to discuss something. Okay?
That's very helpful to simplicity. But a side effect of that is I can't remember how difficult it's about to write. And the typical POSIX case is we don't know how big a file is going to get. The file system doesn't know. And in a lot of cases, the app doesn't know. They just start writing. And so today the answer is, like for that RocksDB demo, you create the RocksDB and you persist it to files, and then use the FemFS CLI to CP it into FemFS. Because at that point you know the size of the files, create them, you're all good. Then you tell RocksDB to unmap it. But on our list is to take a look at how hard it would be to hack RocksDB to be able to create a file natively in FemFS. It already has a way of like having, I don't know if the terminology is right, but a master and subordinate instances where how you should call them what it has. It's already possible. And because in the end, So, and you're absolutely right. So, in fact, the way I well, but there's some big advantages to that. I mean, the RAS effects of that are great because, you know, and in fact, the way allocation works is that it doesn't keep a persistent copy of the allocation bitmap. It plays the log and builds a bitmap, does the allocation, makes the log entry, throws away the bitmap. And like for CP minus R or CP with wildcards, there's this subsystem called lock log, init lock log, and it locks the log, builds a bitmap once, and then does all the copies. Right, so that's pretty efficient. And it remembers where it left off, so it's pretty good at when it looks at the bitmap, it starts looking at the right place. And then with the strike stuff, prior to the strike alloc, which is new, it ended up, allocation was always linear through the file because if you're not allocating multiple extents from one would do. And so, but now that we've got the striped thing, we have non-uniform allocation within the file, within the bitmaps, and so that's I mean, test coverage is almost 90%. Oh, that's, yeah. So, yes. Yes, sir.
My colleague asked me about he asked me in a situation where a big memory and there's more than one host, and that host opens that memory in that situation, we can share some part of the memory, right? So in that case, and multiple hosts want to able to update share solution, and they have to in that case. So my question is about the cache collision. So the colleague was wondering if we have to equip the support of the transparency for whole region for sharing, or just we put it into a small area for lock for synchronization, and through that you can update the shared area. So there, I just tell you two options. So which one is feasible, and what do you think of, what's your opinion about that?
Sure. So both approaches are feasible. When it's multiple writers, there's hard problems, right? So it's not implemented yet because there aren't any CXL3 devices yet, but hardware cache coherency is going to be available in CXL3. We've yet to see whether people will build devices that support that, but I think they probably will. So when there's hardware cache coherency, then that's kind of it's the MESI cache coherency protocol. And so if a host requests exclusive access to a line, the device will do a backend validate command to other hosts. And that tells them invalidated, or if it's dirty, write it back. Now, so that gets you part of what you might need. And then it's really down to the use case, because I mean, like the Redis app, they just decided we don't want to worry, even on one host, we don't want to worry about cache coherency, and we don't want to have to lock in order to maintain integrity, so we just make it a single thread. So, and I want to point out that the things you would have to do to maintain integrity are expensive enough that sometimes you avoid it even when it's just one host. So if you do it on shared memory that's outside of, that can be seen by more than one host, it's going to be more expensive. Another thing is I don't believe atomics are supported in CXL. So, so that's a thing you want to be concerned about.
So, and we're already trying not to do that when it's just, because on a single server, coherency and barriers and whatnot.
Try to shard.
Yeah, which you can do sometimes. And so, now, but there's patterns that are less problematic than others, like append only.
Yeah.
Append only, you can, distribute information about where the cursor is for appending. And so, in the FamilyFest log works that way, because it's just a metadata log. So a metadata entry goes in when there's a create a directory or create a file. Right now, that's all there is, but there will be more. And so when that log gets appended, the clients, when they play the log, they'll read the log header and they'll see, oh, there's a new entry since I last played. So they'll try to read the entry, but the entries are sequence numbered and checksums. So because there's a chance that the last time you played, the cache got loaded ahead, and so you might have a stale cache line where the log entry should be, but you'll catch that because it's checksum, that the sequence number is under checksum. So that's how you detect that. There's a test program called PCQ, stands for Producer Consumer Queue, in the FamilyFest source code. It's used in testing. That does circular queues the way you do with HBAs and NICs and stuff. And again, it uses sequence numbers and checksums. And on actual shared memory, we do see rereads because, but when you reread.
I think this is like similar approach that you use for these kind of like shared data structures on like traditional DSM, where you read this like sequence number and check whether it's the same as before.
Right.
Yeah.
But for this reason, I don't think shared memory is a killer app for message queues. I mean, it's usable.
Yeah.
And it may be good for certain cases, but it's not going to kill the performance of InfiniBand, probably. Now, so let's talk about then what I think are sort of the same use cases. One is, I'm going to publish a data set and then let your servers access it. So in order to do that, I create a file and write the data to it, and I CL flush the whole thing. So that should cause it all to be written down.
So right now, the creation of the file is only allowed for the master.
Right.
So like even if you want to create a new file, you have to send some like command to the master.
Right.
To ask it to do it on behalf of you. Right.
Right.
I see.
There are ways we can generalize this. Like if there's multiple CXM devices, there could be a master. I mean, the reason there's one master is because it's two hard problems: space allocation and log append.
Yeah.
But there could be more than one log. And there could be space owned by me and space owned by you, and I can log in my log and you can log in your. You could do things like
That
that.
will also introduce fragmentation. Along different laws.
Yeah, I mean, if you don't consume all the space that you've got reserved for you, then there's space amplification.
Then I guess this model is that you have a very like ample 6L extension space where you can actually shard it.
Well, yeah, I think of it more like a lot of the use cases are going to involve. I've got, let me take the example I gave in the talk. Well, actually, this might be more of a long-running thing, but I need to make a 6 terabyte database in memory query. So I just prepare the database, write it to a FamilyFest file, flush the cache, and if you use FamilyFest CP to put it there, that's taken care of. If you write the code that initializes the data, then you need to do a CL flush. And then I let clients mount it, play the log, and go. And so if they're only reading, and if the data is not being modified, then you them, then that's the work.
So I guess in this case, your performance would be like similar to directly accessing the DRAM.
Yeah, it is full DRAM. That was a fundamental requirement. The handling, because what a file system does is it handles mapping faults. And so those have to be handled fast. And in the case of FamilyFest, So it works with the IO map interface to DevDAX, which I patched into character DevDAX. It was in QMap, but not in character DevDAX. Well, there are mapping faults. So because the thing is that the process's page tables and TLBs all get flushed out. I mean, every time a process schedules, it loses its page tables and TLBs. And so every time a process is scheduled back in, you get a lot of faults, but they're all the most minor faults. Right. And so, and FileMFS caches that, and the fuse port, assuming it's successful, I think it will be, will bring that into fuse.
So you're saying that in the page you did in the fuse, does it relates with the performance?
Well, that's fuse has to cache every file that has metadata cache. It has to be full cache. And if that's true, then fault handling will be exactly as fast with fuse as it is with FileMFS as a standalone file system. And the fuse maintainer already understands that and still wants it. So it's kind of hoping you do.
I'm very interested in this stuff because it's somehow related to what I'm trying to do. So basically, right now I'm trying to build a shared memory pool for like our serving system, so where you actually have a lot of these append-only data from the models. Right? So I'm like curious about how you basically test your like FileMFS. Is there a way to use it right now?
Oh yeah. Yeah.
It doesn't require 6 or 8 devices.
No. So a lot of the testing and development is done with pseudo-DAX devices. Map equals size dollar offset, or maybe it's planning, I forget. But and also virtual machines that have virtual devices. That's spec'd into VirtIO. So in fact, we're having a big discussion. VirtIO doesn't have a way. It has a way to make a PMEM device in a VM that's backed by a file or a DAX device or anonymous memory, any of the above. And so I can have a PMEM device in a VM. With a PMEM device, I can use MDCTL to convert it to a DAX.
Yeah.
And then there you go. And if it's file backed, I can have multiple VMs that all have a PMEM device backed by the same file, and now you can test sharing. You won't find coherency problems that you will find if it's actually CXL. But yeah, so that's all doable. And FileMFS has the test coverage is almost, well, so kernel code is the heavily traveled code is the fault handler. And by observation, they're full coverage on that. The user space code, we're at almost 90% coverage just from our unit tests and smoke tests. And the smoke tests, qualitative statement, but they're pretty good. Yeah. Well, so
mistake we're likely to make is if a device has a terabyte of capacity, only a small amount of that will be available as cache memory.
Otherwise, it'll be super slow, I guess.
Well, it'll require a lot of S because
Or you should put how many amount of
10%,
10%,
maybe 1%. I mean,
maybe 1%. Okay, 1%.
but the thing is, so if you're just reading, I had a bullet, but I didn't say it in the talk. If it's multiple readers, no updates, then hardware cache coherence is actively bad because it will be taking back cache lines, and you don't want that. That's overhead. And I feel like I've been being cagey, but really what I'm saying is you have to talk about the design of what's being shared and what's being updated and what does decentralization look like in order to have a better answer about it. Yeah, it's kind of what are you doing, right? And I don't expect you to tell me that, but I mean, it's, you know, you want to go, but because you probably need to do some good design work to do something that's not done. And again, I mean, so when I started contributing to the CXL stuff maybe 2.5 years ago, and started collaborating with some teams that were looking at shared memory. And my opinion was they were doing it wrong. They were thinking about it wrong. In order to make this really valuable, you've got to be bulk writing back everything for big data that then gets accessed. And then from time to time you generate new big data. So pipeline kind of out there. Another thing that works is
basically you said it's kind of, it would be like your programming model would be something similar like an error sampling.
yes, very much.
I see.
I mean, that's a great pattern for this because, you know, you get the data prepared and you write it out and then that's read only until it goes away. And okay, so I don't need to delete, but we could do that. In fact,
Yeah, I think if you like do bulk data,
right.
As long as you amortize the cost along the spreadsheets.
Right, and RocksDB actually, and what I did when I started at Micron 10 years ago was led a team that did a very cool LSM from scratch. Key value store, it's called HSC, it's still out of Micron technically so bad. But it did a lot of other things, and but so I guess that's a side observation. Taking RocksDB, it already has a mode where, I don't remember what terminology they use, but say there's a master instance that you can do inserts. And then you've got some subordinate instances of RocksDB to share the same files. It's quite straightforward for those subordinate instances to query against the same database, provided that you don't care about them seeing updates. And then from time to time, we tell them to reread and update to the current. As long as you don't delete files that they're, because files when they're deleted, that they may still be accessing, so you got to protect against that. RocksDB already does
This model also assumes that application can tolerate some of the delays from this data.
Right. But there's many applications
Which can do this.
where the query load doesn't have to see inserts within the last hour. Yeah, and so, and once you get your head around these things, there's an opportunity to, you know, to rethink what problems fit in them. You know, you have a lot of this. Yeah, okay, multiple writer is hard. Even one writer is hard if there's readers.
But I think also if you have this very large extension, like terabytes of scale, multiple writers should be working on like different
things. And if it's different things,
it's very unlikely that they are actually synchronizing all like same stuff.
Right. I mean, you need to
know
that they're not. Yeah. But it's a pretty common type of a use case where a data set may be getting modified by one entity.
Yeah.
And if they want to hand it off to another entity that's on another
Intel, all you've got is CL flush, and that's either a write back or an invalidate depending. And so you just have to trust that it'll do the right thing. It would be nice if they would give us an invalidate, because if I had an explicit invalidate, then because an issue you run into, especially once we're at DCD, and it's not specifically a DCD thing, but there will be some allocated space tagged to capacity that is mapped over HPA space. And then eventually that'll get freed. That'll get some more tagged capacity, and it may map into the same overlapping range of HPA space. If it's possible that there were still cache lines loaded from that previous mapping, then you do have a problem. And that's where write back and validate comes in, because if you do it while it's not mapped, then it'll get blown away and it's not possible to write back, so it'll just get blown away. And that's why if they give us an explicitly validate, then if there's stale data in the cache that's dirty, then it's, yeah, just invalidate it. Because you know when you need to do that, or you can.
Yeah, so last year I think it was in OCP. Micron has shown an example of these 603 devices where you can like share the DRAM within a rack. Is that stuff still like experimental? Is there any like plans? Or?
Yeah, it's still experimental. The non-experimental stuff will be CXL3, because once it's CXL3, sharing is supported. But I mean, there's a chance we'll have a demo of CXL devices sharing a switch at supercomputing or OCP or both. We have it.
How many devices are there? How many devices are supported by this 6L switch? Yeah, I'm very curious about like how the routing problem is like implemented.
So that, I mean, you can imagine it getting arbitrarily complicated. The switches are kind of being uploaded right now, and so it's 4 devices works. Beyond that, I'm not certain. Yeah, which technically doesn't support sharing, but you can do it. You just doing something that's not technically supported. And in my opinion, switch topologies may present problems by making the latency really high. And therefore, in my opinion, and we talk to hyperscalers who have the same opinion, it makes sense to build multi-headed devices with fan-outs of 8 or 16, but not more. I don't know of anybody that's asking for fan-outs above 16. The idea just being, okay, so since it's a multi-ported device, you should have lower latency than if it's a full function switch. And then you can do pooled like top of rack memory appliance that is shared within the rack, but not the latency.
So would it be the form of this like 6L switch? Would it be like a single identity on like inside of the rack? Like a traditional switch, or?
I don't know if I would answer that. I mean, there's, you know.
Is there like POC of this stuff? Like
yeah. Look for H3 and X. And H3 is making a memory appliance that has some host ports and theoretically could take, I don't know, 16 or more like in CXL devices. The reason I did any of these in Family Fast was because the switches right now just compatible the devices together. With the Family Fast interleaving, if you can configure the allocation to interleave across packet buckets, you could.
Hello, good to see you. I've heard your voice many times.
Feel free to reach out or have your friends.
I was trying to cool kids in the back.
You had a really good AI. later.
As far as I know, yeah. Thankfully, there's still ways to tell if an image is A.
It's hard to decide where to sit because
It's very
I've been in other rooms like this. Yeah, they're kind of weirdly proportioned. You know.
like this.
It's a big room for his fun.
It's maybe better because you're not like way in the back so you can't hear.
Yeah. Well, I was thinking because I was in another one today, and I was like, if it was this way, yeah, then people would be like really far.
But I'm sure the people watching the recording of like the crowd camera are gonna get some whiplash from it going back and forth.
I don't know. It's a tough call because you sit by the speaker and you can't see the TV.
Just everyone agrees to sit on like the far left side of the room.
Yeah. Good idea. How's it going? Did you get your meeting without problems, or?
Yeah, my first leg was delayed, but then they delayed the second one as well, so I didn't miss anything.
Okay.
I was an hour late, but that's it. So.
Coincidentally, the second one was delayed.
Was that?
Just a little bit coincidentally.
Yeah.
Delayed. Just happened to work out.
I'm thinking it's a company delayed.
I guess it's
delayed it for me.
I'm sure they do that when there's a lot of people that have that connection.
Which I was kind of surprised. I think I was the only guy from Sweden going to this phone thing.
Where was your connection?
Okay. I was worried because there's so many flights from but it was great. From uploading that we're on it, actually be like very quiet. It was like once a week.
Oh wow.
Yeah. It's Sweden.
super happy that I told you. Like, you could have told me that.
I'm working on other things. They sort of have like the internal teams like insulated from what they ask the contractors to do.
But I'm so tired. Every meeting we have, I'm like, just go ask something. We'll tell you something.
Leading the show.
Yeah.
Yeah.
I agree, and I have talked to David about some things, and like I said, for a few months ago, write the bindings first. You have to actually like follow the bindings.
Yes. And just like certain things you need signed off by, and you need the author to match the who's ever copyrighting the actual binder code.
But like, I guess I don't know if they're ever actually like this thing upstream.
Hey, Pamar. Hey.
See you anywhere. Are you supposed to be? Is there supposed to be a computer in here?
How did you do the presentation with that? But if they're not going to upstream the e-input chips tree, then why create that?
So, do you just change the slides?
Yeah, I uploaded the slides. So this is the.
Okay. So there's a clicker in here. Do we use the clicker? No, the clicker's got the thing in it. What do we do?
Maybe it's just maybe I can.
You have to take the presenter, maybe?
I can barely hear you.
Basically, feel free to tell them.
No, that's not even, it's just.
Any, Hey, can you try now? I made the room as presenter.
Are we supposed to log in or something? I can barely hear it. Is this the camera?
Can you hear me, Pamar?
Yeah, now I got the camera.
I think that's the one that follows the speaker. The microphone box.
Okay.
Whatever it's called. The ball. I don't even know where the
there's one back here. Okay, but they got it apart. It's probably like charging. This one here? Yeah, it's probably charging or something because it's got it in bits. Yeah. Okay, so at least that's over there. This is falling, but that's okay.
You want me to be the time guy?
I mean, I'm not going to run out of time. So.
Was that you? You're not.
I just went with the no version.
Oh.
Just keep it simple.
Yeah.
No room for ambiguity. I'm going to the bathroom before we start. So I still don't quite understand what we're supposed to do with the slides.
Pamar, can you hear me?
Yeah.
Can you flick this?
So I uploaded the slides and I changed the presenter to the room.
Okay.
So clicker should work
in the
now.
room for us to. No, there's nothing here. Is there supposed to be a laptop here?
Yeah.
There's usually a Chromebook somewhere in the room, right? Isn't that what we do? That's kind of my. If there was a laptop here, I'd be like, oh yeah, that's how we do slides. You know, I wouldn't be just kind of wandering around the room lost. Does that make sense?
I can see.
Maybe they'll bring it in here before 3 o'clock.
Usually, Steven's running around in the morning screaming about Chromebooks and stuff. So.
Like you'd think there would have been one here this morning.
There was a talk here this morning, right?
Yeah, this morning.
It was on the schedule.
It's good to see you sober. Yeah, that's what you're.
All right. Is anyone actually logged into the place we can text? Has anyone?
We're missing the.
Yeah. Has anyone actually been to one of these yet? This is my first time being. Is there supposed to be a laptop here?
Well, that's what I said. And
there wasn't the other ones. Okay, I haven't actually been to a session yet.
Yeah, I think there was in the other ones.
Okay. All right. So then that probably means we need to find Steven.
Yeah, we're supposed to have like a per room helper.
Yeah.
Person.
But they usually don't show up until after it starts. It's like every other time we've done it before.
per
Okay,
room, not so helpful.
there's like probably a priority depending on what the topic is. We're at the prescribed room, so
Usually don't get a whole.
We're on our own.
Well, we're the one after lunch, so everybody's probably.
I mean,
So there's
we
some
could
way to
start
log
by
in.
using our own laptops. And
I just went with the one slide, so I don't really need anything. You can just put it up for me.
yeah, actually, come to think of it, if Atish takes over the display,
Yeah.
that's
good
the
enough.
helper person, right?
Yeah, yeah.
That's what.
It's a little awkward to have to shout across
That's,
the
I can switch slides.
Yeah. At least for the first hour.
Do you have a link? Kama, do you have a link for your slide? I can upload it.
Yeah, I uploaded them to the thing.
Okay, yeah.
This morning. Somebody shows up with a Chromebook, but I guess that's no problem. Log into the chat.
I didn't get in here, right? Or
Oh,
did you?
me?
Oh,
No,
I didn't
no.
get in. I'm kind of
We
glad.
wish you good, thank you.
Actually, I'm very glad. Yeah. Yeah.
It was good to go because I took an Uber to my hotel, I thought. And then I went out, so like, yeah, same name, different place. That went that way.
There's more than one of you.
That's how like, yeah, this was a really cheap ride. $9, that was cheap. I was like, oh, I must be right to go.
Now, 18 more euro to get you to the right one.
Yeah, you could have been sleeping on the street last night.
I jumped in a car with Cisco people, looked at the map on the Uber driver's guy, and found like his route to the Cisco hotel that they're using. Picked the nearest street to my hotel. Just when we got there, I'm like, let me out. We jumped out. Worked great.
Should help us.
Shared nights.
It's 4 in the morning in Seattle. Hello, Atish. Turned it off. Been talking too much.
Maybe we need the little throw possible mic.
It's charging.
Oh, yeah, it's charging.
The mic is the same place as the laptop. You throw the laptop.
Oh.
Yeah,
English.
When I change this one, yeah, totally.
James Bond. But somebody will bring it.
Yes.
Okay, as long as I don't have to bring it, that's fine.
Could be. Well, I guess if you try to reach out to Afghan. Yeah, you may just have to go to our plan beats. Thank you for checking.
Theoretically, they're supposed to move it.
Oh, yeah.
Can you hear, can you hear me now?
They had some sort of like, everybody.
Can you hear me now?
Are you saying something?
There was a high school teacher that found
I sent it to him.
like I didn't see you at all. Drinking beers. You weren't drinking beers. You were failing.
That is true.
That's like, free marketing grant,
No, I'm not blocking these seats, so if you're using other than
Right. Don't worry, I'll sit right behind you. If there's one thing that's worse.
It's the tripod that's the.
So you can move it if you want.
Grippable pod.
Yeah, it's just a tripod on a tripod. It's not sort of special.
You can wrap it around tree branches or your neck.
Yeah, you probably wrap it around your neck.
Yeah. Instead of helmet GoPro, it's the neck.
Yeah, you get a picture of you in a shape.
Okay, so apparently someone's supposed to bring a laptop.
We can throw mine up there now if we want to start on time.
Yeah, I have one of these
Yeah.
Chromebook things, or not Chromebooks, Lenovo things.
And then like maybe by the time I'm done
Like,
rambling, I'll just take mine with me.
Yeah, I guess because you were talking, yeah, so,
Yeah,
let's
so-
do that, hopefully someone will show up. Mine just like does not work at all with any of this HDMI stuff.
Oh, well.
Yeah.
I haven't actually proven mine will work.
Yeah, my USB-C ports keep getting smoked by the power controller, so.
Sounds great. I'll hook mine right up.
Only person I've heard that. Yeah, it's just me. I've got, this is like my fourth motherboard on this laptop. It's really ridiculous.
Are you plugging them into the same like dangerous outlet?
No, but the one in the hotel room does leave the entire laptop chassis just like floating. You know how you get that little like.
Oh, you feel it.
Yeah.
There should be someone here hosting and hosting. Is this, but since somebody's here, I'll put it here whenever somebody wants to speak.
Then we'll throw it.
No, not seven.
That's how we're generally good at that side of
Whenever
things.
somebody wants to speak or react, please.
No, I'm probably already.
And so you first can get the microphone, otherwise it won't be recorded in the live stream.
Can you hear me now in the room?
Okay.
What is the link?
Just here to back up. So, Palmer, are you doing the unified script?
Uh-oh.
Yeah. Okay.
Just one,
Was that?
just no. That's the
Yes.
That's
perfect.
one slide.
Okay.
It's the whole talk.
Okay. Okay, so that was quick.
So you know where I'm supposed to go.
Yeah. Expectation.
Oh, come on. Killing me here.
So Tish says all it can hear is echo of himself, I guess. That's weird. He thinks it's the room audio that's the problem. So.
Atish?
Yeah, I can hear you. But I hear
Good. So the mic,
everything
the mic.
twice.
Hopefully it's fixed. It is 3 o'clock though, so I think we're supposed to start.
We are supposed to. I'm trying to figure out where to go here.
Trying to get BBB-ified.
Yeah, the BBB stuff.
Okay. I guess Tish, you want to just put because we have the sponsor stuff. So first slide should be the sponsor thing. I think Tish is in control now.
Yeah, actually, just let Atish drive if that's easier, because I'm struggling here. I'm just figuring out how to do the BBB.
Atish, do you want to put the sponsor slide on?
I guess you can't hear me just talking around the room. Yeah, sponsor.
Why doesn't it work?
Okay. Okay, so here are the sponsors. We're supposed to thank the sponsors. I guess we would not be here without sponsors, so good. There's also an anti-harassment policy that
Okay, well, it get fixed on its own, so. Hey, Andrew, do you want to say something to the mic to see if the mic is hot, see if Atish can hear you?
Testing. Testing.
Okay.
we can hear it here, so.
Atish, can you hear Andrew?
I hear him, but I hear the echo.
It's not, you said a tall.
Yeah, I can hear. Nobody can hear me.
Harassment thing up. We're supposed to talk about that too.
I don't really know where to go.
Harassment slides. Atish, can you key that up for us?
There was no Chromebook here when we got in, so we're just totally lost.
Okay,
There we go. Policy.
perfect.
Yeah. So this is the anti-harassment policy. We need to follow it. We don't usually have problems with this kind of stuff, so hopefully it's all right. I think there might be a little on the strict side. What? No, not yet. My slide is way simpler than this one. All right, I guess we can just go. Yeah, you want to just go to my talk, Atish? I'm the first talk, right?
Let's let Atish drive.
Okay, cool. We'll just.
All right, unified discovery, yeah.
Yeah.
Andrew?
Yeah.
Me? What?
No, you don't Okay. Tyler, right?
I only have a few.
Yeah, so you can do your talk. Teach will just put mine up. Yeah.
I want actually, if I teach you my slides too, I don't know, because I couldn't get BBB thing.
Here, you need to. Yeah, this is always the problem.
Talk to a t-shirt.
Hi everyone, can you hear me?
Yes.
Yeah, I can keep trying here as well.
I mean, I can try. Like, what's BBB login?
Yeah, do you actually?
Yeah.
This would be the right URL, right? Or does someone know?
Idea. You could get to it from a link on the plumbers if you.
Okay, I'll go to that.
It doesn't say what URL it is. Only my first talk is over. I have another talk. But Akeisha's disappeared on Slack. Can you just put my slides up, Atish? We're lost in here. Drew's trying to figure out how to get into BBB.
Yeah.
I can never figure out how to get into BBB either, so. That's why usually there's a Chromebook, yeah.
Alright, there you go.
Sweet, okay. All right, so just go. It is actually exactly to the second on time, so sweet. So yeah, so Unified Discovery is this device tree type thing from RISC-V Foundation. So I figured we should talk about it because they've had code and stuff, and I wanted to give a discussion here, so at least we could have something to point them to when they eventually send patches. Connor said we shouldn't talk about it because it's crap, which don't necessarily disagree with. So Atish, if you want to go to the slide. I think. Maybe not. Oh. Yeah. So it's literally just a device tree type thing, right? So it is not device tree, but it is another similar format for describing hardware. I know, that's it. So just use device tree. It's totally fine. Well, yeah, if you want something bad, we already have one, so it's even better, right?
Was there any rationale for not just using device tree? Is it just not invented here, or is there something?
Right.
Does it have bytecode in it, or it's
back in the early?
Oh, you can have this back.
This one works. Yeah, this works. Yeah, back in the early RISC-V specs, it said config string, and we had our own thing. Andrew didn't like device tree. It has those clunky things with like two 32-bit pairs, and there's no types for strings and all that sort of. Device tree is kind of weird, right? So that kind of stuff. So we had our own for a while, and then early on in the port, someone told us just don't do that, right? Doing another platform device thing is just going to be a gigantic pile of code that's not necessary, right? And we hadn't fixed any of the hard parts, right? Like the bindings and whatnot, right? People spent so long doing that in device tree land. So we scrapped it, but the spec always still said config string in there, and we just said that the config string was a device tree. But then at some point they kind of leveraged that to just do another one. It never went away. We just kind of started ignoring it, and it has kind of come back. If that makes sense. So.
Thank you. It was never meant to be used in Linux anyway, was my understanding. I haven't been to the meetings at all because it's kind of a waste. It was just supposed to be meant for debuggers.
And if they want to put it somewhere else, that's totally fine. But they've got some patches that pass it all the way up to user space to.
None of that should be touching Linux at all.
Yeah, just go somewhere else and do something else, right? Yeah. So that's literally it's my only slide. So. Yeah.
Just the one other thing is the
current patches they have for it seem to like they dump so after being told no in Linux the first time, they're now trying to put it into the bootloader. So the bootloader would parse it's an ASN1. Yeah, so it parses this like ASN1 thing and then converts arbitrary. Well, it's supposed to convert arbitrary ASN1 things to the corresponding device tree representation of it, and then populate the correct device tree property for that. But they're also dumping the raw ASN1 thing into device tree, and then looking in sysfs in the device tree directories there, so that they can look at it in user space. So I would like, if that ever comes to pass, just run something in early probe code, just delete that whole node from the device tree before we even touch it.
The answer is on the slide.
Yeah. I was trying to be unambiguous about the whole entire topic. Right, but yeah, it's like this, and like the whole convert arbitrary ASN1s to device trees just misses like the whole point of the bindings being the thing you actually have to care about, right? Like it's not the syntax of the stuff that we're saying you have to use, right? It's what the compatibility or the compatible node actually means. That's the interesting part, right? But that just got lost somewhere. So anyway, that's all I got, literally. Like I originally asked Atish for just like 1 minute for the talk, figuring that would be sufficient, but he booked them all evenly. So. Are we? No, this is a 25-minute talk. I'm not joking. We got booked 25 minutes for this, which was a mistake. It was not the intention. So.
Can you hear me now?
Oh, he unbooked me then. Sweet. Yeah, I guess we're done then. That's wonderful. I have nothing else to say. Drew?
Can anybody hear me?
This thing? Actually, no, you're one arm. I shouldn't give it to you.
I'll look at my own slides here, I guess. Because I can't see them otherwise.
Your slide should be up.
Yeah, hey Atish, can you also drive for me? Because we never figured out how to actually hook up.
So, try this. I changed the presenter to room. Try the clicker now. Can you try the clicker now?
Yeah, you can't hear you unless you get the. Unless I talk to a microphone. We can see you. We can see it now, if that's your question.
I think you said you should be able to control it.
Oh no, but I'd have to get on to BBB, which I never figured out how to do. So it's not happening. But as long as
you can hear me,
then let's just proceed. We're all good?
Yeah.
All right, so I'm going to go ahead and start. So I'm Drew, work for Bentana. I'm going to talk about heterogeneous ISA systems, so different CPUs with different ISA. It has really nothing to do with what Bentana wants to build or not build. It's just upstream-oriented talk. So, and so I'll go ahead, go to the next slide if you haven't already. Overview. I can't see very well from here where you are. Yeah, thanks. So just to make sure we're on the same page on what type of heterogeneous system we're talking about, because it's sometimes ambiguous, and I didn't use that many characters in the title, already too many actually. And so I'll spell that out real quick, and then we'll go into the discussion after pointing out a few of the challenges we're aware of and current state of stuff. So next slide, including me. Yeah, thanks. Okay, so we're not talking about the quite common case, I would say, where you have a GPU or something like that and you use like a coprocessor. That's one heterogeneous thing, and of course we want those, that's normal. We're also not talking about differences in the set of CPUs where they all have the same ISA, but they might change in power characteristics. So you might have some CPUs that are clocked at a different frequency in order to save power, but at least you can always migrate tasks among them without concern for stumbling onto an extension or some instruction that doesn't exist. So what we are talking about is the third bullet there, which is the overlapping ISA. And this is actually also yet another distinct category, would be completely distinct ISA, which does exist in the wild as well. Like if you had an x86 and an ARM on the same sock. But now we're not talking about that either. We're talking about where it's overlapping. So you have nearly the same set of extensions or instruction set across all of them, but some of the hearts are going to be missing something, and some are going to have extra. And so actually, I wrote an example there, the first bullet of the third one there. This actually does exist. The ARM folk seem to have written quite a bit of code, the CPU feature.c file, full of fun, to handle these types of situations. So it's not something that's just in research literature, although if you Google for this type of stuff, you will maybe come away thinking that, because I had trouble actually finding examples. But I did hear about some Android thing that ARch32, but not across the board. So there's stuff out there. Okay, next slide, please, Atish. All right, so this one's, sorry for the eye chart. I kind of wanted to shove everything into one so we could just sit on it for the rest of the discussion. So in the kernel, I mean, I don't know if we have a big challenge there. I mean, we need to write code if we want to support it, but that's not really challenging. And we can always change how we do it too, as long as we're not exposing the interfaces anywhere. So I wouldn't call it a big challenge, but we do need to maybe follow ARM's footsteps there a little bit more. We do keep track of each particular heart's ISO. We have a bitmap for each one that's independent, a per heart bitmap. And we also have this common bitmap, which is the least common denominator. We already have that as well. So we're already kind of on that track where we're making sure that we're not assuming that every heart has the same one. We're not quite there yet, and I can blame myself for at least one extension I can think of where we assume that it's there for all hearts, even though it's actually only technically tracked in the per heart bitmap. So I mean, we have some bugs there that need to be sorted out, but probably we don't have any real concern. The red is supposed to indicate the bigger challenges on these columns. Yeah, so maybe we've problem was hot plug. We haven't looked at it that closely, at least not that I'm aware of. Making sure that we follow these patterns that ARM does, where they have multiple states when you're bringing on new cores on whether or not you should actually bring it up at all. For example, you can actually reject it under certain circumstances when it fails some sort of a CPU feature check. So we might want to look at that. But like I said, I mean, this is all internal to the kernel, and I don't really see this being a problem other than requiring some elbow grease. KVM land, I do see one gap in KVM land. Again, the red would be the thing. So in the ARM world, for example, when you want to run vert on big little, and there's somebody said this possibly in this room, but I won't name names, that friends don't let friends use big little. But anyway, we did have problems, and I recall in the KVM time when people would try to use big little to use to run KVM, because you'd have to pin, you have to use task set to set your vCPUs to only the big or the little. At the time, actually, I was kind of confused. I was thinking it had to be the big because we were lacking vert extensions or something on little, but that's not true. They're there. The biggest problem was a MIDR register issue where it was being exposed on both, and the vCPUs would happily jump between, and there's no such thing as a Schrodinger MIDR. So you have to have one or the other. So we have to do the same if we're going to have this type of setup in the RISC-V world. We're going to need to be able to manage running guests that have both, vCPUs that can move around, and so we'll probably have to do this task set thing too if these types of things start to pop up. And maybe we should assume they will. If they popped up in the ARM world, which is a little under less experimental, crazy idea mode than RISC-V, then they're probably going to pop up here. In this case, we need to be able to provide the VMM some way to know where we're going to set the vCPUs. And so we need something, in my opinion, we need something like a way to query what hearts have a certain set of extensions. And we don't have that right now in KVM. Yeah, sure.
Yeah, so the KVM case you're talking about here with the big little, there's a related problem where even if you're ISA compatible, the fact that you've got different microarchitectures, which I think was your option 2 or something previously, if you've got silicon errata, which are specific to one microarchitecture type, you have a similar flavor of problem that you want to make sure that the workarounds are on those cores, if you see what I'm saying.
Yeah. So definitely I recall in the ARM world when you're thinking about CPU features, you're also thinking about the anti-features, the errata that you also need to manage and ensure. And this would be the case as well in RISC-V. I mean, one thing is good about the massive number of extensions that RISC-V is generating is that if you do have an errata, you can hope that it's going to be isolated to 1 or 2 extensions. And so you could foreseeably just turn those off when it's broken and not have to like say, okay, the whole heart is busted. No, well, you just disable those extensions and you keep progressing. But now this is like an errata workaround thing where it's kind of an anti-extension. And yeah, but you're right. So this is another thing to worry about, and being able to probe that through KVM would be something we should probably look into doing. This is also not a huge problem though, because it's KVM. We can do what we want there. We can expose the iOctal API. It's pretty self-contained. VMMs can learn how to do it, and they just do it. So probably the biggest problem will be user space, and that's probably what we probably need to think about the most, and how much we want to go down this path or not, what we want to expose. Different people have different opinions on that. Is Deepak on the call? Deepak Gupta? No? Hi. I recall a long email from Deepak about this, so he can chime in now if he wants. So the problem there is, how will you actually, you can expose these types of system calls and whatnot to help inform user space, what's available and what isn't, but how is it going to actually do anything with that was what Deepak was getting at. And so the question is, should we expose it? Should we actually give this foot gun to user space, or should we try to be more restrictive? And with that, I'm actually going to stop rambling because I'd rather hear other people's opinions. That's what we're here for, and I don't really have any strong opinion on that myself. So, anybody want to throw that ball around, or anybody?
Just before any other questions, I'll just say, on ARM, we made the decision that we give a truly SMP view, i.e. symmetric. So you get the lowest common denominator features present. The AArch32 case that you mentioned there is the only case we expose different features per CPU to user space. And that's only because we can actually know that at the time we load the binary, that it is definitely going to be AArch32 or AArch64, and we can constrain that. For everything else, we have no idea, because you can dynamically load a library later down the line that will blow up.
So elf load time, you look, you see it's AArch32, and now you can use it because it's a very specific case.
Yeah, and even that required a fair amount of work from other people to make work.
All right.
Hi, this is Deepak here on the web. Can I go ahead?
Yeah, go ahead.
Yeah, my question is yes, this is all nice and cool, but for who? Why to do this? There has to be strong motivation to do something like this. Then we can, once we figure out, this is the reason it has to be done, and then we basically mold the solution around that.
Yeah, so I guess the comment is wait and see, which, sure.
I want to add to what Mark said. On the ARM side, where we had the IH32 mode only on some cores, it was clear to everybody that this was a horrible idea, and everybody along the chain had messed up, and this was just damage mitigation. So this was not a design that somebody came up with and thought this was how it should have been done. This was because everybody along the chain had been screwed up, coming up with a product that made sense.
Okay, so I mean, yeah. So then one of the questions would be, do we try to actually limit the amount of code we add to the kernel to manage this type of thing? Just kind of draw a line in the sand and say we're going to manage it as if it's always common, and if it's not, that just kind of falls off. Or do we still do something like ARM, where you can really see what's going on, really kind of isolate issues, and hope that nobody really tries to use it for a feature? I don't know.
So my opinion on that would be, from the experience on ARM, I would assume that nobody should be doing this, and once somebody actually needs it, there needs to be a decision how to handle that specific case. And then when the next person comes, that can also be dealt with individually. But I wouldn't try to make a plan for it until it has happened.
2 votes for wait and see.
Can you hear me now?
Oh, yep. You want to speak again? Go ahead.
Fine. Yeah, I think I agree with, I had the same comment. Unless we have the hardware, I don't think there's make much sense to actually go ahead and add any kind of support for this one without any user.
Give user space the most honest picture we can of how the hardware works, because once you start lying to user space, like, you must maintain that lie forever. And we've designed an API that makes it extremely easy to say, give me the lowest common denominator, right? You just don't fill in the CPU set parameter and you get the lowest common denominator. And so most applications that do need to have the same set of features across all CPUs just use that, right? And if you're somebody, you know, the example I can think of is someone like Chrome, who would look for CPUs that have like media decoding extensions on them and then pin themselves to those, can actually get that information from Hardware Probe, and then others that don't care or that want to do something super generic and memcopy just ask for the all CPUs version. So I want to be honest with user space is my vote.
An argument against doing nothing is, I think, yes, I agree with Arndt, right? These products aren't necessarily designed, but these mess ups happen, right? And a war story that we had, I think, I can't remember exactly which SoC it was, but there was an SoC where some of the CPUs on ARM64 had the atomic instructions and some didn't, and we didn't have any of this stuff, right? It was what prompted us to do the lowest common denominator. Right. So the kernel, okay, well, this is good enough for there's enough here to make the point, right? Which is that we would advertise to user space that you have these things because we would have probed them on the boot CPU. And I think it was Go or something. There was some big piece of software which then went ahead and tried to use these, and you get a SIGIL if you migrated. So their solution to this was they never used the atomic instructions, period. Right? So we still live with that now, even though we have all of this, because we didn't have it at the time. So if you do nothing, you run the risk of the first time you run into an issue with this, you might end up having some feature that can never be used.
Gotcha.
We've actually had 2 or 3 cases of that sort, because we also had a similar thing with iCache line size, with a runtime going wrong as well. So if you don't put in place some level of, like, even just warning something is wrong, people will ship entirely broken things and cause the shipper problem Will's describing.
Safe degradation on cache line sizes. You can't pretend to be the big one or the small one. So that's even worse. But none of this is controversial, right? This is just already known common features. Like, I don't quite understand why we're debating this. Just build it.
But build the support. Yeah.
Sorry, you mean build the support to minimize, to give the lowest common denominator, right?
Or to expose everything to user space. And
to be able to
cross
expose.
fingers.
I mean, like, I don't understand why this is controversial, I guess. Yeah. Are we just trying to make it more awkward for ourselves here?
I think really the question is, like, how much time do we put in to making sure that the heterogeneous systems do something interesting? Right, so we have the user interface where you can already say, just give me the lowest common denominator, or give me a specific CPU or whatever. That's all in there. I don't think anyone's saying we should remove that. But there are situations where, like the hot plug thing, right? Like we don't know exactly the characteristics of the core, so we run some code to detect what the core is like after it boots. So you could hot plug in a core that's totally different than anything else. And right now, we basically just don't boot that core. The question is, should we put work into doing that? And my argument is basically no. That's a pretty big corner case. And right now, we just give you a little warning. There's some cases where we probably crash or take a bug or whatever, because I'm sure people can do crazy weird stuff. But the cases we've kind of thought through, we just give you a little warning, don't boot the core. Like if you built one of those, you can just send some patches and figure it out. Because if you try to handle the arbitrary cases, you just go crazy. So it's kind of, so I think what you're saying is basically just keep doing what we're doing, right? Yeah, right. Like we've got the user interface where people can ask for something and they get what they asked for. So that solves the problem of like, did you ask for the least common denominator or specific thing or whatever, right? They'll get what they asked for. And then all the complicated cases just don't worry about until someone actually tries to do something, which is, that's kind of where I would be, right? Like that's why you built the user interface, to handle the possibility of weird things happening later, and at least you got what you asked for. Yeah, right. And then, but this is true not just for heterogeneous cores, like across the board, especially in RISC-V land, people can just build any crazy thing that just might not work. We can't just kind of try to support all that stuff. If someone builds some crazy thing, we'll figure it out. Yeah, anyone else have yeah. Yeah, I think so.
Yeah, I guess the concern is where instruction set extensions require kernel support to be usable. Like, for example, the one that I was involved recently with is we had per heart support for ZICBOZ, cache block zeroing instruction, which was exposed to user space, but it requires a bit set in a supervisor accessible CSR to enable that ISA extension. So like if the bit does, like we remove support for per heart support of that extension because we would have to have per heart logic in the kernel to support that. Or like the example of hearts that have vector on some cores and not vector on other cores. Well, vector requires kernel mode support for context switching. And so like we decided that we weren't going to support vector on, unless it's heterogeneous. So, or sorry, unless it's homogeneous, unless you have vector on all cores. So the question is, okay, I guess in that case we have to hide those from user space. We can't just report that information to user space because they can't actually use those extensions without kernel support. And I guess are we saying it's okay that if an extension requires kernel support to use, it's only available if it's available on all cores, because we're not going to add heterogeneous kernel support for those extensions.
Yeah, I think unless somebody goes and builds a system that has the more complicated thing, right? If somebody builds there is a heterogeneous vector system, but it's one of those t-head things nobody cares about, right? So like unless somebody builds one of those that they actually care about running stuff on, right, then yeah, it'll just be off. That's what we do now, right? If we get a heterogeneous ISO where we don't understand what to do with it in the kernel, we just turn it off everywhere. Or if we get it really late and we thought we had it on because it was a homogeneous system, then we don't boot the core. We just do something correct and easy in the case that somebody builds something wacky that we don't know exists right now, and then deal with it later.
So I guess, are we saying the policy is if someone builds something wacky, we'll decide then, or are we deciding now that we're not going to like what we're going to support?
I mean, like if people build hardware, we have to deal with the hardware, right? Like there's kind of no way around that, right?
But I guess what you just said, like people have already built systems that have heterogeneous vectors. So like we've already decided that we don't want to support those, or are we saying since nobody has submitted the patches, nobody cares, and if someone does submit the patches, we'll decide then?
Yeah. If somebody wants to do the work to support it, I don't know. We'd have to see how ugly it is. I don't know. Maybe it's not so hard, right? That running them across, like enabling that inside kernel, like turning on auto vectorized kernel stuff and running it there, wouldn't work because the alternatives won't work. So I don't know how you flip it on over there, but telling user space about it and doing some save restore code doesn't seem super hard. If somebody cared enough to go send a patch that worked and it wasn't like super weird, I don't see any reason to say no. I don't personally care enough about those chips to go write a bunch of code to make them do something at all, much less even any of their problems, right?
I think there's a case to say no for scientific projects or whatever, a student project, if it's something that's built and purchasable that people have out there. So we got to support it. That's a big difference.
Yeah. And this is where it's like what is like real hardware thing, right? But then we get into the kind of pretty normal kernel thing where it's like, some actual thing you're shipping that's out of your lab, like somebody who would actually run an upstream kernel has access to it, right? And that's a super gray area, and we have gotten to a couple of arguments about it, but I think that's nothing RISC-V specific. That's just a hard thing to define. Does that make sense? Yeah, it's the same. And we have a bunch of hardware that's not compliant, and like, is that available? Was it like one run of a test chip that you just dumped a bunch out? Yeah, who knows, right? So, but I don't know any way to fix that one. That's just hardware. So, and if our denominator for support or not support is there's hardware, we're always going to have some argument about what counts. If that makes sense, right? To me, it's really not hardware. It's like users, right? So, anyway.
Evan had a question.
Yeah.
Oh, did you? I thought Aaron had a question. Yeah. Are we out of time? Oh, okay.
Oh, sorry. Well, just quick while I walk away.
Yeah, I think it's good to be strict about that stuff initially too. If you're, you don't want to, you've got Charlie's thing that optimizes checksum offloading for misaligned accesses, and then a CPU is hot plug that doesn't support that. Like refusing to boot that core or refusing to run the system at all is a good way to go, because you can then back that stuff out later, rather than if you let it boot but it behaves brokenly, it's really hard to change later. You kind of want to refuse, you want to say like, we don't want to do it at all, right? And then if somebody comes back and it's like, wait, I really need it, then you know that like, well, no system has ever booted that did this, so now I can add the support for it, rather than like, well, we had it, but it was broken, and now I have to take it from broken to correct with like user visible side effects.
Will doesn't bring it up.
I'm done.
Thanks.
Can you hear me now? Okay. So we anticipated that the first two take less than what was originally allocated on the schedule. So we switched Deepak's topic earlier because he said that it would probably take more than half an hour. So I'll just switch to his slides. And Deepak, I made you presenter. So you should be able to drive the slides.
Thank you, Atish. Thank you, everyone, and thanks for attending. Yeah, I mean, more than that, I was like, everybody might be in a hurry to go and drink beer at the end of it, and they may not pay attention to it. So I was like, let's go early, and let's start. So at the end of the presentation, there are two basically big opens or kind of issues that I ran into that we'll talk about, and the proposed solutions, and we can basically table the discussion there. But before that, for general understanding of the entire crowd, I would just do a small recap of what are these extensions. So let's start with the landing pad extension. This is so the landing pad and shadow stack, they both are ratified now. And what landing pad extension does is it enforces all the indirect branches. They must land on a landing pad instruction, which is LPAD, and it is coming from a hint knob space, AUIBC, where RD is X0. Extension is pretty much following the software convention, which means that if you are doing a return, RS1, that is RS1 is X1 or X5, then this enforcement is not enforced. X7 is the new one in this list, which allows software to perform software guarded jumps. Things like if you have a very big switch statement and you are jumping within the function. So it basically allows you to statically determine that these are the safer places you can go to from those indirect branches. And both of these ISAs, landing pad and shadow stack, introduces new exception, software check exception. And there is a new TVAL is the TVAL is equal to 2 when software check exception happens. Basically means that landing pad violation happened. Another feature of this ISA extension is that you can tie your call sites with your targets, meaning you can assign labels to your call sites, and that assigned label should match at the target. And what this does is that you can make sure that you can implement a finer grained control flow integrity so that any call site cannot go to any arbitrary targets. So if you have, 100,000 functions in your address space, then if there was no label, then you can go to all those 100,000 locations from any call site, indirect call sites. But using this label mechanism, you can do something like calculate label based on the function signature type, a hash of a function signature type. So you're basically limited to certain function prototypes using this label mechanism. This is the recap of shadow stack extension, which is primarily to protect the return control flow, because on returns you're taking the returns are basically also indirect control transfers where you are taking address from the data stack. So this extension adds new instruction to the ISA, which is SS push and SS pop check. SS push takes two arguments, either x1 or x5, and when you compile your code, x1 can be you can push the return address on the shadow stack. Similarly, when you are returning from the function, SS pop check will check for top of the shadow stack with the contents of your return address register, and if they don't match, it can raise a software check exception, and then you can basically return. Shadow stack is a read-only memory, but allowed to be writable by shadow stack instructions. One thing that I forgot to mention here is that shadow stack instructions are carved out of ZMOP, which is short for maybe operations. It has been ZMOP, I think, also has been, yeah, it has been ratified. ZMOP operations are on existing hardware today. They are illegal instructions, but future hardware can implement ZMOP, and what it basically means that move 0 to RD, and that's why they are called maybe operations. The whole idea is that because we needed certain instructions to change architectural state, ZMOP was created, and any implementation can choose not to implement shadow stack, but as long as they implement ZMOP, the binary which are compiled with shadow stack instructions should run on them. And yeah, there are compressed version and uncompressed version both. Okay, the more information can be found on the link that I have linked over here. And shadow stack extension is the first consumer of ZMOP and ZCMOP extension. Update since last year, I had given a talk on enabling of user mode control flow integrity. I'm basically giving a update since the last time. So I've linked the GitHub repos or patches over here on this slide. On the toolchain side, thanks to Keto and team, they have been helping us to deliver the toolchain bits. And same from Ming Li from MediaTek, who has been working on LLVM bits. On the upstream side, last year when I had presented, I had taken a different VMA flag, which was VM_write. Presence of only VM_write basically means shadow stack. But there has been pushback from the upstream community saying that let's just go with whatever other architectures are doing. And x86 and ARM64 picked up VM underscore shadow stack VMA flag, which is high arch flag and only basically possible on 64-bit. And whenever 32-bit needs something, we can think of at that point of time. So shadow stack is going to be only enabled on 64-bit. That's one update. We have converged on a single general PRCTL for enabling these two features. I have linked the QEMU patches for landing pad and shadow stack. They are relatively stable and can be upstream. There, another update is that being able to post RFC patches for kernel control for integrity as well. All right, so opens and discussions are these two. We can try to finish them in this session, or we can come back to them later at the 6 o'clock. So first is VDSO. The baseline is that as we are earlier also we were talking about, right, like that user mode should have some homogeneous view of homogeneity in terms of ISA. Same goes for shared libraries as well. That if you are running your user space and you have features enabled which are part of your library, then that means that all the libraries should have that feature enabled. Otherwise, you can run into issues. That's where the landing pad comes into the picture. That you can't have a library which does not have landing pad compiled in. So if you mix those two different libraries, then you can run into faults. VDSO management is basically that when you are booting your kernel, you don't know whether the hardware has implemented XMOPs. So you have to carry two different versions of VDSOs with shadow stack or first consumer of XMOP. And when kernel has decided that XMOP is implemented on this CPU, then it can expose that particular version of VDSO. And of course, like if I'm assuming something here, please feel free to speak up. So this is for VDSO management. The options that we had was like have a single VDSO, but patch it in the runtime. It's a bit too cumbersome and flaky, I think. The other option is to follow the RISC-V profiles and build VDSO based on that, but I don't see any profile awareness inside kernel as of today. So I'm not sure if it is gonna see we're gonna see anything useful here. And the last option that I just discussed is basically carry two VDSO, one with XMOP and one without. The size of VDSO is small, so I think it is doable. And we expect that some feature extensions might also start taking instructions out of the XMOP, and doing this way will actually allow that if anyone wants to enlighten VDSO with new extensions which are taking XMOP encodings, they can just add that particular flag for the VDSO compile. And another option, and the last is not an option. It's basically saying that once we enable shadow stack support for kernel CFI, then we can start carrying a single VDSO again. So there's the plan. But I'm opening up this one for discussion. If I'm missing something over here. Landing pad label scheme. This is something which is basically can become an issue if we have two different kind of label schemes. So let's first talk about what are the label schemes. One could be a zero label scheme in which your label is zero. Embedding of zero basically means that label check is not going to happen. It will be bypassed. This approach is simple and can be easily adopted. but as I mentioned earlier, that any call site can reach any target as long as there is a landing pad there. Multi-label scheme is the one that we talked about, in which you can create a 20-bit truncated hash of a function signature, and using that you can tie each call site to a specific target. Sure, there are certain difficulties, and I have linked to those particular difficulties and the discussion on the PSABI GitHub repo that Keita had started. So I think it can be solved. And like one testament is like fine IBT, which is pretty much similar on x86, is part of upstream. So at least for one monolithic piece of software, it is doable. But the real problem that I wanted to discuss was that the possibility of existence of more than one labeling scheme is kind of a problem. So if you have a object which is compiled with one label scheme and you have another object compiled with a different label scheme, then basically they can't indirectly call into each other, because that's going to lead to issues. So in practice, people will end up using only one label scheme. And another point that I wanted to bring up was, like, from all practical perspective, landing pad enabling is going to be done with in conjunction with shadow stack enabling. And shadow stack enabling means that these binaries can't run on old hardware. They have to run on the new hardware, which implements Zemo, which means that allows a clean break from old CPUs to new CPUs as well. So it kind of alleviates and gives some freedom to the landing pad enabling and following a single label scheme. I'll just stop here. You have 10 minutes. Sorry. Took but a bit of time.
Hello. Okay. So personally, I don't think using runtime patching is too cumbersome, because you can use a patchable function entry, and then the kernel can decide to patch whatever it wants for landing pad or shadow stakes, and even we can change it at runtime to to decide whether to use single label scheme or use multi-label scheme. We already have procfs. In the procfs API part, there is a knob to control whether vector is default enabled, and we can use that procfs to decide whether we should use a multi-label scheme or use single label scheme, such like that.
I think the problem for CFI is that the compiler inserts the CFI ops. So we'd need some sort of dynamic relocation to point to them in the VDSO to do any sort of runtime rewriting. At that point, it's easier to just compile a second VDSO. But if there's some trick, then yeah, we can rewrite them. That would be slightly prettier. Is there a trick?
Yeah, Kwamru mentioned that,
Sam usually has a trick.
Well, I mean, other than the compile it with shadow stack and then just walk through the binary and patch out any ZIMOP encodings.
Yeah, but at that point, then, yeah.
I guess what's the impact of not compiling the VDSO with shadow stacks if shadow stacks are used in the rest of the function or the rest of the binary? Is that not?
I believe if you turn on enforcement, stuff will barf at that point. You don't have landing pads, so it's not a target site, right?
Well, like Andy was saying, patchable function entry is sufficient for landing pads because that puts it at the beginning of the function, right? So
yeah, so if we're only putting in landing pads via patchable function entry, then yeah, that seems viable. If that makes sense. Like, I don't have a strong opinion on exactly how the VDSO stuff gets through. I think we should just do whatever's easy. The easiest thing I could come up with was compiling it twice. So, like I say, if there's a trick, then we should just use the trick.
You can compile with shadow stack. Sorry. You can compile with shadow stack disabled in VDSO and then write instructions in patchable entries.
Yeah, so patchable entry, VDSO with no shadow stack, and then just insert our own, right?
Yeah.
That seems like it would work. I can't think of a reason it wouldn't work, so. Right? Unless landing pad allocation gets weird at that point. I don't know. I think someone just needs to go do it, if that makes sense, and then see if it falls apart and dies. Watch out.
Can you guys hear me?
So like this only matters if we want to have like one kernel that can both run on hardware that supports CFI and also the same kernel run on hardware that doesn't support CFI, right?
Seems like a reasonable thing to do.
But like,
Yeah.
does that matter?
Yes.
Yeah, I mean, if...
Can you guys hear me?
Yeah, we can hear you, Deepak. What's up?
Yeah, I mean, to answer Charlie's question, yes, we basically it's not even about shadow stack, it's about ZIMOP, because ZIMOP is, you want this to run on a system on which ZIMOP is not implemented, and kernel doesn't know upfront.
But we have been always maintaining
Like recompiling the kernel is too high of a barrier for this.
I think distros just, this is named for big distro stuff in the future. I think distros just don't want to show another set of kernels for this. I don't know.
Not too high barrier if kernel is itself compiled by shadow stack support, or any instruction.
Tish, you sound terrible. That's a...
Yeah. Can you hear me?
Yeah. Yeah, it's better.
I was just responding to Charlie, we've been always maintaining one kernel for all, right? Like all platforms, at least until now.
Except Renaissance.
Non-portable. Yeah.
Right, we just found that one out. Someone else, we just found out doesn't work, right? Anyway, yeah, we try to do one, but we should stop saying that because it's not true anymore. I guess maybe it hasn't been true for a couple of years.
I mean, those are buggy and stupid hardware, but at least for proper hardware with all the standard extensions, we should at least try to run one on all. So definitely don't want to do separate kernels for hardware with CFI and hardware without CFI. And then that will basically blow, as Deepak said, it's all about GMOPs. So we'll keep increasing the variance.
Yeah.
I don't think he's here.
Did you
but
try
I don't know if he's here, but what did Mark do on ARM for the same problem?
We don't have the same problem on ARM. So the BTI, our landing pad instruction, from ARM v8.0, we had a space of hint instructions. It's allocated from that, so those always exist. That is coarse grained, so you only have BTI C, J, and JC. So it's call, jump, or both. We don't have the fine grain problem there, and otherwise it's just hint space instructions. So that's the BTI side, and for shadow call stack, that's...
So those are no ops in all other.
Yep.
Yeah, and that's really the problem here is the maybe ops. That was just a bad idea. The whole point is they should be no ops, they might not be no ops. So it's not backwards compatible. I don't know why we did that. It's so frustrating.
Yeah, I mean, the reason was that these are hints and they should not change architectural state. I think it was basically to maintain purity of the ISA, which again I think is
architectural state. That's
is going to create a lot of
hence the bugs filed against the ISA manual, saying that they do. So anyway, this is a pointless discussion here because none of us can change any of this. So anyway.
Yeah.
But yeah, it sounds like you guys don't have this problem that we invented for ourselves.
Yeah, sorry. And one other thing is that the BTI, you can change whether it's enforced on a per page basis. So I think we just don't enable it in the video. So I'd need to double check what we do that.
Yeah, that makes sense. Yeah. Cool. If there are other questions. Okay, thanks, Deepak. I don't know who's next.
Thank you, everyone.
No, that's why this is so tricky.
I changed the presentation.
Did you bring a laptop? It doesn't work. Yeah.
Oh. How much?
32 slides. We're supposed to heckle you if you have more than 2, so good luck. Yeah, I don't know. I can't. My laptop also doesn't. Did you bring on?
Hey, can you try the clicker now?
That's what I said. Yeah.
You want me to change the slides or you want to try the clicker?
Yeah, the problem is he has 32 slides, so Tisha's gonna have to click through that.
Yeah, so I think clicker should work. I changed the presentation.
I don't think anybody in the conference had a working clicker who does all these things.
The slides work, right?
Yes.
Yeah.
So, hi everyone. I and Andy are working on making ftrace more optimal on RISC-V. So, I want to know first how many people in this room know how ftrace works. Because if they know how ftrace works internally, we can just skip the slides and directly go to the discussion. Otherwise, I have around 30 slides explaining through an animation how ftrace works. I'll just show them. So basically, I'll explain you the ftrace mechanism in some basic slides. So let's say we have this function in the kernel called VFS open, and we want to attach this tracer to it. So we want to call this tracer for every call to VFS open. So we ask the compiler to insert 2 knobs in the entry of this function, and we do that through this feature called patchable function entry, and GCC and LLVM support this. And then the kernel has this trampoline where this trampoline saves the registers on the stack and then calls a stub function, and at build time this stub function just returns and restores the registers and returns back. So this trampoline exists, and then we patch the entry of the function to be traced with a jump to this trampoline. And on RISC-V we need to patch 2 instructions to make that happen. And once that is done, all calls to VFS open will first go to this trampoline and do nothing and return back. So right now it's just adding overhead. But now what we can do is we have our tracer and we can patch this trampoline to call our tracer. And this is basically tracing enabled on VFS open. All calls to VFS open first go to this trampoline, and it saves some registers on stack, calls your tracer. Your tracer can also modify the registers because it gets a pointer to ftrace regs or like PT regs. And then you return back and the trampoline will restore the registers, return back to the entry of the VFS open, and it runs. So this is how basically ftrace works. And when you disable tracing, it just patches the entry again back to knobs and also removes the patch from the trampoline. So it again gets the call to the ftrace stub. So now there's another thing, that what happens when you want to call 2 functions from the traced function. So let's say we have these 2 functions, myTracer1, myTracer2, and now you want to call both of them from the entry of VFS open. directly patching ftrace call would not work because through that you can only call one function. So what you do is you instead call this other function called ftrace op lists func, and this will then iterate over all the registered tracers, and it knows which tracers are for VFS open and it will call them, and then similarly you return back to the trampoline and then back to your VFS open. There's another mode in which ftrace works. It's called direct call. So if your tracer can receive direct calls, you can directly patch the entry to call your tracer and just skip the trampoline because it adds overhead. And this is how BPF attaches BPF programs to functions that you trace. It generates its own trampoline and directly registers that. So there is a problem with this approach currently on RISC-V that we have to patch two instructions in the entry of the traced function. And currently how we are doing is first we disable preemption and we use stop machine to stop all cores, and then one core does the patching, and I think it sends an IPI to other cores, and then that's how it is working right now. But it's the overhead of a stop machine and then also not having preemption is basically making ftrace useless in production. And looking at it from an implementation level, the main problem that remains is that we have this AUIPC plus jump and link register in the function entry and then also the ftrace caller trampoline. So we have to patch these two places atomically somehow to make ftrace work with preemption and without using stop machine. So the solution that we are trying to propose here is that for a second, if we say that we don't want to do this direct call thing where you directly call a trampoline and you always call this ftrace trampoline for when you enable patching, and when you disable patching, when you disable tracing, it's just a knob. So basically what you're doing is you have two knobs, then you're changing that to a call to ftrace caller. When you disable tracing, it's again a knob. So basically the address of ftrace caller is known at compile time. That means we can just patch one knob to a jump and link register to enable tracing and then again patch it back to the knob to disable it. So, but we are assuming that we don't support direct calls for now. And this is how it would work then. At boot time, we would change the knobs. The first knob will change to half of the mechanism that we need. So basically AUIPC T0 ftrace caller will patch that to all the patchable functions, and the second instruction we leave to a knob. And whenever you want to enable tracing, you just patch a single knob. You patch a single knob to a jump and link register and the tracing works. And for the ftrace caller trampoline, there also we had to patch two instructions. So for that, what we are doing is rather than doing a direct call, we place the target in a variable and then we load the value of that variable and jump to that. And then changing the value of this variable in memory can be done atomically if it's aligned. So that way both of these places can be atomically patched to enable tracing. So, but this solution adds two problems. One of the problem exists already now and one of them would be added by us, because now we either not call any function from the function entry or call ftrace caller trampoline. We are stopping the support of direct calls from the function entry. So all direct calls would also have to go through the ftrace caller trampoline, which would add a little bit of overhead, but we can discuss at the end the pros and cons of this approach. And another problem that also existed on ARM64, which they fixed using call ops, and what we are proposing here as well for RISC-V is that this ftrace caller trampoline is common for all the traced functions. So if you have multiple functions being traced and multiple tracy functions, the overhead is added to all the functions, all the traced functions in the kernel. So I can show that using an example. Let's say we have this similar example where VFS open is being traced by 2 tracy or tracer functions, and VFS open is the tracy. Let's say we want to also trace wake up process now. So, and we want to trace it using this wake up tracer. Currently the approach would be to also patch the knobs inside wake up process to go to ftrace caller, and then ftrace caller would take you to ftrace ops list function, and then it would iterate through all of the tracers and call the correct tracer for wake up process. But that's this overhead of all these tracers is being added to wake up process, whereas it only has one tracer attached. So, and let's say currently this example has 2 tracers, but let's say you have 100 tracers tracing VFS open, and now you want to trace wake up process with a single wake up tracer. The overhead of all these 100 tracers would be given to wake up process without any reason. So how we fix it on x86 is that if you know that there's only one tracer attached to a function, you allocate a dynamic trampoline just for that traced function and call that. And how ARM64 does it is that they use something called call ops, which we are also suggesting to be used in RISC-V, and I'll explain that in the next slide how it works. So, and yeah, the other way could be that we patch the entry of wake up process to directly call the tracer, but that we can't do because the tracer is not capable of accepting direct calls. So the call ops mechanism is what we are suggesting RISC-V to use. And what we do here is that every traceable function, we allocate 8 bytes before the entry of the function using the same patchable function entry mechanism. And then we place the ftrace ops pointer at that location. And therefore every patchable function or every traceable function has its own custom ftrace ops placed there. And then the trampoline can just fetch that and call the function. So that's how this would look like. So currently we patch ftrace caller trampoline to call to my tracer. Now what would happen is that you would place a pointer above the entry of VFS open, and ftrace caller stays static. It just always from a fixed offset from the entry of the function fetches the pointer and then calls the ops function. And this way, because every function has its own ops pointer, you don't have to iterate through a list of tracers to see which one to call. And this is enabled on ARM64 currently. So basically to achieve this on RISC-V, we had to do 3 things. First of all, we had to move from this regs to args mechanism, where why we need this is because earlier there were 2 trampolines, one called ftrace regs and one called ftrace caller. And that was because you had 2 modes, where one where you want to save the registers and one where you don't want to save all the registers. So you had 2 separate trampolines for that. Now we have a common trampoline that saves just the arguments, just the registers that are used for arguments when you call a function in RISC-V. And the other 2 patches basically do the mechanism which we discussed, where we just patch one knob to a jump, and then the third patch set implements call ops like ARM64. So, and I think now we can discuss about the pros and cons of this approach and what we should do. And also, Andy would like to talk about something called CIF, which I don't know about. So.
Sure.
So DICCIF is an RVI-defined ISA, it says very basic things like instruction fetch of naturally aligned power of 2 size up to this size are atomic. It says basically when you execute instruction on a naturally aligned instruction location, it has to be atomic. So for example, if you are executing a 4-byte instruction on a 4-byte aligned addresses, then the fetch should be atomic. Or if you are executing on not 4-byte aligned, but a 4-byte instruction, it would tier the instruction internally, or the atomicity is not guaranteed. So this is ZICCIF, and we must require that to be true because if a naturally aligned instruction fetch is not atomic, then things will break because we patch a knob to another 4-byte instruction, and if the instruction being fetched is not atomically fetched, then bad things would happen. And so we have, because this is very basic things, so the question is, should we just assume the ZICCIF exists on the system and treat it as a hardware bug if the hardware doesn't support it? And there are examples of a machine that doesn't support ZI or doesn't implement the ZICCIF, which is QEMU, interestingly, because QEMU fetch the first 2 bytes of instruction, decide whether it is a 2-byte instruction or 4-byte instruction. And if it is a 4-byte instruction, then it loads upper 2 bytes of instruction. So things would break on QEMU if we do dynamic patching on it. And yeah, that's it. Oh, sorry, and I want to add that, we already assumed the ZICCIF on static branch. So, yeah, it's either a software bug or treated as a hardware bug.
Do you want to fix QEMU? Can we fix QEMU?
Sure. Yes.
You sent the patch.
I think we made QEMU work that way because the ISA manual says that they get fetched that way. So there's some sort of exception thing where if you're like crossing a page or whatever. Remember that?
You send a patch to, was it you? Someone sent a patch to QEMU to implement
Okay, yeah.
Yeah, totally.
Okay, all right, whatever. That sounds manageable then. So just fix it.
Yeah, it makes sense to me as well. So.
Okay.
Yeah, it seems like the static branches should probably be disabled if ZICCIF isn't there. Instead of this, yeah, we could assume it, but we already have all of the other instruction probing and stuff. So it seems like we should probably just add it for this also.
Like the ICSR stuff.
Yeah.
And there's another thing that we are assuming that we don't have a CMODEX in the ISA. It doesn't explain if we can really patch these instructions or not. And we are just doing it and assuming it that they'll work.
So 2 things. One, have we seen any situations where static branches have caused random failures at runtime? Because that's what you would expect if there was any actual real-world hardware that didn't support ZICCIF, which I haven't seen any reports of that being happening. The problem with trying to detect ZICCIF or only enable static branches if it's there is that there's no device tree binding for anything for it at the moment. So any existing device tree is not going to report ZICCIF. So you're either going to have to somehow try to detect it at runtime, or break compatibility with all existing device trees, which is neither are great.
Yeah, I think we talked about this like 2 or 3 years ago and basically decided that we just assume it exists. Because we've been depending on it for so long. Like Sam said, nothing appears broken. So if it becomes a problem, we'll figure out what to do with it.
I have a horrible feeling I'm about to say something stupid. I'm going to kind of say anyway. In the examples you're giving with the NOP patching for ftrace, if you added a third NOP, well, I guess it would be your the thing that takes the address of ftrace caller and then 2 NOPs. Could you still do the direct calls? And in the rare case that you get preempted, you'd take the ftrace caller route and go down the slow path.
So you want to add another NOP?
Yeah, more NOPs. That's what we need. Yeah. So if you add another NOP under the NOP that you have,
yeah,
could you then patch the another AU IPC in the first NOP, and then your jump, in the second NOP?
Yeah.
And like if you get preempted, which is probably unlikely, you'll take the slow path and go into ftrace caller, and it'll have to go in dispatch. But you might still be able to do direct calls in the common case there.
No.
You can't. Why doesn't it work?
Because you've only got half. The AUIPC needs to match the next 12 bits in the jump.
Okay.
Yeah. So for you, AUIPC is like ADRP on ARM64, and the JLR has the low 12 bits. So if you get preempted in the middle, you've got half of it, and however many NOPs you get, you have some boundary at which you've got half of what you need. Which is why we did this on ARM64 in a similar way.
There might be another solution by triggering the re-execution of AUIPC. Then that is possible. But by doing that, we have to decode instruction at exception return, and then, yeah.
The way x86 does some of this patching is that you just replace all of the bytes you're patching with we would have eBreak, they have int3, and then flush your iCache everywhere, make sure everything's good, and then replace it with your the real instruction sequence.
That code looks really.
Yeah,
I read that code.
So that does work. Like we could have done a similar thing on ARM64. One of the reasons we didn't do that is you have to synchronize a lot more with the other CPUs to do that, rather than with this approach where you patch one pointer atomically. So if you've already got a patch site enabled, you just change the pointer, you're done. You synchronize that. And it is vastly lower overhead to do that than to have to synchronize 2 or 3 times that x86 have to do with all the CPUs.
One problem we have with x86 approach is that x86 supports multi-bytes instructions, so they patch eventually a call instruction onto it, but we have to patch 2 instructions. So you cannot guarantee they are being interrupted in the middle of instruction.
Something that we discovered in QEMU is that recent Clang is storing magic data at address of function -8. This will probably conflict with that.
Yeah, so that's Clang's KCFI.
Yeah.
Yeah, which is optional. We have the problem at the moment on ARM64 that we can't enable the 2 simultaneously. We need to work together with to define the offset for consistency.
I assume theoretically that's fixable on the toolchain side, since fpatchable function entry tells the toolchain how many bytes you need for yourself.
Yeah, so if you enable both of them together, they will work. The problem is if you have a mixture of instrumentable code and non-instrumentable code, the CFI offsets end up being different and they're not cross-compatible. So what we need is to define a consistent address for the CFI offset regardless of whether it's compiled with patchable function entry or not.
So yeah, I think we can merge the patches. Yeah, thank you.
I had no idea what was going on.
Oh yeah, we're on a break.
Are we?
Yeah. Great.
Then we have half an hour.
7 extra minutes.
Andy, what's up?
Nice work.
एक तो हो गया.
Nice work for your part two. Just a quick announcement for anybody who is it live? Is it going through? Yeah. For anybody who wants who's interested in a job working on RISC-V Linux and other interesting stuff like that, please come talk to me. Louder? Okay, great. Hey, just a very brief announcement and plug for Sci-5 if folks are interested in working on RISC-V Linux, come talk to me.
I am
That's it. No.
Oh, are you still hacking on Pico Lucy? Oh,
There are some architectures that just stop it. Like no one uses, but Rick Slice no one uses.
Really? Yes. Well, that's a huge step.
Yeah, it's pretty weird because our JAI comes with a 5-bit registering from the start. And that doesn't make sense because normally you know you are thinking with some 1 or 2 bit register. Like,
But for us, near means I think some no one is directly calling to a 4. If it's near, if it's less than 56 MB, then they do a call. If it's far, then
That's not very far.
I say this is because the address of address caller is statically defined like compiler. Direct call means some dynamic function that that was something that I wanted to do as well. But let's say you attach that direct call and it's running like BPF. I've attached a BPF program and it's running 100,000 cycles per second, every time you are doing a load from one which is like extremely slow.
But isn't when it still be faster than doing it like you both you're trying to you're still there's a bunch of family there. You're trying to your cache load.
Is there a JALR that is relative to the current DC?
I think we could do something where we support both modes.
Or maybe do a performance analysis and see if there's even a point if there's even a point for not doing it.
Yeah, so you need to first do a tape out.
Performance analysis, but we can do it another It was a very nice presentation. It was very nice to repeat, to react. It was very nice
Wow, that's, I really enjoyed learning that.
atomic patching. Do you have anything else to do? Do you have any comments? Or you can just leave it out?
Social event like a very neoclassical.
Oh yeah, well it's just figured out that I don't know if we're desperate. I mean I'm always kind of looking for the right result. Thanks for your help on the whole IOMU patch series thing. I'm really we can hopefully, accelerate things on your side too. At least on the non-GPU side, we're heading in the same place, right?
Yeah, basically what R64 does, except in an edge case where they can jump directly and take it, but otherwise it's the same.
Steven was say anything about this?
I chatted with him, he was even giving me more happy solutions. Just for but he was fine with it because
Okay, so according to him, it's not really a problem to
I think the most, I will have to do a comparison, but most highly used case of like direct core GPU, so I can to see how much performance over MPP gets. I know it will become faster because I know too much thought machine.
Yeah, it will be faster.
Thought machine is like
regarding the performance, if you have system in the right system of the direction of the architecture, okay, so that's what you no, maybe not. We'll see. But we have to.
But the thing is that too much custom and mode first. If I have to, if I have to do something like that, I would wait for the specification to first have C mode X and everything rectified. Because so because without that, like we assume that most architectures will support it, or most associates will support it. What if someone wants something where this is not possible? You need to wait for someone.
I guess we can wait and see if someone complains.
आपको रजिस्टर सेव कराने स्टैक पे दो इंस्ट्रक्शन लगे ना इस काम के, दो इंस्ट्रक्शन पैच करने के लिए वो दो इंस्ट्रक्शन ही तो पैच नहीं कर सकते सारा गेम एक करेगा लोड एक करेगा जंप दो हुए ना
Well, actually, उसके बाद वो वापस आया वो डायरेक्ट जंप चला देगा उसने तो लोड ही नहीं किया एड्रेस वो रेंडर देगा या तो मुझे आरसीयू टाइप करना चाहिए भाई वो तो बहुत ज़्यादा ओवरहेड होगा हर प्रोसेस वो तो सकता है अब मैं कैसे पता करूँ कि उस कोई भी फंक्शन शेड्यूल आउट नहीं हो सकता अब हर बार लोड करेगा वो तो हमारा केस ऑप्टिमाइज था उसको हमने छोड़ दिया और वो कॉमन केस है अब डायरेक्ट कॉल नहीं करें ना अब इनडायरेक्ट कॉल हो गई है ट्रेस कॉल आपको बेसिकली क्योंकि हम लोड कर रहे हैं फिर ब्रांच कर रहे हैं तो वो नहीं करवा सकते ना तो सीधा जंप कराने के लिए दो इंस्ट्रक्शन AUP LPC और जंप ये सारा
What's that? What speed does that get you? 10 gigabits. Yeah. We want that file real fast.
This stuff downloads fast.
I know I'm thinking of for loops called functions.
Oh.
I got handy loops.
Oh.
So Max is fixed.
Yeah? Whoa, he's at the center of the internet. That's amazing. So you can stream his music from the other computer really quickly.
But like, so even I understand less now why how you would.
Well, you would stream it that?
Turn that into something other than the file system.
All of the pirated movies.
So my internet connection is 1.3
Gigabits?
Wow. Right.
Yeah.
So I kind of 1.02 and a half. Because Palmer had a switch sitting around in 10.
Nice.
That's pretty cool.
That's good. Oh, I'll take that off your hands. That's fine. It was not expensive. Switch was under $300, and then like I put a nick in my desktop.
Oh wow. That's awesome.
Yeah. It was not expensive. The most annoying thing was pulling that.
Do you have a header data conduit or something?
I had conduit. Because I already had an Ethernet cable going. Pull the.
Did you bring a bundle of string?
Yeah, a little twine thing.
I've got a fish tape. We also. It's like there's basically no terms, but it's just there's an external access port on each building. But we did it. We did the smart thing and we built it. So yeah. Instructions essentially go into software.
Yeah, that's something that you kind of need to find out.
Yeah. Something, some equivalent, hopefully equivalent operation on the host. I assume that's to just keep floating points.
A lot of various elements outside my house that I know are there and know roughly where they are, but I don't know exactly where they are. So I'm terrified to like do any digging. There's like electricity, water, geothermal, and like lines. Yeah, my heat and cooling is geothermal, so there are like geothermal lines, and I know roughly where those are because we had a guy come out and like spray paint them. I don't know. That I don't know. So I don't dig over in that area.
So the geothermal is just
Yeah. So it's like an AC unit, except the thing outside that tries to blow it in. Yeah, instead of the thing outside that tries to vent it into the air, it just vents it into this water pipe that then always comes back 55 degrees.
Yeah, I've seen people do that with inputs, greenhouses, or operation. Constant year round. Oh, interesting. I know people for like larger scale houses.
Yeah, it works pretty well.
Do you have any telescope?
No, yeah.
It's not always possible to do.
The thing that makes me nervous is punching holes in the roof. I don't. I know everyone's like it's fine. They just caulk it up and it's good. But like, I really don't want to punch holes in my roof.
It's like redoing it.
Then sure, yeah, you do that first, and then you put the new roof on.
Solar panel shingles.
Yeah, those look. I looked at when I built the house, and it wasn't quite yet. Like just before you could get them. Yeah. And they were very.
Plus the efficiency of solar panels keeps improving, right? So
If you put it offline, you
yeah, put it off.
When are we leaving?
Yeah, that's also.
When are we leaving?
The other thing, so my neighbors do have solar panels. What annoys me is like we have power outages for long stretches, like in the winter and potentially in the summer, and their solar panels are set up in such a way that like if the power goes out, they don't get any electricity from solar. Like, you need the mains coming in, and like, you know.
batteries, and those only last 5 years or however long they last. And then those batteries last that long. Really? But at best 10, right? Yeah, car batteries don't last that long. That's true. Yeah. Is that what wears out car batteries? Is discharge?
Yeah. Or it's like if they're really full or really empty.
Right, but you'll keep these really full all the time, right?
Yeah, but I guess I'm pretty smart managing them, right?
Yeah, but maybe you keep them at 80%
Yeah, if
all
you keep
the
it at
time.
80% all the time, it's true.
Yeah.
Would have bigger. I think the fluctuation when it goes up and then it just stays that high.
Yeah. So I couldn't convince myself it was a good idea, so I have a little wheelie generator that hooks up to my propane tank and then hooks up to my house. Yeah, like it would be no fun to lift up, but it has a little handle and wheels, sort of like a suitcase, and you can push it slowly. Yeah, exactly. And I have like a big propane tank, so you can hook up to that. It already has like a generator port on the outside of the house that then goes into the electrical panel. Yeah, and then I can control like which circuits. Maybe. No, there's a little panel where I can choose like which of the circuits goes to generator versus line. Yeah. The one thing that I realized during that crazy ice storm that's not on the panel that I can switch to the generators, any of the heat pumps. I guess they were deemed too power hungry to ever be powered by generator, but it means that the house got very cold. The lights were on and the fridge worked, but it got cold.
No. I don't know. This has never happened before. It's usually like it's just here, so I don't even really know what to do. And I can never figure out how to log into any of these systems that they have, so I don't even know how to ask somebody. You can just run around screaming, "Where's Steven?" But how it works.
Is it allowed to?
I don't know. Sure. Why not?
I don't see why not. They had some people coming in and like cleaning out stuff. Cool.
You wouldn't be the first one. Yeah. What's up? Okay, cool.
Plug-in research. Too many volts.
I just do whatever people.
That's small things to do. At least benign.
I just not put that much space in the box.
Yeah.
Things happens to that. Yeah. Mainline and next, and maybe some other branches.
Like I know there is testing of like there's some CI system that runs unmatched on at least some RISC-V.Git branches because I've seen like mails where like it was broken for a couple of months because
LCI runs some stuff. Sometimes it's usually broken.
Stuff is broken.
It's broken.
It's been broken for quite some time.
Yeah.
It's an illegal instruction.
What?
But it's unleashed.
Yeah.
What's in there? So there's an issue with the clock driver a couple of releases ago that broke. Oh, Unleashed you're talking about.
Yeah, yeah, I think you mean on the unleashed. It fails on the unleashed.
Maybe I'm not sure if it was Unleashed or Unmatched, but there was
Is Unmatched the new one? Okay.
Unleashed is the old one.
Yeah. Yeah. So Unmatched is what Debian builds on, right?
Unmatched is the one with PCI Express.
Yeah.
You can actually access.
Yeah, although going.
Well, there was a clock driver a couple of releases ago that I sent a patch for so it should, it should be working now. I don't remember. I haven't seen anything because I think it only sent an email if the build is broken. So assuming if it works, I don't hear it.
Yeah, because they're not doing interesting stuff.
Like, do
you know what that means? I haven't officially joined it.
I don't know. I don't have any suggestions. It's more like. First of all, it would be nice when more tests, testing on boards pretty much. We do a little, we do some testing on QU, but it's like, it's a QU. Let's do proper boards. I'm asking because it's mostly you guys that have actual boards. And then there's, the Milk 5 set one. Yeah.
I do.
I can live with it.
Yeah, I did see that.
Other internal boards.
Yeah.
I'm coming.
But yeah, it's not like Linux.
I do master on Vision 5.2 and stuff like that.
Yeah. And that's various different configurations. Most of the configuration is based on whatever feature I'm bringing.
Yeah, last time we talked about the vector stuff.
It would be out of place.
That's one regularly, but I haven't. Yeah. Other risk type
now
stuff.
You have to
the rest of my week.
Demo for
It's kind of fun. I spent the last week looking at self-tests and there's a lot of things that's broken. It's broken ARM, it's broken x86. Just getting a baseline would be.
Yeah, and then there's all the K-unit tests that.
Yeah. I haven't even run those.
I sent a patch a while ago because I was trying to kernel hardware ASAN, and I realized, there's a bunch of failing unit tests for regular kernel ASAN.
Yeah.
So I sent a patch for that, which hasn't been raised yet. But, it was the bitmap operations that we implemented using assembly routines didn't have this so they wouldn't have checked the actual No, just there's we implemented __ set bit. And I renamed __ arch set bit that have the implementation. No, it's not in master. It's not exactly. It's not anything that's broken. It's just a missed possible bug because it's not actually checking the point. It's not super high priority, but it's just one of those things. No one's running the test, so no one. Oh, okay.
Yeah. Okay, there's one guy. There's one guy right
He's not telling anybody.
So the every part,
A lot of them are just
hey guys, it's start talking time.
Hey, Atish.
Sunil's on the computers. Okay, let's go.
Hey, Pamal.
Sunil's remote, so. Okay, we're good.
Yeah. Hi, everyone. I'm Sunil from Vienna Microsystems. And today in this discussion, we're going to discuss about RIMT, which is a new ACPI table for RISC-V
to provide IOMMU information to the operating system. Some background about RIMT. So basically, as I said, this is a static ACPI table to communicate IOMMU information to the operating system. And I wish there was a standard way across new architectures to provide this information to the operating system, but unfortunately, every CPU vendor has their own such static table. For example, Intel has DMAR, AMD has IVRS, and ARM has IORT, and they are maintained outside the uh, uh, standard ACPI specification by those respective organizations. So similarly, for RISC-V, we have to RVI has to define this specification for RISC-V, which is called RIMT specification. The specification link I have provided, but here is a very high-level overview about this specification, and there are more details in that specification draft. But to get you the basics of RIMT, basically it's a static table, like I mentioned, and it has this standard ACPI header in the beginning, and then after that there is an array of devices, and currently the devices can be of three different types. One is IOMMU device itself, and the second one is the PCI root complex PCI devices, and third one is regular platform devices or namespace devices. So there can be any number of this type of devices in the system. So in this example I have shown here, there are two IOMMU devices, and two PCI root complex devices, and one platform device. And basically this table provides the information about IOMMU as well as the device behind that IOMMU, that topology also. So the way it is structured is in this example, you can see that there are two IOMMUs, 0 and 1. First one is implemented as a PCI IOMMU, PCI device, and second one is platform device. And PCI root complex 1 and platform device A are connected to the IOMMU 1, which is a platform device, whereas PCI root complex 0 is connected to the IOMMU 0, which is a PCI IOMMU. So, and each of these PCI or platform devices, those data structures will have additional ID mapping array. Basically, it provides the source device ID, PCI device ID in this case for PCI devices, and the target IOMMU has its own internal device ID. So this provides the mapping from source device ID to the IOMMU device ID, as well as which IOMMU is going to handle this. So this ID mapping table is critical, and using that, operating system will, while configuring the device, it scans this RIMT table and finds that for this particular device, if it exists in this RIMT table, it gets into the ID mapping data structure, and through the ID mapping data structure, it will get which IOMMU is need to be configured, and what is the target device ID. So that is the simplest, that is a high level crux of this table, but there are additional flags and other things to properly map, and some of those capabilities like PCI, ATS, and etc. are also there, very similar to other architectures. Any questions so far? And we are trying in this first version, very basic thing, whatever is minimally required. In future, based on the hardware capabilities and more features, we may need to have more revisions of this table, but that will be incremental. Okay, so now coming to the next changes, differences between other architectures and RISC-V. So in ARM, if you can see, they also have IORT, which is a static table, but it is parsed very early during boot, and they detect the similar SMMU nodes in the IORT and create the platform devices. and later SMMU driver will climb those devices and initialize them. However, in RISC-V, because the platform IOMMU device can have IOMMU can have its own interrupts, and they can be either MSI interrupts or wired interrupts. And if it has support for wired interrupts, then it has to be probed only after APLIC or PLIC is probed, because we need those interrupt controllers to be initialized before we go and register any of or map these IRQs. So because of that reason, RISC-V has platform IOMMU device in the namespace as well, but it is mostly having the base address and interrupt information, and rest of the topology information it has to get it from the RIMT table. So because of that, unlike ARM, we don't need to create the platform device on the fly during boot explicitly by parsing the RIMT table. And because namespace IOMMU device will be created automatically when regular ACPI scan happens on the DSDT, and it will have a firmware node also. However, we need to link this firmware node or namespace device with the RIMT IOMMU node structure so that devices are configured properly. As I said, RISC-V IOMMU can be implemented either as a PCI device or a platform device. And when it is a PCI device, IOMMU infrastructure works based on a firmware node. However, PCI device may not have a firmware node in ACPI. ACPI may have only the host bridge level firmware node. So because of that, for PCI IOMMU, we need to create this firmware node statically or explicitly. And only one restriction in this implementation is PCI IOMMU should be implemented in such a way that the PCI scan happens first before other devices behind that. So, like I said, because of these reasons, firmware node should be registered with the RIMT as part of the IOMMU driver probe itself. And that is one difference compared to other architectures. So because of this reason, the devices behind the IOMMU can be probed before actual IOMMU is probed, right? This problem, I think it exists even in ARM as well. And it basically is solved using deferred probing. I don't know whether there is any other solution in ARM to avoid deferred probing of the drivers behind the IOMMU, but in RISC-V, because of platform device in the namespace, we can actually use the underscore dep method or implicit dependencies what we came up for APLIC and PLIC devices. So we can potentially avoid this deferred probing problem. But is that a good idea, or is there any corner case? Or and the second question there I had was, unlike IRQ framework where some things are expected very early during boot by ACPI, this IOMMU probably can use the firmware devlink infrastructure also. So if we come up with something very common, I think problem can be solved for ARM as well as RISC-V to avoid this deferred probing issue. I mean, basically firmware devlink can create the dependencies and order the probing. So that is something we can brainstorm, but at least for now, this can be future enhancement, but for now, we probably can go ahead with something similar to ARM, where we expect drivers to support the deferred probing. I'll pause here if there are any questions or discussions on this.
concerned about there being existing drivers that don't support deferred programming and therefore would require a software change if we didn't use the underscore dep method?
Yeah, exactly.
I mean, is there any downside to using underscore dep? Because if not, that seems like the most compatible solution.
Yeah, we can do that. I don't see any downside for that. Only thing is, I don't know how it is solved in the ARM case. If ARM is supporting IMMU with deferred probing, I don't know whether this is such a critical thing in this case, where we expect all drivers to support. All drivers, all devices which are using IMMU for their DMA transaction to be supporting deferred probing. So
I think ARM does not.
Of course.
I think ARM does not
Sorry,
mandate
go ahead.
drivers support deferred probing. So the firmware node, like the old driver infrastructure, knows the links to the IMU either from device 3 or like just from ACPI, and this is it just handles. It tries to probe it, but it defers it from the driver core. It doesn't actually probe that driver. So driver shouldn't be aware of this kind
Yeah,
of.
it is supported in device tree.
Yeah.
Sorry.
I think this is
device tree supports this.
Yeah, please go.
No, this problem is not there in the device tree probing because device tree has this firmware dev link for IMMU map property, and using that it properly orders the probing. The problem is in the ACPI where we don't support this firmware dev link design or framework to order the probe. So only way is driver should support the deferred probing.
Okay, I have a fundamental question actually. Why is it that the devices behind the IOMMU have to be probed after the IOMMU itself? What's the reason for this?
They configure their DMA related stuff during the device configuration itself. So as part of the device driver initialization, they call this IOMMU configure, and that if the IOMMU is not ready, it will return deferred probing. So then the driver has to wait till IOMMU is ready.
So
that exists already in the code.
So maybe to make this more specific, are you talking about different probing from what PCI scanning is actually, where you essentially discover the hierarchy of the devices?
Yes. Yeah. PCI devices, when they are probed, if they need IMMU, then that particular device driver will have to be deferred. Yeah.
Okay. Thank you.
Yeah, here you got it.
Sunil, adding
Okay, sorry, so now we got another
DEP in every
audience.
Sorry. So there's already
Go ahead,
there's already a mechanism for ordering IOMMU driver probe against device probe. It's something that's used in ARM already. You need to hook in some stuff in your special ACPI and hook into the IOMMU driver's bus ops, and then it just sort of works automatically. You don't need to worry about eProbe defer or anything like that, if that's helpful.
Oh, okay.
Thank you.
Okay. Okay, that's great. Thank you. Adish, you had a question?
Yeah, I was asking, like you mentioned about either default probing or the adding the DEP for every device that depends on IMMU. So, but last time we were trying that for APLIC ACPI bindings. That time there was some feedback saying adding DEP on every device not feasible. Is that correct?
No, I mean, when I mentioned DEP, it is not DEP in the ASL, but basically operating system will itself detect and create something like
So
pseudo
you do it in
DEP.
implicit.
Yeah, implicit. Yeah.
Okay.
Okay, I think that was good input. So we don't probably need to worry about deferred probing. So other thing which I noticed is this ACPI IMMU configure ID, which is getting called for ACPI in the ACPI, directly calls this IRT IMMU configure ID from the common path. So because we have RISC-V specific IMMU configuration,
It doesn't
we
just
have to
call.
change this code.
It doesn't just call IORT. It also calls the VertIO stuff, and you can just add yours. Just add it to the list.
Yes.
You don't need like an Arch indirect or anything. That's the wrong. Actually, that's the wrong abstraction. Just add yours to the list. That's
okay.
all.
Okay.
Say that in the list.
So if there is no IRT, it will just return. Okay.
I'll probably forget, but sure.
Okay, cool. Well, I'll definitely forget. So hopefully Sunil remembers. All right, yeah.
Yeah, those were the things. I think this is very helpful. But if you have any other inputs on the specification, please provide us. It is currently under RVI's ratification process, internal review phase. There will be public review as well in future, but this is an early insight on that. Yeah.
Yeah, so I have a question going back to one of your first slides where it describes the topology. Is there a way to describe root complex integrated endpoints which wouldn't be behind a root bridge?
Yes, you can do that as well. Okay. This is a generic one.
Okay.
Yeah. Only thing what we have not done something similar to other architecture is this reserved memory regions, because we don't have. I mean, one of the thing for ratification is the POC. We couldn't do that POC, so we kept it for next future release if required. If such hardware comes up and require such thing. Okay. If no questions,
Could you expand a little bit on that reserved memory regions that was not being implemented?
Yeah. So if you look at the IORT or sorry, I heard some echo. There is apart from PCI something similar to PCI root complex. I'm hearing my own voice. PCI and platform devices, there is something called reserved memory regions, which typically used by some controllers, which need to be basically identity mapped and excluded from the UEFI region. So such requirement for such devices or controllers, there is a special node or a special, apart from PCI and platform device node, there is a special node in IORT. That particular use case, doing a POC was tough. So I've not added whether that's a, I mean, even IORT mentions that recommends not to use that, but there are devices in the industry, but I don't know whether they will be supported in RISC-V or what is the use case. So once hardware, real hardware comes up and real platforms using that, probably we will have to add that in the future revisions.
Thanks.
Okay. If there are no questions, I'm done. Thank you very much.
I can go next. You need to align with the time, Palmer, or yeah, okay, continue.
I don't know. I think we're just kind of doing whatever. Yeah. Just go for it. Someone will eat all the time at some point. So.
Yeah, we can have earlier break, so that's good for you guys. So this is a proposal that we've been working on and discussing on RVA and ASWG forum. So to basically support MSI in ACPI without an APLIC. So I'll go over the details. So in ACPI, there's something, the interrupts are basically mapped or represented using GSIs. It's known as global system interrupts. It's an abstract, like a software construct or abstract construct, which maps the real interrupts into the ACPI namespace. Now, traditionally, it's always been IQs that are being mapped through GSIs, but spec says that say namespace, so you can map anything other interrupts such as like MSI as well. And how it is done with the platforms that has MSIs is there is always a IRQ to MSI bridge, because most of the platform has some bunch of wired interrupts as well apart from the MSIs, and then that bridge is what converts your GSI or like IRQs, wired IRQs to MSIs. And for RISC-V, it's APLIC, x86 is IPLIC, or RAM64 also like PLIC. So which does this one. Now in RISC-V, it's APLIC, which is a standard hardware specification. So we have driver for it, which converts the wired IRQ to MSIs with the existing hardware. But if a platform doesn't have any wired IRQs as such, and it wants to use GSIs, a platform doesn't have any wired IRQ as such, and then it has all MSI capable devices. So it can be built without a IRQ to MSI bridge, that like a centralized IRQ to MSI bridge. Then in that case, we will have two kinds of devices in that platform, right? Either there's a PCI devices, so then which is not dependent on APLIC. The PCI controller takes care of converting those any kind of MSIs, and then mapping those MSIs to whatever the interrupt the device is carrying. But there may be some other platform devices like MSI capable devices that wants to use ACPI GSI mechanism. So these are the devices which can be driven through ACPI drivers. So we don't need to necessarily write a new driver for it, right? So this is the problem we're trying to solve here, and to see that if the proposed solution is the proposed solution can be workable, or there are better solutions, or anything else one would like to understand from the broader community. So what happened is, as I explained, those wired interrupts represent the GSIs, and then every time there is a hierarchy affinity change, your MSI, the hierarchy to MSI bridge basically have callbacks, which converts those MSI target address, and then the MSI target address and data gets updated in that hierarchy to MSI bridge. Now, in absence of that hardware, if we want to drive the ACPI devices, we need something in the ACPI abstract, ACPI namespace that allows to do the same thing, that doesn't depend on the centralized IRQ to MSI bridge, something like APLIC, right? Now, as I said, there's two alternate solutions. One is you can write your custom driver and then use per device MSI domains, no issues. The other option is, if that device can be driven by the existing ACPI driver, everything should just work as it is with the existing ACPI framework. But the only problem is, how do we map those GSIs to MSIs? And there is no ACPI construct as such, as per my understanding. So the proposal what we came up with is a GSI to MSI bridge, which is a completely ACPI device, which describes bunch of system registers in the ACPI namespace that allows you to update the MSI configs whenever there is affinity change. Now it's completely contained in the DSDT table. So a platform can have as many as GSIs mapped through this. There is no, the register layout is pretty flexible. So we kept in mind that if it's going to be used, it's up to the platforms how they want to drive those. And remember, like in the hardware, those devices are MSI capable, right? So if we need to communicate the MSI target addresses to those devices. So the device expose a bunch of registers which you map through ACPI, and then whenever that affinity change, MSI config gets updated. Now, so since this is DSDT, it's scalable and you can map as many as GSIs you want. Currently, there is no MDT defined because that limits how many GSIs you can actually support. And also in RISC-V, there is no early probing. So you can, there's no early probing for these kind of platform devices. So we can anyways, MDT is not that useful. Now the draft proposal is linked here. Question?
Yeah. So I appreciate the willingness to come up with a generic solution, but you're trying to describe hardware that, in my experience, tends to be even weirder than you can possibly imagine. I mean, interrupt controllers is the epitome of shit. So trying to describe it, I mean, ACPI is supposed to give you a high-level abstraction of the platform, and really an abstraction. Here, you are actually going the other way around. You are trying to describe the tiny details of how an interrupt gets routed over a memory bus. And it seems to me that you are conflating two very different things that it aims for disaster. So on platforms I've had to deal with in the past, there were two options. One was describe everything, the platforms, literally interrupt controller specific description of how the rights are conveyed, whether they are translated or not, whether there's a device ID that drives the translation if you have an IOMMU in between, and eventually you get what you want. The other extreme is, and in my opinion slightly preferable, is that you describe you have virtual interrupt numbers, but they are set in firmware. That's all you expose. Your platform devices get configured by firmware. And so they get their doorbells, whether they are edge or level MSIs, and that's all you have to do. I mean, it gets abstracted away from the OS, and that's much more compatible with what ACPI tries to do.
Yes, so this is basically what trying to do with the second solution you proposed, like second solution you said, right? The only difference is we're trying to, instead of firmware setting it up, we're trying to let OSPM to manage it. And this is the layout that I was talking about. And to at least the mandatory ones is the MSI address low high data and enable one. So if the firmware, the question is if the firmware configures everything, what do we do when the affinity changes? Then we have to communicate to the firmware that, hey, affinity changed, and then you need to update your MSI target address. Correct?
But why would you have to change those things? Is that because, I don't know, I'm not familiar with the interrupt controllers on RISC-V, but do you have to retarget the doorbell when you do an affinity change?
Yes.
Yeah. Oh noes.
No,
oh noes.
The top level MSI The top level MSI controller is completely specific to each CPU.
Yeah, it's just like an x86.
So the MSI, yeah, basically what Samuel said, the MSIC, which is MSI controller, is hard specific. So when you assign an MSI, it's let's say CPU 0, and the CPU 0 can go offline. There is IRQ balance. You can affinity change that can happen, and your target MSI target address change to CPU 1 for whatever the MSI address is, and then you need to communicate that to the either if the platform firmware manages it, you try to communicate that to the firmware, or if it is managed by ACPI, what will happen is this GTMB driver, which acts as a abstracted JSON to MSI bridge, writes this MSI address low, high, and MSI data, and then that's how it gets communicated. That's how it gets updated in the device that actually fires those MSIs. So it's kind of those NBIs and NBIJ in the ARM64, but in the SoC, but instead of a separate driver that describes the hardware.
The MBI gen is very different. The MBI gen is entirely different because it doesn't even expose a doorbell at all because it's integrated in the ITS. So there's effectively no right. You don't observe the right transaction. You don't have to program it. You don't, and also more importantly, the ITS has a single doorbell and it's in charge of the routing. So you never update anything because the MBI gen is an actual RQ to MSI bridge, wire to MSI bridge rather. Here you end up having to reprogram basically the endpoint, and that's a very different prospect. So it seemed to me that what you have here is not so much a description of your of a bridge. It's actually a description of the endpoints, because that's what you are changing. So really what you want is don't lie about your topology. Expose it because you have to, but that really becomes a function of your endpoint and not of something in between, because that something doesn't really exist.
Yes, correct. So basically this entry is basically describing the endpoint that driving the MSIs. So we just call it a bridge because it's a ACPI. It's basically a table of bunch of devices configurations that drives that are MSI capable, and you can modify. You need to modify those devices to change where the MSIs are routed. So that was the reasoning behind calling it a bridge. Earlier it used to call something else, but yeah. So is there a better way to do this? If not, if you don't want to have extra hardware that routes converts those JSI or like wide interrupt to MSIs or JSI to MSIs. So the only reason here is we want to leverage the ACPI drivers, as I said, right? Like for power management, like the GED device or the GPIOs, all those can be directly reused without having platform-specific drivers, and then everything will just work as it is in ACPI. And if we plug this one as in IQ chip in the Linux subsystem, and then all the interrupts will be driven by this. All the MSIs that are dependent on that will be driven by this. So for example, this is what it will look like. So instead of, so APLIC MSI is the APLIC running in MSI mode, and then the POC is done basically with the GD device that we can switch to be MSI instead of wired, and then the GTMB becomes the IRQ chip for it. And the domain hierarchy look like this, where IMSIC, the root heart level interrupt controller, which is the parent domain, which is specific to the heart, and then the child domain node becomes this GTMB device, and then obviously then there is a device node. But if there are any other alternatives that we can approach in ACPI land, definitely we can try those. So we started with making it like RESPI specific, but then based on the feedback, realized that there may be some other interest to use it as a generic, and then future MSI capable platforms maybe use it, but that's why I wanted to understand if somebody has faced this problem in the past or there's a better solution for it. What do we do? Currently, it's under discussion within the ACPI working group. So it's pretty much we can change, like pretty much in a very early draft stage, and then can be changed based on the feedback.
And what did the ACPI people, the UFE forum people think about it?
So there is no outright, there is no alternative suggestion proposed or position as of now, but we had some concerns from the Windows folks as there was no MADT table. So we don't have MADT because in the RISC-V, everything is a platform device, so we don't do early probing, so we didn't need to have any MADT. But Windows folks were trying to understand if this can be fit in Windows model if there is a need, because because this is being proposed as a generic ACPI device. So we're still in discussion with that and with Microsoft folks, and then there's a meeting today. We'll see if they have any alternate solution or any other alternate proposals.
I think it's similar to the previous talk. It's to solve the platform driver or platform device with the MSI.
Yep.
And yeah. But the question is there really necessary to a platform driver that need a MSI?
Yes, like we have hardware for that. So it's what's necessary is whether those platform devices are driven through ACPI drivers or a vendor specific driver. So this is trying to solve the problem for the former, where the ACPI drivers are being used because all the ACPI driver knows is GSIs. So then they're driven through the GSIs, and then there is no GSI to MSI mapping without the bridge, as I mentioned.
Yeah. I would say mostly we use the platform driver with the device tree, but now you need it with the ACPI. Then you meet the problem. You need to mix them together. And this is similar to previous talk to find a solution to solve that. Is that right?
Yes. So this is a ACPI specific problem because those ACPI drivers rely on GSIs and then has already been developed. So those are like common drivers. Like for example, the GED device which drives the system reset system power button thing just work as it is for any platform that uses the GED device, given that there is a mapping from GSI to MSIs if it supports MSI, right? So that's the thing. Those are the devices we can, or GPIOs, like underscore GPE thing that we can use in ACPI directly. But we need a mechanism to map those. Either we add additional hardware, which basically the APLAC for in this instance, or this was one of the proposed solution which does a ACPI way of doing things.
Okay, thank you. And I think I would see the real hardware scenario and or real hardware have come out with this proposal, and I could understand more this scenario. Yeah, thank you.
And just to give you another, are there any other question, or yeah, go ahead, Samir.
Try to say handle as much as possible on the firmware side and hide all these details from the OS, because we're not sure we can enumerate all the quirkiness of the interrupt controller. How would the OS know what, like, IMSIC IRQ number, IMSIC local ID that the GSI virtual interrupt was associated with? Like that's like obviously like the affinity information and like the trigger, that can be all handled in firmware because firmware knows what the hardware looks like, and it knows when you take a CPU offline, so it can modify the affinity. But how do we know what MSIC local ID is used?
Need to be able to handle rebalancing. I mean, if you run RQ balance in user space, that will move interrupts around. So either you have a way in the kernel to actually act on those, which means go and reprogram the target doorbell in the endpoint, or you call to firmware to do it. I mean, either way, that you need to be able to honor that. It's not just a CPU on-off problem. Okay. But yeah, my main concern stands is that you are effectively here describing things that are, you're centralizing things that are actually distributed in the system, and all these are individual device properties that would be better represented together with the device. If they have to be represented at all, they would need to be represented with the device. Otherwise, you spread programming information all over the place, and I don't know how you manage that.
I mean, I think the use cases, you have something like, an existing device, like random example, in a 16550 UART, right? It's standard programming interface, uses a standard driver, but you have an MSI instead of a wired IRQ, so there's some extra register off to the side to configure that MSI. Like, is that part of the standard device, or is that just a separate device that's sort of like a single interrupt control, right?
I think you have a different device here. It has a different programming interface. It really has. It's not the same device.
Yeah.
You've literally glued something that writes to two sets of memory addresses for set and clear, because it's a level interrupt, and it really isn't the same device. You can represent it as your standard H250 plus a 1-bit interrupt controller. That's the way to represent it, but it really isn't the same thing.
Yeah, and what this is doing is using this ACPI, representation to represent that 1-bit interrupt controller, except that this allows you to do an arbitrarily many of them using a single ACPI device.
So to answer your question, this should not work with existing. If you pick up a 8250 IP from any vendor, right? But the device is to be separate. It can be compatible with 8250, but you need a device-specific mechanism or registers that converts it to MSI, or that should be MSI capable device, right? If the IRQ, the device itself is not MSI capable, obviously you can't have these registers. And then what we're trying to come up with these registers which are mandatory is MSI address low, high, and data and MSI enable. And then to extend level interrupts, we have something like MSI retriggers, which basically you can fire it as at the end of interrupt. And then you can also describe if a hardware requires, you can describe what kind of IRQ trigger type is, and then you describe it through this register also. You can configure that through these registers. The firmware or whoever building that ACPI table need to communicate that what should be the magic value for, let's say, enabling retriggering or describing what kind of trigger type. So at least these are the basic abstracts that are being commonly used. Obviously, we might have missed something because, as Mark said, we're trying to have a distributed interrupt controller across all the devices instead of a centralized one. So there may be some unknowns, and yeah.
Example,
This is for
one thing you might have missed is, say, an interrupt controller has a mask bit instead of an enable bit, right? You don't currently have a value there. So if that bit's inverted, how do you handle that?
Sorry, I couldn't hear the question.
Another thing, another question actually. Do you expect these transactions to be translated by an IOMMU? I mean, can you have translation
This,
in between?
there is, yeah, in this design, there is no capability. So that would be another area which we have not looked into. Just wanted to understand if it makes sense.
If
As of
this can be,
now, there is, it's not.
so if this can be translated, you need some kind of device identifier from the source device, because you need to be able to pick the correct set of translation. And I don't see that in
Yes.
the description.
Yes, it's a good point. We'll keep a note and more, investigate more.
Yeah, I think that was your earlier slide just said, this assumes that the next level interrupt controller is the platform's, closest to the CPU interrupt controller, which isn't the case if there's, IMU doing translation, or like, for example, if you wanted to actually use the APLIC as the target of the MSI, right? There would need to be some way to specify that if that was a use case that was supported.
Yeah, this assumes, like, I think I have it on the slide, right? So it assumes that the next parent level would be MSEC. So I don't know how we'll map the IMMU, and then have to think about it. So I'll keep a note, and then if not, we have to add it to the spec saying, hey, this one cannot be translated by the IMMU. Any other question? Okay. Just wanted to bring another point is, if anybody thinks this can be useful for any other platform or something like what Mark mentioned, the IMMU has to be how the it's translated by IMMU has to define. If anybody thinks that there's something else missing, please reach out. The proposal is available here. You can, it's a Google Doc, so you can pretty much comment anything on it. And I think that's it from my side, if there are no questions in the room. Yeah. Can switch to. So Deepak, you want to go? Is Deepak in the room?
Someone else is here?
That was Deepak.
Yeah, I think we're
Yeah.
done. Are we done?
Yes.
So Deepak
You're leaving?
wanted
See
to
ya.
discuss landing. Hey. So
Hi.
earlier we switched to Deepak's topic earlier so that we can have a longer time. I think we discussed the VDSO one, but didn't discuss the landing pad. So we have time, so you can go ahead and discuss. If somebody has opinion, otherwise people can go have their beer early.
Yeah, thank you, Atish. So, I think we spent some time on the VDSO, but I don't think we gave enough time to the label scheme problem that can occur. So I'm just going to reiterate the problem statement, and we can discuss on that. So as we earlier discussed that all the indirect branches, they can be tied to the target using a label value, and the label value is set up in X7 register as per ISA, which is T2. And at the target, the label is embedded into a landing pad instruction, and it is checked against X7. And if they mismatch, it will fault. It will create a software check exception, and this label scheme can be two ways. One is zero label scheme, in which there is no label checking. If the value 0 is encoded in the instruction, then even if there is a non-zero value in T2, it won't be. So label check is basically bypassed. This approach is simple and can be easily adopted, and I think BTI is pretty much same on ARM, and N branch on x86 is same. But the problem is it is a much coarser grained CFI, and from a call site you can reach any function granularity. The multi-label scheme is the one in which you can have a hash over the function signature and truncate that to 20-bit because ISA only allows 20-bit. And then you have a finer grained CFI using this to reach any target from to reach only the targets which have the same or similar function prototype. We have been discussing that we can implement this in an iterative manner where first implement a simple landing scheme and then later enable the multi-label scheme. But the problem with that approach is, can you go to the next slide, Tish? Yeah. So the problem that I wanted to bring up here is that if we do it in that manner, then we can even then we can't mix and match objects, the binary objects in the address space, and most likely packet managers and library managers are gonna just pick up only one. And the proposal that I'm basically trying to make here is that we go with only one labeling scheme, that being a multi-label scheme, and the reasons are basically saying that mix and match is not possible of these kind of objects, and another reason is landing pad, even though it's not a ZIMOPS instruction, it's a hint, comes from the hint space. In practice, it's going to be enabled in conjunction with shadow stack. So anyways, these binaries won't be running on the older CPUs. Yeah, questions?
The binaries can't run on older CPUs, but would it be more accurate to say that they can run just potentially quite slowly? I mean, we could just catch the traps and ignore them.
Yeah, I mean, catching the trap means that you either need some kernel support or you need to have signal handler.
So are we trying to define the labeling scheme for all of user space here, or like as a suggestion for everyone to use, or is this just for the VDSO that you're concerned about right now?
No, this is for all the user space, not the VDSO. So VDSO problem is with respect to ZIMOPS. This problem is with respect to all the user space.
Okay.
Because assume that you have.
Go ahead.
Assume that you have a binary object which was compiled with simple label scheme, which was LPAD 0. So, and if this binary calls into another binary, which is compiled with, let's say, multi-label scheme, then all the call sites in the first binary wouldn't be preparing the label for the indirect functions that are in the second binary. So the problem that I'm trying to highlight is that having multiple labeling schemes is basically not going to work.
But the VDSO, since that's what we have control over in the kernel build, doesn't make any indirect function calls outside of the VDSO, right? So as long as the landing pad scheme is usable in one direction from other things calling into the VDSO, it doesn't have to be compatible in the other direction. So if we just use 0 within the VDSO, would that work at possibly the cost of slightly weaker CFI?
For VDSO, it will work, but for other libraries in the address space, it won't work. So for VDSO, we can probably relax it and make sure that VDSO is not calling out into the other libraries indirectly.
You can't call some other shared library.
But for other libraries, it won't
you
work.
can't call some other shared library from the VDSO. That's not a thing. I don't know how you would go about doing such a thing.
Yeah.
Yeah.
Yeah. So that's not an issue. I think we can do that. You know, VDSO object can have help at 0, but we still have the problem where we have one SO which is compiled with different landing pad label, another SO which is compiled with different.
But at that point, they're basically just different ABIs. So if user space mixes together a bunch of different shared libraries with a bunch of different ABIs, then stuff will do whatever that does. Probably not something useful. Not a kernel bug.
Right, and that point of not a kernel bug, but at that point of time, LD will most likely disable the landing pad for the entire address space, because otherwise things will start faulting.
That's more useful than most mixed ABI links, so seems fine.
Yeah.
I mean, the other option is to just start crashing, right? So.
Right. So.
If we are using dynamic patching style of the landing pad, then it is possible to change it to more a simpler landing pad scheme by like using a procfs. Don't know if that makes sense.
How? If I have a SO1 which was compiled with simple landing scheme, then all the call sites are not going to prepare a label. And if this library A had interaction with library B, assume there was a API in which it was basically doing some callbacks into library B. Then library A call sites, whenever it is indirectly calling into library B, they are all not preparing the label, but on the target you have the label.
In that case, I think it would be the issue for loader. They has to load libraries that are compatible.
Yeah, I mean, isn't the whole
Right,
point of CFI that if you mix up the labels and the call sites, that things don't keep running, they just crash? So, it seems like a feature.
Yes.
Right? I don't pay ton attention to CFI though, so I don't know.
Right, so it'll crash, or loader will just say that I have mixed objects and I'm not gonna enable CFI on this address space because it's better to run something rather than worry about I'm going to be hijacked.
I guess the thought here is that we're only concerned with the VDSO because everything else is user space's problem.
Yeah, also seems like not a kernel bug, right? So yeah, I don't know.
Yeah.
Though
it's definitely not a kernel issue.
To the suggestion of patching the VDSO, which I think definitely could work, I'm just maybe there's some concern about the fact that if you do that and like it's configurable at runtime, you might need multiple copies of the VDSO in memory, and like not all processes would have the same VDSO mapped into them. So, because you couldn't like have a single one and just change it back and forth every time you context switched, of course. So like I don't know what the overhead of that, or whether there's infrastructure in the kernel to map a different VDSO into different processes.
Yeah, I mean, we like sort of have compat VDSO for a different ABI. It's kind of mushy to call that a different ABI because it's just a different ISA. But it just seems like overly complicated for you're just protecting VDSO calls from function. CFI like aliasing.
No, we don't. No, we don't have to switch VDSOs between different processes. We just pick one and we go with it. And the reason is, you boot, if you see that Zimops is available, you just expose the VDSO which has Zimops instructions in it, and you expose it to the user space. User space can decide that whether it wants to enable CFI instructions for itself. If it enables, it's going to leverage that. If it doesn't enable, it's just Zimops instruction, which is not doing anything. So you don't break anything. So you don't have to have multiple VDSOs per task. Does it make sense?
ABIs with the complex versus simple labels, right? Yeah.
Right. Even in case of like, complex versus simple label, as long as it is not enabled, it's not gonna do any harm. The only thing is, if you have more than one labeling scheme for the user space, then it's as good as disabled, because multiple libraries will start building with different labeling scheme. And again, it's not a kernel thing. It's a user space thing. But this being a RISC-V MC, I thought I'll bring that up if people have different opinions or solutions.
Yeah, I think
on
then
this
we're back to
aspect
this
of
just being
problem.
different function call ABIs effectively, right? Because if you're doing the hash the function signature, get the landing pad ID type thing, then that's part of the ABI effectively, right? If it's always 0, that's a different ABI. You can't link shared objects with different ABIs. Stuff will blow up. So, right?
Yeah.
So either they both need to be the same ABI, and there's some way you look inside the shared objects and figure out which subflavor of ABI you're looking at, some sort of overloady type thing going on, or stuff just crashes when you mix ABIs, just like it would anywhere else. So, right? I don't think there's anything different.
I think we're done.
Yeah, I think there's no more questions unless you guys have stuff to talk about. Cool. All right. So thanks, everyone. I think we're done, unless I forgot about a speaker.
Yeah, you're done.
Good. We're done then. Cool. All right. Yeah. So.
There's a boss scheduled tomorrow.
Yeah, there is.
Announcement, so.
Does anyone remember when?
So there's like 12:45, if I'm reading the time zones correctly, which is 3:45 a.m. for me. So I'll probably miss that one. See if I can wake up. But yeah, anybody else interested, please join. I shared the details in the IRC channel.
All right. Thanks, guys. Bye.
Yeah. Bye.
Sure, yeah. What's up?
I'm very interested. And it's for dealing with the
Yeah, just get a slightly weaker security enforcement. That seems pretty straightforward. I don't do CFI stuff, so Deepak doing CFI stuff. So maybe I don't know. In that case, but yeah, that seems like excessively more. That's the thing is with CF, it's like very hard to tell what's where in any of these specs. So maybe they changed something, I don't know. Yeah, I've been paying like not a. It's more of like a linker, user space linker type thing. I've been kind of staying out of the label allocation thing. It's very contentious. Out of it. Does that make sense? It's like whatever. I don't really the simpler forms that get turned on.
Categories, right?
Doesn't even matter.
Yeah, that's why I'm really excited to
you'll basically get the that's pretty easy. And all these more complicated things with per page new method stuff.
Uncapping.
That's because there's too many things going on. So, yeah. So my understanding is that the simpler schemes are going to be all that anybody ever uses, and that any worries about the more complicated schemes are just kind of, whatever. That's kind of where I am. If that makes sense. And that's kind of like putting my linker person in the same spot where it's like, that's it, right? Like, and the simple schemes are easy, those are manageable, they fit into the way people build systems, and all this more complicated stuff where like we mark per function or per page or whatever of CFI enforcing or whatnot, it's just kind of whatever. If they wanted this back, I'm like, we'll never turn it on. Yeah, cool, yeah.